Hello everyone, have you guys ever heard of the term DevOps? I bet you did. It is one of the most lucrative fields in the sector of software development. According to Glassdoor, an average DevOps engineer 100 compensation band could grow more than the whopping amount of $200,000. I think these numbers are quite enticing, and this domain itself is an amazing blend of philosophy, technology and management. So if your goal is to build a lucrative and technically challenging career, then DevOps is the highway to go. That being said, I welcome you all to this extensive session on DevOps by Intellipaat YouTube channel. But before we take a deep dive into its technical concepts, make sure to enable that subscribe button and the bell icon so that you never miss any update from us. First of all, we shall look into the agenda for this session. So we will begin this session on a friendly note by getting introduced to the term DevOps. Next, we shall look into SDLC models, and after done with that, we will take a deep dive and understand how DevOps works, what is a version control system, and different DevOps tools. Next up, we shall list difference between the distributed version control system and centralized version control system. Later, we will cover introduction to Git, GIT Lifecycle, concepts of merge conflicts, and version control with Git. Once we are done with that, we shall discover common Git commands and shall also iterate through Maven build lifecycle. Towards the end of this session, we shall cover some of the most commonly asked DevOps interview questions with sample answers. I hope I have made myself clear with the agenda, so without wasting any time, let's get started with the session.
The word DevOps is a combination of the terms development and operations, meant to represent a collaborative or shared approach to the tasks performed by a company's application development and IT operations teams. Let's assume that Gary is a DevOps engineer working for Instagram. His job is to collaborate with different teams and make sure the DevOps pipeline is running smoothly to release frequent updates. Before Gary, Instagram used to create and release updates after every 2 months. But when Gary joined as the DevOps engineer, the plan was to release updates every 3 days to keep the users happy. Now users are more happy as they can use new features on a daily basis and get what they ask for due to the faster release cycle. DevOps teams use various tools to automate and accelerate processes, which helps to increase reliability. A DevOps toolchain helps teams tackle important DevOps fundamentals and go through its phases including continuous integration, continuous delivery, automation, and collaboration. Teams use various DevOps tools to help them facilitate a DevOps culture in their organization. Most teams rely on specific tools for their pipelines, building custom toolchains that fit their needs for each phase in the application lifecycle. DevOps Cloud teams use tools like Docker, Selenium, Jenkins, and Kubernetes. These are just a few tools amidst an array of DevOps tools. DevOps influences the application lifecycle throughout its plan, develop, deliver, and operate phases. Each phase relies on the other, and the phases are not role-specific. Plan. In the plan phase, DevOps teams ideate, define, and describe features and capabilities of the applications and systems they are building. They track progress at low and high levels of granularity, from single product tasks to tasks that span portfolios of multiple products. Develop. The develop phase includes all aspects of coding, writing, testing, reviewing, and the integration of code by team members, as well as building that code into build artifacts that can be deployed into various environments. DevOps teams seek to innovate rapidly without sacrificing quality, stability, and productivity. Deliver. Delivery is the process of deploying applications into production environments in a consistent and reliable way. The delivery phase also includes deploying and configuring the fully governed foundational infrastructure that makes up those environments. Operate. The operating phase involves maintaining, monitoring, and troubleshooting applications in production environments. In adopting DevOps practices, teams work to ensure system reliability, high availability, and aim for zero downtime while reinforcing security and governance. Professionals can become a DevOps engineer coming from different backgrounds. A DevOps engineer should have various skills and they can't just be DevOps tools. Let's have a quick look at the other skills a DevOps engineer should have. A DevOps engineer should have one high-level programming language like Java, C++ or C#. Should also know Linux, SQL, cloud technologies like AWS, Azure or GCP, scripting languages like Perl, Bash or Python. On an average basis, DevOps engineer earns 5 lakhs per annum to 14 lakhs per annum in India, while in the USA, a DevOps engineer earns from $125,000 per year.
Now it is a proper things it is written there. What's the tasks we need to do it? So for your better understanding, what I am going to do, firstly let me read it within just a 1 minute, and with the help of proper diagram, with the help of proper architecture, I will show you what's the tasks and how we can perform this project. Okay, so let me quick having one read here. Like first thing, it is saying that you are hired as a senior DevOps engineer in DevOps software, okay, and they want to implement DevOps Lifecycle in the company. You are implementing this cycle, okay, fine. There is a one link, it is given there. We need to use that link. Inside this link, we have all the file that we are going to use that. How we are going to use that, we will look at this, okay. So first is saying that Git workflow has been implemented, fine.
Let's have a quick quiz question, guys, and the question is, identify the tools for DevOps, and your options are Monit, Nagios, Jenkins, or all of the above. Please mention your answers in the comment section below.
It's saying cold bin is automatically triggered once the commit is missed to the master branch develop branch. Okay, commit test post, it is fine. Code should be continuous with the help of Docker file every time. Okay, now I just got to know. No, okay, so let me tell you what's the tasks you need to perform here with the help of proper diagram. Okay, so now see my screen carefully. Now I will explain you what's the tasks we are going to perform inside this project number 1. Okay, how we can move it. So firstly, as you can see in the project, we have the one GitHub repo. Let me write here. GitHub repo. GitHub repository there, as you can see in the project as well. At the top, this is that GitHub repo. Okay, now it is saying in the project that we need to create a 3 new EC2 instance here. Let me show you. It is saying we need to create the 3 EC2 instance here. First instance name as the master. Let's control the whole thing. So let me write the name here. And just a minute, let me firstly draw it. This is my second instance, and this is my third instance. And this instance name we are giving the test. Like the yesterday, we are giving our instance name test and the prod. Same name we need to give. So guys, the capstone project number 1 is basically 50% exactly, not exactly, almost the same of the Jenkins assignment, 50%. Okay, so we have the one GitHub repo. Okay, we need to clone that repository to the master. To this branch, we need to clone it, this repository. We need to firstly clone it. After that, we need to install the following tools of the DevOps here. Let me write it first. Then I will explain why we are installing this one. Firstly, we need to install Ansible. Why Ansible? Just a minute, let me tell you. Ansible. After that, we need to install the Jenkins in it. As we know, for the Jenkins, we need to install Java as well. So here we need to install Java also. And here we need to install Docker also. So in the my master EC2 instance, we need to install the 4 tools like Ansible, Jenkins, Java, as well as the Docker. And now in the test, we need to install the 2 things, Java as well as the Docker. Why the Java as well as Docker? Let me tell you. Let me first write it. Java and the Docker. We need to install it, as well as in the prod, we need to install Java as well as the Docker. Now first the task one need to do, we have the one repo, as you can see in the project. This is the repo. We need to clone the data, whatever it is there, to my master instance. Okay, and we need to install Ansible. Why we are installing the Ansible? Because we are making the 3 connection here. So how you can making the cluster, connection between the master, test, and the prod by using the Ansible. So by ping it, I hope you guys know the Ansible concept, how to ping it. Okay, so here we are going to make the cluster. That's why we are installing the Ansible in the master. Okay, now second things, we need to install Jenkins. Okay, so why installing the Jenkins? Because let me tell you first, because here we need to create a 3 pipeline. Let me first write it. Sorry. We need to create a 3 job here. 2 job in the test. Let me write job 1. Here it is saying it should run with Docker file on develop branch, like as you guys know. Okay, now the job 2, it should run again with Docker, but on master branch. Okay, now the job 3 we need to build in my prod instance. With the help of prod instance, here we need to build the job 3. What is inside the job 3? It is saying that firstly we need to create a normal job. Okay, and it is saying that whatever the job, now firstly see the question. Where is the question? Yeah, see, code build, see the second line, code build should automatically trigger once commit is made to the master branch or the develop branch. If commit is made to the master, then test and product. That means we here need to finally publishing the job. That is fine. Let me firstly write it.
Just a quick info guys, if you want to make a career in cloud computing, then Intellipaat provides an advanced certification on cloud and DevOps by IIT Madras. This course is taught by industry experts and IIT Madras faculty. This course is designed to upskill and land your dream job. Now let's continue with the session.
Publishing the job. Okay. So here again, like the yesterday we discussed, we need to give the dependency here. Like till my job 2 is not running, that my finally job 3 will not be published, or we can say the triggering. So here we need to give the dependency like between the job 2 and job 3. Unless my job 2 will not be successfully run, my job 3 will not be triggered. So here, as I said, why we are installing the Ansible? Because we have to make the connection between the master, test, as well as the prod. First thing is that. Second thing is why we are installing the Jenkins, because here we need to create a 3 pipeline, job 1, job 2, job 3. And after that, as you know, that Jenkins need Java, so that's why we are installing the Java in it. Now, while installing the Docker, so as you can see, I written there, it should run with the Docker file. So for the Docker, we need to for the making the Docker file, we need to install Docker in it. So that's why we are installing the Docker in the master. Okay, so why here the Java Docker has been installed? Because as we know, once we are logged into Jenkins dashboard, we need to connect my test and prod there. Okay, so that's why we are installing the Java in it. And the Docker, why the Docker? Because my job 1 will be triggered with the Docker file. That's why we are installing the Docker in the test as well as the prod. So this is the whole implementation we need to done here. Yeah, develop branch, we have to made it like the previously, like see here in the question, it has been mentioning there. If commit is made to the develop branch, just test the prod, do not push it. So here, like the yesterday, we had nothing will be mentioning there. So that's why we are simply make the 2 pipeline that is mentioning in our project. that firstly, we need to trigger a first job with the help of develop and second job with the help of master. Again, okay, I'm going to explain you. This is a repo. Let me open this repo. You will see two files has been there. We need to use these two files. Okay, so firstly, we need to clone this to my master. Okay, after that, we need to install the Ansible. Why we are installing the Ansible? Because we have to make the cluster between the master, between my test, between my prod. Okay, now why we are installing the Jenkins? Because here we need to create the three jobs. Job 1, job 2, job 3, and for making it in the Jenkins dashboard, we need to install the Jenkins in it. Okay, now why we are installing the Java? So as we know, each and everything on the Jenkins work on the Java, so that's why we are installing the Java in it. Okay, now last is why we are installing the Docker, because here it is saying it should run with the Docker file. Yesterday what we have discussed, like yesterday on the Jenkins assignment, we have discussed that we are creating the pipeline on the develop branch. That is simple. But here there's a little bit we can do changes, that we need to create a job with the Docker file. How we are creating the Docker file, we will explain you. I will explain you when we are creating the job for your better understanding. So that's why we are installing the Docker, because we need to trigger a pipeline with the help of Docker. Okay, now in the test, why we need to install the Java as well as the Docker? Because Java for making the connection to the Jenkins dashboard of my test and the prod, like the yesterday we did. Okay, now why the Docker? Because we need to trigger a pipeline with the Docker file. That's why we are installing the Docker. Okay, now same as the prod. So now it is clear. It would be very easy when we are implementing this thing. There's a little bit lengthy project because we need to install the multiple software in it. So firstly, I am going to make the master instance. Okay, now guys, listen to me carefully. Now firstly, let me go to the AWS. I am following the same implementation with the help of this diagram for your better understanding. Each and everything I will follow one by one. Okay, firstly, let me go log into my AWS account. Just a minute. Yeah, now go inside the instance and let me launch my firstly the master instance. Now guys, remember I am launching the master instance, but let me first light it. Master, I'm giving the instance name master. Okay, I'm using the Ubuntu and the Ubuntu 20. Now see guys, instance time I am using the T2.medium. Why I am using this? Because as you can see in the diagram, that we need to install the 4 tools here: Ansible, Jenkins, Java, Docker. For the smooth running it, I am using the T2.medium because it has the more memory, 2 CPU. If you want, you can use the T2.medium, but it is fine for the T2.micro. You can use the T2.micro as well. But why I'm using the T2.micro? So that because I need to show you how it is running. So it will run smooth way. It will run on the faster. Okay, that's why I'm using T2.medium for better performance. You can use the T2.micro, but it will take little bit more time as compared to taking the T2.medium. Okay, so let me selecting my key pair as well as the security group. Click on launch instance. Yeah, so this is my master. Let me connect this to my Movextrom. You can use the putty or directly connect to AWS, doesn't matter. Okay, let me few up this, delete this quickly. Okay, click on the sessions. Let me change the tab name. This is my master. Yeah, let me increase the font size and let me firstly update this. Sudo apt get update, or you can simply write sudo apt update. Yeah. Okay, so see the diagram. Firstly, we need to install the Ansible in it. Okay, so for the installing the Ansible, I am directly get the Google for the command, and let me copy this, the link, and paste you the link of the Ansible here. Yeah, so I already updated. Let me copy the second command. This is the properties of the Ansible packages. Yeah, and next we have the package of the Ansible that install my Ansible in it. That download the Ansible, not the install. After that, last is sudo apt install Ansible. So let me write it sudo apt get. It's a get or what? Let me check. Apt install only. Yeah, so this will install the Ansible in it. Like you see the diagram, let me launch my two more instance. First by the name of test and second by the name of prod. So let me go to my AWS again and launching my new two instance. Here I am creating the both instance simultaneously. I am writing number of instance 2 here. Okay. And I am giving the test first. Ubuntu. And the Ubuntu 20. Yeah. This time t2.micro is fine because as you can see in the diagram, we need to only install the two things here in the test as well as the prod. So t2.micro is fine. It will work fine. So I am not changing to the t2.medium here. I am selecting my key pair. Let me selecting the security group and launch the instance. Click on view all instance. Let me refresh this. Let me change one of the name. Second one is my prod. This is my prod. And first one is our test. Let me connect it both test my prod into my MoveX room. You write Ubuntu. Where is my PAM file here? Let me change the tab name. This is my test instance. Let me increase the font size and let me update this sudo apt update. And let me quickly connect it to my prod as well. Copy the public IP and let me quick make the connection. This is my prod. Sorry, we need to write here Ubuntu. And this is my prod. Let me change the tab name. This is my prod. Increase the size and let me update this. Sudo apt update. We are just make the three instance master test as well as the prod. We are installing the Ansible. Okay. Now, firstly, the most important task we are going to do now. We have to make the connection between the master to the test to the prod between the three of my instance with the help of Ansible SH method. Okay, so let me go to the master and let me generate the SH key. Just a minute. Okay, hold on. Hold on. Let me connect it to the master as well. Master is disconnecting here. Yeah. That is the font size. It is already updated. Yeah, so my instance is ready. Now I'm going to make the cluster. So for that, we need to do the sh keys in here. So let us generate our sh key first. sh hyphen keys and pressing the enter. It will ask enter the file, press enter again, enter again. Yeah. So now see this line. It is saying your public key has been saved in this location. So we need to go inside this location. Let's copy this location. Okay, inside this location, we have our sh key that help us to make the connection. So let me write here sudo cat and paste it that location so that it will throw the key. Yeah, you will see this is my key. So let's copy this key. Yeah, now go inside my test. Go inside the sh cd.sh. If you do the ls, you will see the authorized key files will be there. So let us open this file. Sudo nano authorized key, the file name. Yeah. So this is a by default sh key. Below from this, pasted the new key. Yeah. Now Control S to save, Control X to exit out. Now do the similar tasks in the prod as well. Go inside the cd.sh, do the ls, and open this file authorized key. Sudo nano authorized keys. Yeah, and here pasted the key again. Control S to save, Control X to exit out. Okay, now go back to master. Now let us go inside my Ansible folder, like cd /etc, sorry, etc /Ansible. Okay, what is show me? There is a no Ansible is installed or not. Let me check the Ansible location. Yeah, Ansible is there. Yeah, so if we do the ls, you will see the host file will be there. Let's go inside this host file. For making the connection, sudo nano host. Now these are the command. There is no need. Let's delete this all the command. By pressing Ctrl K, it will be deleted. Now here I am writing my instance name test. Yeah, and for making the connection, what we have discussed yesterday, like use always the private one, not the public. Okay, so here I am pasting the IP of my test, private IP of my test, and below from this I am writing the prod and the prod private IP. Let's save this and exit out. Okay, now we are done it. Let us check that connection to my both of the three instance has been made successfully or not. So let us ping it Ansible -am ping all. So it is in, do you want to continue? We need to write yes. First one is working fine. Write the yes again. Yeah, second one is working fine. So you will see success. That means connection to my test as well as the prod to the master has been successfully made. So are you getting the point, guys? These basic things in the Ansible you already learned. Yeah, so we are making the cluster by the help of Ansible. Okay, now listen to me carefully. As you can see, I will tell you one shortcut method. Okay, as you can see, we need to install the more things like Jenkins, Java, Docker, Java and Docker, and Java, Docker, and everyone. So what I am going to do here now, okay, now listen to me what I'm trying to say, that we have the one method that simply just copy pasting all the installation command one by one. This is the one method. Okay, as we could not simply go to the master and install the Jenkins, Java and Docker, that is remain. That is a one method. Okay, and as well as in the test, simply by the command installing the Java and Docker, that is fine. Okay, but there was one more method if we want to install the things in a proper way, like it will looks good with the help of YAML file. So what I am going to do now, I am just making one YAML file. Inside the YAML file, I am giving the tasks, like in the master, I am going to install Jenkins, Java, Docker, and the test Java, Docker, as well as the prod. So in that YAML file, I am going to give the tasks that I am installing these things. And I am also giving the package name there. Okay, so that when I create that YAML file without downloading, installing one by one, when I simply run that YAML file, play that YAML file, each and everything will be installed. That makes our task little bit easier, or it is looks good. If we need to install the multiple software, or we can say multiple things on a particular instance or the multiple instance. Let me show you for your better understanding. Okay, so let me go to the master. Here I am going to make one file, one YAML file, sudo nano, and the file name, suppose I am giving install.yaml. So now listen to me, I am going to make the YAML file. Okay, I think I have the YAML file. Okay, let me copy pasting it and let me explain you one by one. Okay, I think I have the YAML file. Because yesterday I take the session of the project. Yeah, this is the content. Let me explain you. Let me copy it. Now listen to me carefully now. Okay, so when, as you guys remember in the Ansible, okay, when we are making any YAML playbook file, we need to give the syntax like it will start for the dash. These things you know. Okay, so first we are mentioning the host. Host means that where it going to be run. Okay, now what is the use of become? Can anybody know what is the use of become here? That if we want to get the admin access, or we can say the root exit, then you need to write the sudo as a prefix, or simply write sudo se. Okay, but how to get the admin privilege in the YAML file? So with the help of become. So I am writing become to get the privilege. Okay, and now as you can see, I am giving the name install Jenkins, Java, Docker. Now see in the diagram, we are installing Jenkins, Java, Docker in the master. So I am giving the name here, installing Jenkins, Java and Docker in the master task on my master instance. In the task season, I just defined that I am going to install Jenkins, Java and the Docker as per this diagram on the master instance. Okay, now after that, see the script. In the script, I am mentioning one file name that is called jenkins.sh. So after this, I am going to make one file. Inside this file, I am giving the command of the installation of these three. So in the script, what is meaning of the script is that it will take the installation command from the jenkins.sh and the fetch them and install that. I will show you what I understanding. Let me first explain the whole YAML file. So this is the task for my master. Okay. Now, as you can see in the test, I need to install Java and the Docker. So see here, this is the host called test. We are giving the test and become to get the admin access. Now in the name, I just mentioning install Java as well as the Docker. as you can see, we need to install Java as well as the Docker as per the diagram in the test. So I'm naming the same. And in the task, I mentioned it is the task of my test instance. It is a task of my test instance. Okay. Now in the script, I'm mentioning the one more file name docker.sh. So inside this file, I am going to create it. I am going to give the command of this one. Okay. So that's why I'm mentioning one file name here. So it will fetch the data. Now similarly for the prod, giving the host name prod, install Java and the Docker as per the diagram. Install Java as well as the Docker as per the diagram. Okay. Now in the script, we are giving the file name docker.sh. So now let me show you by making, as you can see, I am after this YAML file, I am going to create two more files, jenkins.sh as well as the docker.sh. Okay. So inside this, I am giving the package name. I am give the installation command of the following tasks. So let me first save this and exit out. Okay. Now, firstly, let us make our what? If we see the ls, you will see install.yaml file is there. Okay. Now let us make our jenkins.sh file. Sudo nano jenkins.sh. So guys, here I need to give the installation command of the Jenkins, Java and the Docker. Okay, so let me give it. Jenkins, again, I am getting it from the Google. I've sent you the directly. So I am writing here Jenkins installation. Yeah, Linux, Debian in Ubuntu. This is the all command. So instead of copy pasting it, I just copy all the command and put it there. This is the command of the Jenkins. So I am need to add the two more command for the installation of the Java as well as the Docker. So I am adding the two more command here. Okay. Sudo apt-get install openjdk -11 -jdk-y. This is a command for installation of the Java. And let me give the Docker installation command as well. Sudo apt-get install docker.io -y. And I'm also writing -y here itself. Yeah. So let me save this and exit out. So we are make one file. Let's remaining the file that is last one docker.sh. Sudo nano docker.sh. Inside this, I only need to give the installation command of the Java as well as the Docker. Only two commands we need to give. So let me write it quickly here. So let me firstly give the refreshing command sudo apt-get update. After that, let me give the Java installation command sudo apt-get install openjdk -11 -jdk-y. Sudo apt-get install docker.io -y. Okay. Let's Ctrl+S to save and Ctrl+X to exit out. So we have done with all the installation. Okay. So it's not time to build our YAML file so that all the installation part would be done in just a 2 minutes. Okay. So before that, let me check the connection. Let me try to ping it again. Ansible -m ping all. Let me check the connection. Yeah, connection is perfectly fine. So let us create our YAML file. Ansible playbook and the file name install.yaml. What is the file name I gave? Let me check. Hold on. ls. File name is install.yaml. Yeah. So let me write Ansible -playbook install.yaml. And let us do the syntax check. Syntax check means it will check if there is any syntax error in the YAML file. So there was a command -syntax -check. This command is basically check any syntax error is there or not inside our YAML file. So if we are writing this, it will show nothing will it. So let us give the command to install the YAML file. So this will install my, let us press enter, and it will take time. It will take time, depends firstly on the internet connectivity or the performance of your instance. That's why I'm using the T2.medium. Okay. So as you can see, it has been done. So let us check it. So as you can see, it is done. Let us check. Now see here, it is 3. It has been installed in the master or not. So let us check it one by one. Let us check the Java version. Java -- version. Java is there. Let us check the Docker version -- version. It is there. Yeah. So let us check the location of the Jenkins. Yeah, it is there. Let us clear the screen. And let us check for the test as well. Here we need to install the Java as well as the Docker. Okay. So let me check Java has been there or not. Java -- version. Yeah, it has been there. Let me check for the Docker as well. Docker -- version. Yeah. And let me check for the prod as well. Same things. Java -- version is there. Yeah. And let us check the Docker version is there. Docker -- version. Each and everything would be installed. So till now, see the diagram, guys. What we have done till now, we have made the 3 instance, master, test, and prod. We are done with the installation of these 4 all, and these two. And we are also done with the making the cluster between them. Now the task is remaining that we need to go inside the Jenkins and firstly make the connection to the test and the prod to the Jenkins dashboard and creating the 3 pipeline. That's the task we are remaining now. So let us open our Jenkins dashboard. Okay. So go to the instance. Yeah. Go to the master. Copy the public IP and open it till 8080. That's the port number of the Jenkins. Let us unlocking our Jenkins. Yeah. So copy this password. Sorry, copy this location and go inside our master in which we are installing the Jenkins. And let us paste it here. Let me paste it. Let me come out. Sudo cat and paste it at location. It will throw the password. Let's copy this password and paste it there to unlock our Jenkins and click on continue. Click on install suggested plugins. Yeah, so it will unlocking my Jenkins. So let's wait for the another 10 to 20 seconds so that we are unlocking our Jenkins there. Okay. I see here. Previously, before I writing the CD, I am inside my etc or Ansible folder. But when I give the CD's command is basically come out each and every folder in the just a one way. So that's why I'm coming out from each and every folder just a CD command. Yeah, change directory stands for. Okay. So let me set the username as well as the password. Admin or any name you can give. Let me set the password as well. Let me write the Ritik, my username, and any valid email ID you need to select here. Save and finish. Start using Jenkins. But it CD. Yeah, C. You guys remember the Linux? So in the Linux, as you can remember, if you want to go one step back, then you need to write cd space ... That is for the one step back. And there's a one more command called cd. If you are writing only cd, nothing ... nothing name, then it will throw you from the any other directory to your home directory. Okay. So guys, I think you are just forget the basic command of the Linux. no worry. So cd command, as you can see in my screen again. Okay. Before writing the cd command, you can see I am inside my etc folder. That is, I am inside my Ansible folder. That is inside my etc. So when I write the cd, you will see nothing will it commit left hand side of this symbol. So that means I am just come out from that symbol. I am come out from that repo. I am come out from that directory. Okay. The cd command is basically come out from each and every directory. Yeah, fine. So this is the Jenkins dashboard. Okay. Now guys, as you remember, you forget one thing, that we have the one repo. We have not till clone it to the master. Is it? We just forget it. So let's firstly clone this. So let me open that repo. Is that project? Yeah. This is that repo. Let me fork this. And let me click on create a fork. Okay, so this is my repo. Let us clone it. So let me copy this link of this repository and let me go inside my master. This is my master. Okay, so let me clone this. So what is the command to clone it? What is a git command to clone it? If you guys remember, what is the command to clone it? Yeah, exactly, git clone and that repo. So let me write it, git clone and that repository link. So as you can see, cloning has been started. So if we do the ls, you will see website is there, website name of the repository is there. Let us go inside this cd website and do the ls. You will see both of the file that has been inside the repo. It is now here. Okay. Now, as you guys remember that we need to build the job with the help of Docker file, but still we have not created the Docker file. So let us firstly create the Docker file. So that why I'm creating the Docker file, because it will do my two tasks. First task is what? That for making my job, we need to create the Docker file. That is fine. Second task is that I should creating my master branch as well as a develop branch with the help of that Docker file. Yeah, fork is basically, yeah, let me tell you, see what is happening. See, as mentioned in the project, we need to use that repo. First thing is that, so fork meaning is it says the imaginary repository. So you have the two options. Either the link that is mentioned in the project, you can simply copy this to your repository, make the repository, or you can simply fork. Fork means it just make the imaginary repository to your GitHub account. Why? What is the use of that imaginary repository? Like suppose if you are doing some brick project, if you are working as a professional, and let's take a simple example. Okay, if you are working as a professional, so for doing any tasks, your manager is giving you the link in which you have the files that you need to use it in any particular project. Okay, so by doing it, you can simply, what you do, you can simply attach to your GitHub and clone it. Now what happens if you are by mistake doing some mistake inside the project? Okay, so in that case you have not do anything, because what happened when you clone it by making the repo, then it will you cannot go back. Now fork means that when you are making any imaginary repository, you can delete anytime. That means that if your project is successful, then make this fork as your permanent repository, and otherwise delete this. It has no use. Once you make this permanent repository, clone it, then you are not going to do any changes further. So what is the benefit of using the fork? That we can do the any changes depends upon your any requirement anytime. Now, I hope this time is clear to you. Is it? Now it is clear, Miraj? Okay. Yeah, so what we are going to do, yeah, let us create the Docker file in it. Okay, so let me create the Docker file, sudo nano and the Docker file. Yeah, so I have the, I think, the Docker file. I will share you all the content. Don't worry regarding the Docker file, whatever it is. Okay, so let me paste it here. Yeah, same content is there in the Docker file, same, nothing will it. So let me save this, exit out. Okay, so now let us see the git status of this Docker file. You will see it has been untracked. So let us track this by the git add command, git add dot or the name of the file, it is fine. Once it has been tracked, we need to commit this. Let us commit this git commit -m and any message. Suppose I am writing adding Docker file. Anything you can write there, it doesn't matter. Yeah, so once you have made the commit, your default branch, that is your master, would be created. Master is created. Okay, but as per the diagram, we need to create the first job on the develop branch. Okay, so let us create our develop branch here. Simply git branch and the develop. Yeah, so if we check the git branch, we have now the two branch develop as well as the master. Okay, yeah. So now what I am going to do, let us go to the Jenkins and make the connection to test as well as the prod to my Jenkins dashboard. Let us go to the Jenkins now. Yeah, start using Jenkins, go inside the manage Jenkins. Before that, let me check the one thing here. Configuration, global security. The agent. Yeah, let me select it. Random. Click on apply. Click on save. Yeah. So now let us make the connection. Manage nodes and cloud. This is my master. So let's connect my other instance test as well as a prod to my this instance. Okay. So hold on. Yeah. So let us click on the new node. Similar tasks as we did the yesterday for making the connection. Okay. Yeah. So I am giving the instance name test. Okay. And click on the permanent agent, click on the create. In the remote root directory, write the location of the Jenkins /home /Ubuntu /Jenkins. Same tasks we did the yesterday, nothing changed. Yeah. Launch method launch by the sh. And in the host, again writing the private IP of that particular instance for the better running in the future. So copy the private one and paste it there. Yeah. After that, let us make the credential here. Click on the add, click on the Jenkins. In the kind, click on the sh username with the private key. And the ID, you can write the anything. Suppose I am writing the anything as well. Anything you can write in the description as well. But in the username, we need to write the name of my virtual machine that we are using it. So here I am using the Ubuntu. So let me write here the Ubuntu as well. Yeah, and enter directly, and here nothing changed. So let me open my PAM file content. Copy this and paste it to my Jenkins dashboard. Yeah, and click on the add. My credential has been made. Let's select the credential. Yeah. Host key verification, home non-verifying verification strategy. Fine. Yeah, and click on the save. You can see test has been successfully connected. Okay, so we need to do the similar tasks for my prod as well. Yeah, so let us click on the new node again and let us connect to my prod as well. Prod, click on the permanent agent, click on the create. Again in the remote root directory, write the /home /Ubuntu /Jenkins. Yeah, launch method launch by sh. Yeah, and the host, the private IP of that instance that we want to connect. So here I'm connecting the prod. So let me copy the private copy of that one and paste it here. Yeah, and we are doing the host. After that, let me check. Yeah, credential, no need to create it again. Use the previous one that we are making it. Okay. Yeah. After that, host key verification, non-verifying verification strategy. Click on simply the same. So as we discussed yesterday, once we are making the connection, it should reflecting to my this instance as well. So if we go here and do the ls, you will see Jenkins there, right? And the similar Jenkins inside the prod as well will be there. You will see. Got it? Yeah. So guys, till now what we have done with this, we are done with the cloning, we are done with the this installation, we are done with this installation, we are done with the this installation. Now the only task we are remaining to make our the 3 job 3 pipeline. So till now guys, is anybody is having the any doubt, please ask me the same. It is clear, yes or no? We have do the nothing, just simply give the installation, make the Docker file, and simply make the connection to the Jenkins desk. Now is the time to create our all 3 jobs. Okay, like the same we are did the job. Okay, there's a little bit slightly difference. Let me tell you when we are making it. Okay, so let's go to the here and go to the dashboard and click on the new item. Get the name called job 1 that is mentioned in our project. Click on the freestyle project, click on the OK. Yeah, here again selecting the GitHub project. Okay, here you need to give that repo link, that fork repo link. So here go there and copy this link and paste it there. Yeah. After that, select where this project can be run. You know, here firstly, because as you can see the diagram, we are going to create the job 1 in the test. So here in the label experience, we need to add that test name. But before that, let me are going to push my both of the branch. We have not still push it. So let us go there to the master. Okay. Yeah, so we have the 2 branch right now, git branch. Yeah. So as you can see the diagram, that it should run on the develop branch. So let us firstly push the develop branch there. Okay, we need to push the both of them. So let us firstly push the develop, then we can push our master in it. Okay, so let me write here git firstly checkout to the develop, git checkout develop. Yeah, so let me push it this git push origin develop. Here we need to write the username of my GitHub account. I'm writing it mine 23. After that, let me copy paste in the tokens here. So where is my tokens? Here it is. Yeah. Yeah, it has been done. So if we go to that repo, where is that repo? Yeah, and refresh this one, you will see develop is already pushed. Now let us check all the things has been pushed from the master as well. So let me push to the master, git push origin master. Sorry, hide the username. Yeah, my user and place of tokens there. Yeah, it has been done. Now if we go there and that repo and refresh this again, you will see both has been branch has been there. Master is there, develop is there. Okay. Now let us go there to my job, and if we writing here the test, it will selecting and here selecting the test here. Okay. After that, click on the git, and in the repository URL, we need to again pasting that repo link. Go inside the code and copy this link. Yeah, so here guys, remember here we are making with the help of develop as we discussed. So here we need to write the develop branch in it. So writing the develop. After that, scrolling down, we need to create a GitHub hook trigger for git polling. Now for that, we need to trigger a webhook for that repository like the discussed yesterday. So let us go to the settings and enable our webhook there. Click on the webhooks, click on the add webhook, and let me confirm the password if I remember. I hope it is correct. Yeah, it is fine. So in the payload URL, we need to write the from where it is running. It will be running on my job Jenkins. So let me copy the IP of the Jenkins here, and we need to paste it there. After that, we need to write the GitHub webhook. It's the syntax we can say we need to follow if we want to trigger a webhook. Let me check if something is missing or not. GitHub webhook, yeah, and simply click on add webhook. So we need to wait till this green symbol will come. So let's refresh this page and check it. Yeah, now it has been done. So let us go to our job. GitHub hook triggered for Git polling. Yeah, add webhook. GitHub hook triggered for Git polling. Yeah, fine. It is fine. Now, is everything remaining? Now, firstly, before doing anything, okay, let us check by running this simple pipeline. Okay, so let me firstly click on apply, click on the save, and check the develop branch that my last pushing to my develop branch has been done or not. Because this job is running on my develop, so each and everything would be there inside that link. So for the safe side, I am doing the pushing again. Tokens is there. Yeah, everything up to date. Yeah, no worry. Okay, now if we click on the build, let us do the check that it will normal pipeline is running or not. Let us click on the build. Let us wait it would be done or not. Then we will do the remaining of the thing. That's need the Docker in it. Yeah, it has been there. So let us check. Go to my test. Go to inside this Jenkins. This is my test. Go inside the Jenkins. Do the ls. Go inside the workspace. And do the ls. Job 1 is there. Yes. So if we go inside the job 1 and do the ls, the files has been there. Docker file images. It has been there. Now let us do the configuration. Just to safe side, just for the safe side, let me check that if something is missing to be pushed to be done in the GitHub repo. Otherwise, nothing else. For just make sure. Okay.
Let's have a quick quiz question, guys. And the question is, what are the key components of DevOps? And your options are continuous testing, continuous integration, continuous delivery and monitoring, or all of the above. Please mention your answers in the comment section below.
Just a quick info guys, if you want to make a career in cloud computing, then Intellipaat provides an advanced certification on cloud and DevOps by IIT Madras. This course is taught by industry experts and IIT Madras faculty. This course is designed to upskill and land your dream job. Now let's continue with the session.
Yeah, it is done. Now how to check it? Copy the public IP of the test and paste it on the port number that we are mentioning. So let me show you. What is my copy the public IP of my test instance and paste it on the column 81, that the port number we are assigning, so that you will see the GitHub web page is going to running on my port 81. So this is how we are done with the job 1 that will be creating with the help of Dockerfile. What the changes instead? We are making the job on the develop run. Till now it is same, but this time with the Dockerfile. Dockerfile makes sense. Like in the executed shell, we are assigning the Docker name, image name, and the run that image on the particular so that you will see this web page is running. So now let us go to the job 2. Job 2, do you use the Docker file in the Jenkins? See, what is a user Docker file? That I just push that Docker file to my GitHub wrap. And here, just see here. Let me show you. In the configuration, in the executed shell, see, I just give the command to build it. This is the location of my job 1. So inside my job 1, it has the configuration of the Docker file, right? So this is the location of my this test. See, pwd job 1, this is the location of my this one. So inside this, because it is running on my GitHub link, inside GitHub link, it has the Docker file, right? So inside this, it will work with the Docker file. Because here we are giving the Docker name and the port number in which our application is going to be run, as you can see. So now it is clear. Miraj, I am talking to you. Yeah. So now it is saying the job 2 should run on the master branch. Okay. Only changes we need to do. So let us quickly make this. Where is my Jenkins? Yeah. Go to the Josh. Yeah. Click on the new item. Give the job 2. Click on the freestyle. Click on the OK. In the description, if you want to write anything, then you can write. Let me show you where description I'm talking about. This description. Like here, you can write anything here. Like I am writing here, testing for master branch, because we are making this job on the master branch. So you can write any other, like hi, hello, anything you can write. If you write the lyrics of your song, it will work. No problem. Anything you can write there. Okay. After that, again, select GitHub, and here we need to paste that GitHub link. Go to there, copy this link, and paste it here. Yeah, in the select resist where this project can be done. After that, what we are going to do here, as you can see by the diagram, that this job is also running in my test. So in the level experience, we need to write the test again, selecting that one, click on the Git and give the link of that GitHub repository again. Now go scrolling down the branch specifier, master is fine. Okay. After that, yeah, in the build triggers, select GitHub hook trigger for the polling. But before that, what we are going to do, let us push that Docker file there. Okay. So if we going to be here, go inside the master. Okay. So whatever it is, let us push all of them. Okay. So that it will not throw the any error. So let me write git push origin -- all. Whatever it is, it will going to be pushed this time. Okay. It doesn't matter. It is going to push the master. It doesn't matter if we going to anything. Okay. So let me check before that. I am on which branch? Develop. Okay, fine. Let us check out to the master and do the git push origin -- all. Let us push all these things, whatever it is. Let me write the username developer 123 as well as the tokens here. Yeah, everything is up to date here. Fine. So let us go to there. We are selecting the GitHub hook trigger. Fine. After that, firstly, let us run with this simple. After that, we will assigning that particular Docker container like that. Simply let us try this. Build now. You will see it has been done. Okay. So now let us do the configuration. Let us assign the port number. Go to inside the configure. Before that, let me show you here. If you go to the here and do the ls, go inside the test, do the ls, you will see, not this one, cd dot job 2 has been there. Job 3 has been successfully uploaded there. Okay. So let us go inside the configure, scrolling down again, go at the last, build executed shell. Yeah. So here, give the command again, sudo docker build and the location of the job 2, /home /ubuntu. Let me copy it. Go inside the job 2, cd job 2 and write the pwd, copy this location. And paste it here. After that, let us assign the image name. Suppose I am giving master app. You can any name you can give to the application. And let us run this image. Sudo docker run -itt -p and the port number. Suppose I am assigning 82:80 and the image name master app. Let me check the location is fine. Sudo docker build. /home Jenkins workspace job 2 master app. It is looks fine. Let us apply. Let us try to build it. I think it will throw the one error. Let me check. It should be done. It should throw the error. No, right now it's not throw. Okay, fine. If we copy the public IP, let me check. And paste it this time on the port number. What the port number we give? I think 80 or it was 81. 81 is for the first job. 82 is for the another one. Yeah, you can see it will be running here. Fine. Yeah. So this is how my job 2 is running. Now the only thing is remaining, but it has a little bit different to my job 1 and job 2. Here we need to create the job 3 and we need to give the dependency to each other. Let me show you so that you guys are understanding better. So go inside here. Go inside. So I want to show you one interesting thing. Okay. Like guys, see. Now see here, I am not creating the job 2. Now if I build this again, it will throw the one error. Definitely it will throw the, see. Build is now successfully failed. What it say? Let me show you. These things not every trainer will tell you. Now listen to me carefully. Conceptual thing will be there. Let me open the output. What is saying? Yes, see. Port is already allocated. That means we are building the new container. We are building the new job. But in the new job, it would say, let me show you. On the new job, it will create the different container, right? So we have not given the deletion command here in the executed shell. Because what happened, let me tell you, let me first show you. You are running Docker on the same port number exactly. So either we need to stop the container before assigning the new port, or either we can delete the container. So I am going to the executed shell and adding one more command here for the deletion of the container, remove of the container. Let me write it, sudo docker rm -f and sudo, hold on. Docker ps-a-q. Yeah, so this command is basically deleting my previous one and building a new one. Okay. Let me check command is fine or not. ps-a-q. Now, if I apply this, save this and build it again, it will never throw the error. Build now. It will start working. Let's wait. It has been successful or not. You will see it has been done. See here, when it's successful, it will create the container on particular port number that we are assigning. So when I run that again, so it will throw the error of what? That the port is already allocated. or you can delete you can simply give the deletion command, so that whenever next time you are creating any port, next time you're creating, it will automatically delete the previous one and create the new one on that same port number. That's the things I want to explain you. Okay, so let us build our third one. So click on the new item, job 3, name we are giving freestyle project, click on OK. Sorry, Mint, got it. Okay. Now in the description, again, you can write anything. Suppose I am writing anything, you can write there. Suppose I am writing releasing product, anything you can write. I am just writing anything for this. Release product after successful master test at job. Anything you can write there. After that, again, select the GitHub project, first thing, and copy the link of that. Where is the link? Yeah. Copy this link again, paste it there, same tags till now. Yeah, and select assist where this project can be run. In the level experience, now what's the name we need to give there? Test as well as the prod? Prod, exactly, because we are building this job on the prod. So we need to selecting the prod one. Yeah. So in the Git, we need to select that repo again. We are triggering this pipeline with the Git. So yeah, in the build triggers, we don't need to select GitHub hook triggering. Yeah. After that, build triggers, go inside the build, go inside the executed shell. And here give the command for the running of the image, sudo docker build dots and the image name. Suppose suggest me any image name. What you want to give? Any image name. Suppose I am rating the final release. Okay, any name you can give in place of that. I am writing sudo docker run -itt -p, and the port number, suppose I am assigning this time 81. We already allocated 82 is already, let's suppose the 80, or any port number you can give, it doesn't matter. Final release. Yeah, okay. Build it, final -itt -p 8080. Finally, let me check. Yeah, let us apply. Let us save. Okay, let us firstly build it. Let us try to build this before giving the dependency. Okay, let us try to build this simple pipeline. It will work or not. Let us wait. It should be done. Yeah, it has been done. Okay, now give the dependency of the job 2. So let us go inside the job 2. Go inside the job 2. Go inside the configure. Yeah, and go at the last post bill option. Post bill action means where we need to select the after this job. So here I am selecting my name of my job 3. Okay, yeah. After that, nothing to change. Simply click on apply, click on save. Now go to the job 3 and run it. It will throw the error of the again same, that container port is already allocated. Let me show you that error also. Let me click on the build now. It definitely see throw the error. So only error is same. Let me show you the error as well. Error is same. We need to just give the one remove command. See, port is already allocated. Okay. So go inside the job 3 again. Go inside the configure and adding one command so that it will work fine. Go ahead, the execute. This is my job 3. Yeah, this is my job 3. Here, adding one command to delete this. Sudo docker rm-f, and let me write it the full command quickly. Let me check each and everything is fine or not. Yeah, click on apply, click on save. So if we build this time, this will work. Let us wait. It should be done. No, it is again. Okay, let me check what happened to this one. Okay, spelling is mistake there. Sorry, spelling is mistake there. Apply, save, and click on the build now. This time it will work. Again, oh my god, of what happened? Go inside the configure. Okay, without this, let me just remove this. Let me check. What's exactly happening there? Apply, save. Yeah, now it is working fine. So now if we copy the public IP of my prod and paste it on the port number 80 that we are giving it, sorry. That is 80. It should work. Now if we go to here and build it again, it will again throw the error because of the port is already allocated. Yeah, so now we want to add this one like configure. Just let me just show you by giving the command. Okay, sudo docker rm-f, and let me quickly write the command for the same. Let me check now. It is everything is fine. Sudo docker -f is sudo docker ps -q. Yeah, it should work. Build now. Yeah, now it is working fine. Now let me take your doubt. This is how we are done with our project. So in the job, when we are making any job with the help of Docker file, the only missing is that sometimes it is saying when you are running the first job. So port is particularly allocated. If you are running that job, so it will say that port is already allocated to that number. So that's why we are giving the deletion command.
Starting with this one introduction to the DevOps. So what is a software development? So what is a software development? Software development is the process of transforming customer requirements into a complete software product. So I will be speaking up few of the lines from these PPTs. Those are PPTs. Then I will also explain you all those topics in my own language also, and I will try to explain you with these examples as well. So those people are new to this IT industry. It's fine. You're new to the IT industry, but you're still aware of it that you are using up many types of softwares in your day-to-day life. to conduct some work or to get some output. So similarly, what happens in case of the software development also, when we have to develop something, we always have some life cycle. Life cycle means the stages, like how to go through there, how to go through that life cycle, how to develop up the applications. Through that, you need to have some processes, correct? So similarly, if you're creating any product also, like like let's suppose you're creating, you want to bake up a cake, then in that case also you need to go through several steps, how you will bake up a cake, and then you will put up the ingredients, and then you will bake it up, and then you will eat it. So you have a different stages through which you go and get an end product and enjoy your cake. Similarly, in case of software development also, you go from different phases. In different phases means first you will write up a code, and to write up a code, you need some softwares, and after that you will also need a what a programming language you are using, and after that you will store somewhere. For storing up, you need some space. That space could be some centralized repositories or maybe a distributed repositories. So what is this distributed repositories and central repositories? We will discuss when we'll come up onto the version controlling the Git. Okay. I'm just giving you an overview what happens when we talk about this software development lifecycle. So in that case, you need to know what all tools will be included, uh, what all services need to be done, and then you have to need to install the supporting softwares dependencies on your system, and then you go ahead and save it somewhere, and then you deploy onto the servers. Now this is the basic things which happens, but to conduct these things as well, you need a lot of planning. You gather the requirements, you gather the different, you go to the different phases, you design it. Now the tools which I have told you, that comes mostly onto the working conditions, like when we will start working upon to the software development. But before that, before going to that phase also, we have different things. We, like for example, you, when you want to go for a trip, when you go for a trip, you usually plan it out where to go, what will be the weather. Now you plan the things, and according to the weather, then you will gather the requirements, like you will gather the resources from the market. Then once you gather the resources, now you will pack it up, and then you will go ahead and enjoy the trip with your friends, and over there traveling will be done, hotel stay will be done, then you will come back. Similarly, in case of software development also, you will plan a lot of things during these phases, what will happen, how it will happen, if the it comes a failure, then how to recover those points. Now to conduct these all plannings and all, we have the different models into the IT industry, which we will discuss in upcoming slides. So first thing is, what is a software development life cycle? In a software development life cycle, first we have the requirements, then we have design, then we have implementation, then we have verification, and then we have maintenance. Now, what do you mean by requirements? Usually, when you go ahead and create any product, like anything, either a software, either any hard product, you always first look into the requirements. What are the requirements of the people, and how we can solve those problems of those requirements, so that our product can be sold it out very easily and we can earn the profits. Similarly, in this case also, for example, I am one of the client. I came back to you that I have something in my mind, but I can't know how to implement this thing into the market. So as an expert, you will first gather up his requirements. What are the informations he have, and what he is looking for, what are his expectations, and then according to that you will start designing. So designing means you will think upon this. Okay, this is a website. This will be looking like, on a left side we will have these buttons, on the right side we will have this percent, we will include the payment gateway, we will include this much of pages, we will this is the costing part, so we can go ahead and use this domain. Example, multiple things comes over here when we talk about the requirements and designing. Once the designing is done, okay, once the designing is done, now you're ready to go and implement them. For implementation part, what will happen, you have designed, now you're going to implement what you have designed. You have written down to your own points and all. Then in that case, go ahead and start implementing those things onto the different stages, and now implement those through the different phases with the different team. And once the implementation is done, you will verify. Verify means we are testing up. So in case of testing, you will test up the tools and services onto a different platforms. Once the testing teams has verified that yes, this code is good, now this website is meeting the requirements of the customer, then it will go and we will go and deploy. After deployment, it will go ahead and then we will do a maintenance. Like for example, you have created a product, now you have deployed that product or you have purchased that product. After some time, you will start working on to the maintenance part. So that will comes under the maintenance. We have, like, I will explain you one by one again into this part. First is requirement. This is the most important phase in the software development life cycle. In this stage, the requirements are gathered from the customers and the requirements are then analyzed to ensure the feasibility. As I've already told you, requirements is to gather up the what are the needs of the customer. That is the comes under the requirements. Now design. What do you mean by design? Once the requirements are received, the architect transform these requirements into technical specification and plan the software components which may be designed. Like in what happens in the designing cases, you will be checking up what will be the configuration of servers will be needed, what will be the version of that particular software will be needed, like .NET, or you want to create into Python, Java, which programming language will be helpful to gather or to work on to the requirements of the users much more closely. So in that case, you will put up that design onto the designing page as well. Then implementation. The specifications are passed on to the developers, which create the application based on these specifications. Like you have gathered up, you have designed it up, now you are sending up those information to the developer. He will start converting that design to the end product with the help of the design you have done, and it will start working out over there. Then verification. Once the development work is done on the application, it is verified by a group of testers to map the application functionality with the specification given by the customers. Second, last, then the maintenance. The code is verified, is pushed to production. Post this, the application is updated with any future enhancement or optimization if and when requirement. That is the maintenance. I hope you have got it. Now coming on SDLC models, SDLC like software development lifecycle have a different models. Now, what do you mean by models? Like, you know, to work on onto one of the thing, you have several ways. You plan it into a different ways. For example, you want to go for a trip, then you will plan it out whether should I go with the train or should I go with the plane or should I go with the road transport. So to conduct or to get an end product, you have several ways to do it. Similarly, in software development lifecycle also, you have different models. And once you follow those models, you will get the end product. Each and every model have their own benefits, and it depends upon the criticality of the project and also the size of the project. So if you have a size of the project means if you have a lot of requirements from the users or from the requirement from the client, like he wants a very complex website. For example, if you go for the Amazon.com, you must have seen there are a lot of options and are there into the Amazon.com. Like you have a checkbox, filter, payment gateway, multiple pages are there. So that kind of website is very much complex, and that creation of that website will take you a lot of days. Correct. On other side, if I go to some other website, let's suppose just an example.com. On that one, you're just printing up one of the page, say hello world. So how much time will it take to print up a hello world? Just 5 minutes, 10 minutes, or maximum 30 minutes. Okay, not more than that. But as a website, if I am talking about the Amazon.com, it will take around months, and then you have to maintain that as well. So Depending upon the project size, the complexity, how many people are involved, how many teams are involved. So in that basis, we always try to get the SDLC models. I will explain you the different types of SDLC models available for you, which a company follows or different project teams follows into their industry. So, since the time software development started, various software development models have been curated by which implemented SDLC. Each of these models solve problems that existed before these models were invented. Why we need a waterfall model or any of those software development lifecycle model? Because one person is working, for example, your manager is working for ABC company. Okay, after some time, he is switching up into some other company. Instead, at his place, a new member has joined. But now, as after joining up, he saw that we are following up the waterfall model. So he has a basic standardized into his mind that how does the waterfall model work. So to create a standardization throughout the IT industries, we have named it as a different software development lifecycle models, so that consistency could be there throughout the industry. If one person leaves, another person joins, then the new joinee should not face a lot of issues to understand the flow. So once you will tell him that okay, we are following the waterfall model, so he will easily able to relate it. Correct. So that's why we have the different types of waterfall models as well into the IT industry. So most of the companies, we have multiple software development life cycle models, but most of the companies follows uh, uh, one of them. One is you can say waterfall model, agile model, or lean model. We will tell you the benefits of it and what are the different phases of these models. So waterfall model. What happens in waterfall model? You must have seen the waterfall, how you can relate it. You can see the diagram as well. And when you go to hills or some other places, you must have seen the waterfall. How does the water goes from up to down? Similarly, in this case also, we have created a kind of a structure in which what happens, we have different phases. So when you go to the hills, you must have seen the water goes from up to down. Does it go backward like down to up? No. So similarly, in case of SDLC model of waterfall model, so what happens once the one phase has been completed, then it will go to the next phase, then it will go to the next phase, then it will go to the next phase. Until the first stage is completed, it can't go to the next phase. So it will be more on a time consuming side. Until the feasibility check is done, analysis can't be done. Until the analysis can't be done, design can't be done. So all are dependent on each other. But to alternate, and but what was the feedback of this type of model, or what was a drawback of this kind of model? So these days we are very quick. We need the end product very fast, and we can't spend a lot of time. In waterfall model, it was a time consuming. So for it is a time consuming, for example, there is a team called used for analysis. They will say until the feasibility check is done, we can't analyze. Okay, until the complete feasibility check is done, we can't analyze. So analyze team will be sitting idle, other teams will be sitting up an idea. Nowadays what is happening, you can't afford so much of time, because if one phase is taking lot of time, other phases will also be affecting it up, and they will not able to deliver the product on time. So in that case, what is happening these days, we are quickly making up the changes onto our models. But do we believe, okay, analysis team will go to the feasibility check team and say, okay, as much information you have gathered till now, give me, I will start planning out, or I will start analyzing those points, so that at least we have something to present to the client or to a team in sitting on us. So nowadays the things are changing, we want a quick results. That's why we always think about, okay, as much we have, give it us, we will start working onto it. But in case of waterfall model, until the last phase is completed, we can't move to the next. So we have different phases over here: feasibility check, analysis, design, code and unit testing, integration and system testing, maintenance and software. So in this case, waterfall model was among the first development models which follows SDLC. Waterfall models allows a linear sequential model of development, that is, until the first stage is not finished, the next stage will not start. So Neha is asking, does waterfall model have requirements analysis gathering phase, or does it start with the feasibility stage? See, that gathering up the requirements is always there will be a phase. Okay. So those are the phases which I and the SDLC model phases which I have told you over here. Requirement design, implementation, verification. This is the overview of the SDLC model. Now to work on these steps, we are using our different models into it. So you can say waterfall model is a part of those complete setup. SDLC models needs requirements, planning and all. That's the overview. But in that also we have different sub phases. Sub phases is like feasibility check. Okay, so feasibility check, what do you mean by feasibility check? That okay, we have got the requirement, whether it is feasible to work onto it, if yes or no, whether we can it is good to use it or not. So feasibility check is onto the product, onto the requirements. So but is it feasible to do it? Is it really possible to do it? For example, today one of the client come up and say, I want to create a time machine. So you will tell them, tell the client, it's not possible, sir. It is not currently possible. Maybe in future we have such kind of technology through which we can do it. So this kind of sometimes see, a client is a person who has something in his mind, but it's up to you, and it also depends upon the technology and all the requirements, whether it is feasible to use it or not, whether it is possible to do it or not. So that is the feasibility check analysis. Once the feasibility check is done and you realize, yeah, we have good to do, then you will analyze it through the different products, like what need to be done, how it to be done, which tool should be used. Those analysis will be done. Once that will be done, then we will go to the design phase. Design phase more onto an architectural side, like which service cloud we will be using it up, which services will be using it up. Virtual machine, okay, virtual machine you're using, but we need a storage account, we need a SQL server, we need some networking. So that part comes into the design. After that, code and unit testing. Then once you have realized that design is done and it is good to work, then you will send up to developers. Now what the developers will do, they will start doing the coding. Okay, okay, we have decided that we will be working onto a Java language and Angular language, and for SQL and for the database side we will using a SQL database. So you have analyzed this, you have designed it. Now the coding team will write up the code, and the testing team will test that code once the one of the phase is completed for the test production, for the production. Now once it is done, again integration and system testing. What is integration and system testing? uh, one thing is called a unit testing. Unit testing comes on one-on-one testing of the code. They try to run up the code onto a local one, but after that, once the testing is done, it goes to the another phase, integration and system testing. So they will take up that code and application and try to run out into the different devices. For example, nowadays many applications are there onto a Google Play Store. Now Google Play Store is fine, but we also have several devices. Many mobile manufacturing companies are there. So is it compatible with the all these mobiles or not? So these kind of testing is usually done by the companies, depending upon the end product, what you are creating. For example, if you are creating up an application for your mobile, then your company will purchase different models of the mobile, iOS and Android, and they will test the application on those devices. That is the integration and system testing. Once it is done, maintenance of the software. So what happens, like you have deployed onto the servers. After deploying to the servers, maintenance is needed. Maintenance means that your services should be up and running. For example, you have purchased your car. Once you have purchased the car, after that you need a maintenance of it as well, correct? After purchasing, your responsibilities doesn't over. After that also you have to maintain it. Similarly, you have created up the software. Now you have to maintain the servers. You have to maintain the coding. Why to maintain them? In one go, you can't satisfy the complete lead to the client. The client will always have something in their mind, because like for example, you have bought a car. After bringing up a car at your home, you after some time you have thought, okay, I want to change the alloys, I want to change the seat cover. So now you're modifying those things, correct? So in that part, the maintenance of software comes into the work. Now, advantages of the waterfall model: clear objective, specific deadlines, no ambitious requirements, well understood milestones process, and results are well documented. Now, going further, what are the disadvantages of the waterfall model? Working product is not available until the later stage is available, is in life cycle. Poor model for large and complex projects, cannot accommodate changing requirements, high risk and uncertainty. These are the disadvantages of the waterfall model. Now, the next thing comes is agile model. What is the agile model? Like I've told you that waterfall model was used initially into the IT industry. Now the things have changed because requirements of the users have also changed. By the requirements, I mean the time span. So earlier, when any of the applications or services were created, that time it took 6 months, 7 months. Client is fine. They know technology is slow and everything is slow. It will take some time to develop. Even we don't have the so much qualified developers and all. So that is fine if they're delivering in 6 months, 7 months, and we don't have a much of competitors as well. But nowadays, what is happening? The things have changed because there are new softwares are coming up. Even you don't have to write up a code. You just put up a drag and drop of your requirements. Your code will be up and ready. So multiple types of things are coming up into the market, and even people want to expedite these processes. So in that, keeping those things in mind, the models has been evaluated. So they have analyzed that, okay, now this model is not working much more because of the time constraints and all. So another model was introduced, and another model is known as a agile model. You will hear about the most of the time agile or scrum. So we will talk, this is one of the model, agile model. So what happens in the agile model? You go to the priority, the request, design, coding, test and debugging, release and deployment. So what are the points of it? To overcome the challenges faced in the waterfall model, we came up with the agile methodology. Agile method believes in creating shorter development life cycle. Shorter development life cycles are achieved by not releasing all the features at once, by following the incremental model of deployment. I hope you have got the clarification with these points, but let me explain you much more better way. So what happens now, okay, I have lot of requirements, and I have lot of expectations with the website. Okay, it's fine, you have a lot of expectation, but out of this, what is your priority? Do you want a payment gateway, or do you want a extra pages for the information? So you will analyze, okay, what is my first requirement is? My requirement is to get the payment from the customers. So I will tell them, okay, create a one page website and add my payment gateway. For other pages and other details and requirements, you can add it up later. So in this one, what we have done, we have prioritized the request. Like this was your request. Now we are prioritizing them. After prioritizing the request, what will happen? For example, there was a complete website in which 10 options were there, or 10 features were there. Now out of 10 features, you have prioritized, okay, first created this, second create this, third create this, fourth and fifth and sixth and 10. So you have prioritized these things. Now after, onto that basis, you will design it. After designing that, you will coding. After coding, test and debugging, and and then release and deployment. Now, in case of release and deployment, out of 10 phases, 10 features, you have just deployed the one feature. Okay, you have deployed one feature and you have delivered it in 1 month. Okay, now client will be happy. Why he will be happy? He will be seeing some progress. Okay, let's suppose your manager asks you to create some document. Now every day he asks for the updates. What do you tell him? I am working, I am working, I am working, I am working. But he will not be clear up like how much you have worked so far. See, I want to see the output, because if he needs some he need to show you some inputs, or he wants some modification, he can tell you in the same day. But if you go with a different perspective, like, okay, I will show you once the complete document will be ready, he will agree. But think on this side, during this complete documentation, when you were preparing, at that time you didn't take any consultation from the manager. After 6 months you have worked on to the document. After 6 months you have delivered it to your manager, and manager says, oh, I don't need this document now. Why? Because you took 6 months to create this document. Now my requirements have changed. I don't want this one, I want some other thing. Or maybe he will, after 6 months, he will ask you to modify those products. So will it be feasible for you that after spending 6 months, how will you feel after 6 months if I just tell you, you don't have I don't need this product? So how will you feel? You will face not you will not feel good. Even from the client side, it will they will be dishonoring that. Why? Because that particular client has paid you for over the 6 months, and the end product which you have gotten, that is of no use. So to avoid the situations and all, the models were changed. Okay, now in this agile model, these were the points. Now what are the advantages of the agile? Customer satisfaction is high. Why customer satisfaction is high? Because as soon as he sees some progress, he will be satisfied. Yes, something is working, something is there into the process. He will be happy over there. Now, less planning recruit. Why less planning? Because there was a huge product. Now that has been divided into sub features. So less planning will be required for each and every feature. Requirements can be dynamic in nature. Why dynamic in nature? Every day the technology is changing. Every day the new requirement is changing. So in that case, let's suppose I was thinking about to create a new product. I slept, and then after I wake up, I thought about, okay, why, when I'm already paying for my product, why we should not have this feature? Why should we don't have that feature? So in that case, your requirements are changing. So in that case, what is happening? If your requirements are changing during the agile model, it will be easy to do that. Why? Because we have already divided the complete project into the sub parts. So making a change into the sub parts is much more easier as to compare to the complete project. That is the one of the way. Functionality can be created and tested quickly. Why tested quickly? Because you have created a feature. If you're creating up a small feature and delivering it, so it will be very easy for the users or the clients to test how the things are working and then give the feedback on time. What are the disadvantages of the agile? Not suitable for handling complex dependency in projects. Knowledge transfer to colleagues can be difficult since there is a little documentation. Success of the project depends heavily on customer interaction. So this is the disadvantages of the agile model. Uh, Disadvantage of the agile is like it is not suitable for the complex projects. Complex projects means you have a lot of coding, you have a lot of dependencies on one page to another. Many websites are there where we have a complexity. So in that case, agile is not too good. I'm not saying if we can't use it, we can use it, but sometimes it's not too good because what happens in complexity, you have the dependencies from one place to another. Then what happens? You have while you have divided your features, of that website. So if one feature you are trying to add, that could happen that this feature is dependent upon the another feature. So dependencies are also there into the product. So because of which the complexities are there. If you have a complex project, it is not good to use the agile. Now knowledge transfer can be difficult because what happens in agile, usually you create up the features. Okay, you know that I will be working up in this company for next 1 month. So usually what you will do, instead of creating up a complete documentation, you will just create a documentation of 1 page or 2 page for the official use, and then you will start working on to the features, and then you will deliver it up. So documentations are less in that case, in case of uh, this one, agile. Okay, let's go further. Lean model. What is a lean model? 7 principles of the lean model are eliminate waste, amplify learning, decide as late as possible, deliver as fast as possible, empower the team, build integrity, see the whole. So lean development model is a philosophy of increasing quality in software delivery by making use of agile methods. Ignore the cluster for later and focus on what is required now. Lean methodology has its primary focus on two things: respect for frontline workers and continuous improvement. So what happens in lean model is it's a more much advanced than the agile model. In this one, you can say it is much more faster as compared to agile. So maybe in agile you are taking up 2 months to deliver. In a lean one, it will take you will be delivering up the feature into 1 month. So like what was happening in agile, we were dividing up a one feature into sub features. So in this one you will try to divide the task much more easy into a much more small ways, and then you can try to divide that within the teams. So in this case, mostly we have these principles of it, so you can write it down, this principle. So what happens in this case, it focus more onto the quality. Quality means quality, you know what do you mean by quality? Like you are delivering of a best product to the customers. Sometimes this in the lean model, it could be more on time consuming, it could be on less on time consuming, depending upon the feature you are trying to work on. So depending upon those things, sometimes the times also changes, deliver time also changes into this one. Okay, so this is one advantage, carries the same advantage of agile methodology, creates a positive working environment, customer feedback is given the utmost importance, limitless waste, save times and money. So what happens in lean model is like in agile we were also taking up the feedback from the customers, but in this one we are taking up a feedback much more aggressively, because you know without the customer's feedback you don't know how he is liking up the product. So in that case, lean model is very much useful if you want to take up the regular feedbacks from the customers. Okay, now limiting waste times and money means as you will be delivering up a product on time, and also you will have a less of team because you are trying to deliver the product on time. So you will have a small team will work on small code, so they will deliver up a one feature. Once it is delivered, they will work to the next feature. So you need a small team. In that case, it's waste helps you to save the time and money. Now, what are the disadvantage of it? Largely dependent on skill set of the team, therefore require a strong team. No room for error. A missed delivery can be bad for business. Success of project depends heavily on to a customer interactions. So in this one, you are directly interacting with the customers. Why? Because you need to have their feedback, inputs, and you need to have their thoughts. So in that case, you need to have a proper feedback. If you don't get a proper feedback on time, then you will not able to understand how your the things are working into the industry. Okay, so this is a Azure DevOps. So when you will try to create any project into the Azure DevOps, you will get see the option. You see work item process. It's a basic Scrum, Agile, CMMI. These type of models comes up. What is the differences when you select different type of models? It usually matters in case of the sprints, like how much time you are creating up that Agile or Scrum. That is the sprints. Another one is you see the boards. Under the boards, you have the work items. So depending upon the work items, depending upon the process you have taken it up, whether Agile, Scrum, or any other, these type of work items gets different. Why we get a different? Because I have, as I have told you, in different work models we have different type of phases, and in each type of phases have their own requirements and details. So if you have a complex project and you want a much more division of that task and work, then you can use a Agile or Scrum. And if you know it's very basic, it's very small project, and in that case you can use just a basic template. So depending upon that, your work items will change in this structure. This is a process structure. So this is majorly this is the responsibility, whether we are using a Agile, Scrum, how the data flow or how the things should move ahead. These are the usually calls made by the either through the architecture person or either through from the Scrum masters or the project manager. So you must have heard these days many people are going for the Scrum master certification. So after deciding upon the which one you have to go with, then you can go with the Scrum or either from the or either you can go for the Agile. So the difference basically Agile and Scrum comes up when you have to decide upon the time and how to manage difference between them. Now waterfall versus Agile versus lean. So we have waterfall, Agile, and the lean. So what's the difference? You can see over here we have the lines: orange line, green line, purple line, blue line, and the dots. So it depends upon the how much time each phase is taking it up over here. So like requirements, the requirements in the orange phase in waterfall model, you see requirements how much time it is taking, and design how much time it is taking, and the complete product is now being delivered at a one go, but it will be taken up most of the time. So similarly, in case of the you can talk about the Agile. In case of Agile, you have a, you can see the time span. You can compare it from here. The difference between the Agile and lean model came about the eliminate the waste. Eliminate the waste means, like in case of Agile, if you know this feature is not required, you will still keep it up. But in case of lean, you will remove that feature. That is eliminate the waste. So summarizing, a problem with waterfall model was the development life cycle took a lot of time to complete. Therefore, by the time finished product was delivered, the customer requirements were no longer same. For example, today I asked you to create any application, and if you will deliver it me after 6 months, 7 months, or 8 months, it might happen by the time my requirements will change and I no longer need that. That was the drawback of the waterfall. Okay. Now the problem was fixed by lean agile methodologies. These methodologies strictly focused on customer feedback and improving the software quality. That too is shorter development lifecycle.
Which of the following is not the part of DevOps Lifecycle? And your options are operating, plan, build, or code. Please mention your answers in the comment section below.
Just a quick info guys, if you want to make a career in cloud computing, then Intellipaat provides an advanced certification on cloud and DevOps by IIT Madras. This course is taught by industry experts and IIT Madras faculty. This course is designed to upskill and land your dream job. Now let's continue with the session.
Now, why DevOps and what is DevOps? So, you guys are here. I know most people have heard about learn. You must have learned from or heard about from your teachers, or maybe from your colleagues, or maybe from your friends, or maybe from your family people, that you know, nowadays IT is very much in boost, and one of the technology which is very much high and demanding into the IT industry is cloud computing. Either learn Azure, AWS, or go with the DevOps. Few people must have influenced you about this DevOps and IT. But do you know what is DevOps? What is the use of our DevOps? I think very less of people will be aware of it, why you have enrolled into this course, and what is actually a DevOps is. What is the use of this tool? What is the tools, or maybe like it's a combination of the multiple tools. What is actually the requirement of this is DevOps. Okay, so I will explain you what is DevOps and what is the advantage of the DevOps, and how you can make up your career into the DevOps world, and what all things you can learn, and what are the advantages of it. So the DevOps word came up from the two keywords, the development and the operations. Basically, what was happening, we had a team called development team and the operations team. The development team work was to create up a code and test it out onto to their side, give that code to the operations team. The operations team will deploy them onto the servers. That was the how the teams used to divide their work into the company. Now the challenge was, you know, when you, if you are from the you can say IT background student, or like for example MCA, BCA, or maybe like you have done the electronics or computer science, BTech, anything, then you must have written up a code sometime, like .NET code, Java code, Python, any scripting languages, any code you have written up. And now after writing up a code and creating up a live project, what do you usually do? You run that particular code onto your local machine. Local machine means your laptop. Now, after running up it onto your local, you see, oh, my project is running perfectly fine. After some time, your teacher asks you, can you please give me the, can you submit your assignment? You have copied that code, you have to a pen drive. You are very happy that it's working fine onto my system. You have given it to your teacher. Teacher will try to run that code onto her or his laptop. Now what happened? When she or he tried to run it onto a local machine on his laptop, it's not running. It start throwing up the errors. Now who is wrong over here? Your teacher, you, or your system? So basically, no one is wrong over here. It all depends upon the dependencies and all the system configurations and all. Now, this was happening the same thing into the IT industry as well. The coders, the developers used to write up a code onto their system, the local laptop, and once they execute it onto a local, it runs fine. And then they give the code to the developer operations team to go ahead and deploy onto the servers. Now, it may happen that configuration of the developer and the servers will be different because of several reasons: configurations, hardware configurations, software configurations, and multiple things. So this was not working accurately. Now operations team used to go back and say to the development team, please make the changes into the code. Developers used to come back and say it's running fine. So there was a contradiction between them. And let's suppose this things keeps on going up into days. You know, in a company, people goes on leaves, one person is not there, another person is not there, or maybe you have sent up a mail, another one is not responding. So meetings are happening. Now these things were very much happening, and it, for so simple task and all those things, it was taking a months to complete. So to avoid those things and situations, what we have came up with the word called as DevOps. What we say, okay, now developers will write up a code, and but they will deploy the code directly to the servers and test it out. If that code is running onto the servers, now it means that this code is perfectly fine. Now operations dependency is less. Operations team will still work. They will work on the maintenance part of the servers. If they need a new hardware or new infrastructure, if a developer wants a new infrastructure, new software requirements, new dependencies, maintenance, monitoring, then in that case operations teams will be there. But each time when they have to redeploy the code, the developer will not ask operations team to you can say deploy that code onto the servers. They will do it themselves. By doing themselves means they will not copy the code by themselves. It will be like they will be just pushing up a code into a common place that is called as a repositories. From there, these servers will automatically check. Okay, there will be a webhook means, or what does happen, it will check automatically that yes, the new changes has been there into this file, so please run this set of task. Then the set of task will be executed and you will get the output. So this is our overview of the DevOps. Don't worry if you have not got it completely. I will explain you and we will talk about the DevOps throughout these classes. So don't worry about it if you have not got it. If you have got what is a concept of DevOps, then you will easily understand the things. Now, I have told you about the conflicts between the development team and operations team. Now, in this also, we have the several phases. I will talk about those phases, what happens in DevOps and what will happen. So this is one of the, there are few PPTs or you can say slides in which they are talking about the DevOps, and it will explain you as an example what is happening between the teams. Okay, so we will read it out this one. Although the software quality was improved, we still had a lack of efficiency among the development team. A typical software development team can consist of developers and operations employee. Let us understand their job roles. Developer's job is to develop an application and pass his code to the operations team. The operations team job is to test the code and provide feedback to the developers in case of bugs. If all goes well, the operations team uploads the code to the build servers. I hope you have understood the team. Of, what are the responsibilities of the each team? What a developer has to do? What the operations person has to do? I hope you have got it. Okay. Coming up next, the developer used to run the code onto the system and then forward it to the operations team. The operations teams when tried to run the code on their system, it did not run. Okay, I told you because dependencies onto a developer were different. Dependencies means many such files, DLL files or any execution files which were there onto a developer laptop is not available with the operations. The operations team then marked this code as faulty and used to forward this feedback to the developer, and the code runs run on the developer system. Hence, he says it's not my fault. See, there is a contradiction in both of them. So this led to a lot of back and forth between the developer and the operations team. Hence, that impacted the efficiency. I hope you got this point because they both have a contradiction. Who is wrong? They both are blaming to each other, but didn't find any solution. So at the end, I like maybe after some time they will get the solution. But before that, they were just putting up the blames like it is because of you, it is because of you, or maybe you don't have that software, you don't have such softwares. You know, this kind of things usually happens into the IT industry or anywhere. Now, the problems was solved using the DevOps. So in this one, whenever we talk about the DevOps, even you will search about it, DevOps in Google, you will mostly see this kind of sign. This kind of sign means infinity. Infinity means these are the different phases and these are going up several times. On each and every time, it will go from the different phases: plan, code, build, test, release, deploy, operations, and monitor. I will explain this to you in upcoming slides. Now, traditional IT and DevOps, less productive, more productive. Skill-centric teams, team is divided into specialized slots. More time investing in planning, smaller and frequent releases leads to easy scheduling and less time in planning, difficult to achieve target or goal. Frequent releases with frequent feedback makes achieving targets easily. So now what is happening in case of DevOps? Now DevOps is a software development methodology which improves the collaboration between the developers and the operations team using various automation tools. These automation tools are implemented using various stages. These are the parts of the DevOps lifecycle. So as I was explaining you earlier, this is the infinity sign. Do you see this infinity sign? This is the infinity sign which we talk it as a DevOps. So in this one, we have a two phases. One is called a dev, another one is called a operations. On the left side, you see dev, and on the right, you see the operations. So in this case, first in a development side, we are planning. I've told you in a waterfall model, lean model, agile model, one thing was the planning. Planning means that after gathering the requirements, you will plan it out the things. Plan and designing are the same thing. So you will plan out the things that what need to be done. Okay, how it will be done. Then after doing up a planning, this is done by the dev team. Okay, this planning will be done by the dev team. Now after that, it will go to the coding. Now you have done the planning. Now it's time to write up a code. So you will do a coding. After coding, you will go to the build. What do you mean by build? So if you have written up a code into your past, or maybe like you are still studying, you have done up a coding a little bit. So you know there is always a compiler. What do you mean by compiler and code build? So what happens, for example, you have a Java code. If you are new to the IT industry, then also it's fine. We will see this thing in action, and once we will come up to the other topics. So in this development side, like I've told you, build. What happens in build? Like you have a Java code. You write up a Java code into a raw language, but when you deliver that product to the user or maybe to the operations teams, you don't give up a code as a complete, you get up the package. For example, let's suppose you want to install some software onto your local machine. Let's suppose you want to install some software like VLC. Okay, for running up that VLC software, some code must be written up in a background. Do you see that code when you download it from the Google? No, you don't see that code. You see as an end product, you see the application. Then you double click on that application and then the software gets installed onto your system. Do you know what type of code is written on that? Do you know? I'm not talking about if you go about the reverse engineering, you can do that as well. You can try it out. But I'm talking about a layman language. If a person is installing up a software, does he know what type of code has been written? What is there into that software? No. Similarly, in case of the layman language, if I tell you about, we have the code. Now that code will be built. Build means converting the raw language of the code to the some executable file. That is done through the build. Okay, that build is a concept. That is a task. Once we will run up a CI/CD pipeline, I will show you. So usually what happens, for example, you have a Java application. For Java application, we have the different compiler like Maven, we have and many more compilers are there. Similarly, for .NET, for example, we have a .NET application. For .NET application also, we have the NuGet. We have multiple software for different one. For Python, we have the PyCharm. If you have worked on these programming languages, you must be aware of it. So the type of language you have written, according to that type of language only, what happens, you try to use the compiler. When you compile that code, you get some executable file, correct? So in case of Java, if you use the Maven, the output of that file comes like jar or var or EAR. I will explain you these things. Don't worry if you are not getting. Once we will come up to hands-on activity on CI/CD pipeline, I will explain you all those things. Okay. So now a different type of code have the different compilers and an executable file comes out of it. Okay. So that executable file which is coming over here is now being used to deploy onto the application. So we have different type of code and we have different type of compilers to create an executable file. That process of creating up an executable file is called as a build. I will tell you about that. So once we'll talk about the CI/CD, in a DevOps, we have a CI/CD concept, continuous integration and continuous deployment. That we will discuss in upcoming classes because I don't want to cluster all the things today only. So these are the few basic things. So in this build, what we are doing, we are writing up the task, how to create up the particular executable file. Then once that build is done, we will test the code. Test the code means it will be tested out onto test means actually in a company what happens. So before delivering up to the end product and to the end users, what we usually do, we test it out. For example, if you you know everything in the world, when before going up to the end users, we test it onto our locally locations. But for example, you are going to purchase a car. When Mahindra is creating up a new product, or any company is creating up a new product, they test those product onto their site. Once that is done, once it is validated and verified, then it goes to the end users to use it for your day-to-day life. Similarly, if you're creating up any of the software, in that software also, what happens, we have first we have written up a code. Okay, your application is good, you have created up. Now you have to test it out onto with the different user, and even you have to test it out onto different servers, whether it is working fine or not. So in that case, you will need a testing. Testing could be a manual testing, it could be a automation testing, depending upon your requirement. Then release. Once you are sure that the test code is running fine, everything is fine, then it goes to the release. Now release means the you are going to release that product to the different phases: dev, QA, and production. Now you will deploy it. Deploy means now you're running up that application onto the servers, the end servers, the production server, QA server, and the or maybe a dev. Mostly in case of deploy, we talk about the production server. We are going to deploy. Deploy means we are going to run that package which was created under the build pipeline. The package which was created under the build, like executable file, that will be run onto the server under the deploy. Okay, once it is done, they operate and the monitor. Now what will happen, you have deployed it. Now users will start sending up a request onto those servers. Okay, now after sending up the request onto the servers, what will happen, the other team members, the operation team will start monitoring it up. Because what do you mean by monitor? Okay, I have sent you the code, it is running fine, now monitor it up. Your server should be working functionality should be always fine. There should not be any issue over there. So in that case, you can use a monitoring. There are two types of testing also. One is called the application testing, another one is called the code testing, code analysis. So depending on that, testing kit can be in any phase, anywhere. So depending upon what kind of testing you are doing, it depends upon that. It could be on a code itself or either into an executable file. So what happens, this was a code. Okay, for example, you have written up a Java code. That is a Java code. You have written up and you have a POM XML file. You have written up a code that is very basic code. Let's suppose, if you have ever written up a code for the HTML language, very basic one, you write up a hello world. In case of hello world, what happens? You are writing up a one file, HTML file. Now you want to execute that file, or you want to see that as a website. So you will compile that code. Compile that code means you're executing the compiler to compile that code, means whatever is the language of, let's suppose is a computer language. Okay, one is known as a computer language and one is known as a human language. Now you want to convert that computer language to the human language. So that is a layman language I am telling you about. You are converting up a computer language to a human language. In that case, you are using a compiler. So in a build stage, you are converting up the computer language to the human language, that you can say as a building stage. Under the building stage, we have different kind of compilers depending upon what type of code you have. Okay, let me go much more deep into the another example of layman way. For example, you have there's a one person who speaks German. There's another person who needs who speaks Spanish, another person who speaks Hindi. So if you compare both three of them, can they talk to each other? No, because they have their own languages. Instead of that, what you will do, you will use one device which is a translator. That translator will help you to translate the language of each other in your local one. So for example, similarly in this case also, you have a different languages, the Java, Python, .NET. So you will need something in between which will make your software to execute and run. So in that case, we have a compiler. And to create that executable file, there's a steps that is known as a build pipeline. Okay, I hope you got it now. Now, this is a DevOps lifecycle. This is a DevOps lifecycle: build, dev. So how DevOps work? The DevOps lifecycle in the SDF lifecycle have different stages: plan, code, build, test. Then we have the release, deploy, operate, monitor. What happens in case of plan and code? We have known it as a continuous development, continuous testing, continuous integration, continuous deployment, and continuous monitoring. We have different phases over here. So what do you mean by different phases? Planning and code comes into a continuous development. So if you talk about the traditional, if I talk about traditional software development life cycle and today, how the things are changing. So nowadays, what is happening? Continuous development means traditionally we used to write up a code once and we have to use it again after 6 months, 7 months, or 1 year. Now, in this case, in continuous development, what is happening? We are continuously creating up the features. We are changing our code because the requirements of the customers are changing very frequently, and even we are going with the agile model. So in this one, we are doing up a continuous development very quickly. Like for example, in today we have developed something, maybe 2 months, 3 months back after it, we will try to bring up something new. Continuous development is going up very quickly. So under the continuous development, we have two phases: plan and code. Now the second phase, continuous testing. Now we have built up that code, building up that code, and we also need to test it up. That comes under the continuous testing. And in between, we have the continuous integration. In short, we known as the CI. So in case of CI and continuous integration, you have set of tasks and steps. Okay, what happens with the continuous integration? Under the continuous integration only, these steps comes. What do you mean by these steps? I will tell you. We have set of task. Set of task is you have to run. First, you have to run a sonar. Then you have to write up the build pipeline compiler thing. Okay. Then you are running up a test. Then you are storing up an artifact. Then you are going ahead, and then you are deploying onto the production server or the dev server. So when you are creating up a one particular artifact means an executable file, that is known as a continuous integration. Okay. Under the continuous integration, you will create an executable file. Once that executable file is ready, then you will copy that file and to the servers. So that is the continuous deployment. Why we called as a continuous deployment? Because let's suppose in the continuous integration and continuous development, you got first you have created a version 1. Okay, now version 1 is fine. Okay, it's very good, it's running fine. Now and it is now all the users are using the version 1, but behind the scenes the developers are there. They will also try to enhance the version V over there. They want to bring up the version 2 into the market. So they will keep on making changes into the code for the version 1, and they will deploy onto the servers. Now over here, which server? Not to the production. It will only deploy to dev or QA. Why only to dev and QA? Because in case of dev, testers and the production team will be using. For the QA, they will be testing and using, but the production team, still the end users will be using up a V1. Okay, let me explain much more in different way. For example, you know, when we started using up a Facebook, at that time the features were different, looks were different, appearance was different. Now the things have changed with the time. So now, like for example, the one which we are using right now, the Facebook, the developers must be enhancing the features onto their side. Once they are verified that these features are good to use by the end users, they will put up onto the production server. So that is a different continuous deployment goes like this. What they will do, they have the test servers. They will continuously deploy onto those servers. Every time they make up a new code, they need to test it something over there. For example, you are writing up a code for HTML page that is hello world. Now you want to change it the format. Format means hello world will be changed to the bold or maybe into a green text. So you have written up a code. Now to check whether the code is running up, whether the code is changing it into the green or not, you will run that code. After running that code, if it looks like red, oh, I want a green, it is looking red, I want to change it. You will make a changes into the code. Again, you will compile the HTML file, and then now you have tried again. Now it's green. Now you have validated it. Now it will go to the production server. So continuous deployment keeps on doing that part. Continuous monitoring means the number of users are trying to see your website, how they are getting up responses. By responses, you mean, for example, you have Amazon.com. If the Amazon.com goes down for 5 minutes, how many losses will be there to the Amazon company? They can't afford it. So continuous monitoring should be there so that users get a better and the best facility out of it. So monitoring is done of the servers. There should be no downtime. There should not be any shutdown of the services. Everything should be up and running. Continuous monitoring goes through that. So now, how does the DevOps work? Continuous development. Like developer has made the some changes into the code. He has pushed those changes into the version control system. Version control system means we are using up the Git. After version controlling, continuous integration means a new package will be created. Automatically, a set of steps will be executed. Then what will happen? Production server, it will be deployed on production server. It will be deployed on testing server. Then they will get some feedback and they will do a monitoring, and they will share that monitoring and feedback with the developer. Now developer, according to the feedback, will change up the things. Let me show you the overview. How does the pipeline CI looks like? So this is a CI in Azure DevOps. This is a CI, continuous integration. What happens? For example, if you see this one, this is a YAML one. Don't get confused. I will explain you these things in upcoming classes. So what we are doing over here, this is one of the application. This application is .NET based. Okay. So, and even we are using up a Docker over here. I don't want to go in deeper right now. Just I am showing you we are using up a set of tasks. We are declaring up a set of tasks over here. This is known as a continuous integration. So once I will run up my pipeline, these set of tasks will start executing. And once that set of tasks gets completed, I will get one artifact. Artifact means executable file. So if I show you how does it look like, the artifact, if you see this one, this is the one of the pipeline successfully. Here it is this is a package. This is one of the packages which got created over here, executable file. I will not explain you these things right now. I am just telling you this is a CI. CI means you have a set of steps through which you will create up a executable file. Once that executable file gets created, under the releases, you have different phases. Under the releases, you have set of servers on which your code will be deployed. Okay, so that is a CI/CD, continuous integration, continuous deployment. So in this complete process, we are doing the same thing. Developer is storing up a code into a version control system. From there, it is going to continuous integration. From there, it is deployed onto a servers, feedback, monitoring to the developer. What is a continuous development? This stage involves committing code to a version control tools such as Git or SVN or for maintaining the different versions of the code, and tools like and Maven, Gradle for building packages the code into an executable file and can be forwarded to the QS for testing. Okay, now what happens in the case of this particular development? Like it is mentioned, what happens, there is, let's suppose there is a developer. Okay, this is a developer. This developer has written up a code in Java language. Okay, he has written up a code in the Java language where he will store, he has to store that code into some place. Okay, that place could be either he will keep it onto his local hard disk, but is it good to store into a local hard disk? No. So now what happens, they have to store, the developer has to store the code at some location. Okay, that location could be his local hard disk. Otherwise he has to store it at a common place, like onto a server, from where the other users can also, or the other developers can also see the code and also contribute to that code. Okay, so for that perspective, what we do, we use a version controlling system. What is a version controlling system? Version controlling system means whatever changes you are making onto this code. Okay, for example, this is an application for, let's suppose, Facebook. Okay, now in that application, there will be some code at background. In that code, multiple developers are writing up the code to bring up that platform. So in that particular application, many developers are working and making up a changes. So we are up there storing it up. So we call it as a repositories. Okay, we call it as a repositories. I will explain you much more in detail once we will come on to the version controlling. I'm just giving you the overview. We call it as a repositories. So you can say a repositories is a place, or you can say it's a storage place where you can store up your code. Why we store up a code under the repositories? Because benefit, if you make any changes into the code, so what will happen automatically, and you will push up the code automatically, the changes which you are making up onto the code will be historical, entry will be made for that, history will be created for that. What do you mean by that? For example, developer A is there. Okay, there is a Java application. There was a file called abc.txt. In abc.txt, he has added some lines, or maybe has modified some lines, updated, created, deleted, anything. So he has into this file, he has said hello. Now the developer A has written up a hello into this file. So the time, date, and all those things get stored as a version controlling. Version controlling means it will record the things that this particular developer has made these changes on this date and time. How it will be helpful? Let's suppose in future we want to roll it back, or maybe we want to check it out what changes were made on that date and time. So in that cases, these repositories and version controlling will be helpful. Okay, I'm just giving you an overview right now. Once we will do the hands-on activity, you will get better understanding if you haven't worked on this repositories and all. So under the repositories, the example comes of the Git. Okay, that is a distributed version controlling. So that's what it has been explained, that the under continuous development, what does the developer A do? There is a Java application, like I told you. He keeps on making up changes into that application. He will write up some code today. Okay, he will test it out onto his local only. He will try to execute that code onto his local only, and after that he will push that code into the repository. He will push it. Okay, after this changes has been pushed, this particular code and development is done. Okay, development is done means the multiple developments will be done, because one go only the developer can't write up a complete code. He will write up the code into a multiple phases, and once the code is even delivered to the end users, multiple new versions come up into the market. So he will keep on doing the development of that code. That is known as a continuous development. Okay, I hope you have got it. Now it is mentioned and Maven and Gradle. Now these are the three types of compilers for the Java language. All those three are for the Java language. We will discuss about the differences between them in upcoming classes. Like when we will talk about the hands-on activity, I will tell you the differences between the and Maven and Gradle. Okay. Now, continuous integration. The stage is a critical point of whole DevOps lifecycle. It deals with the integration, the different stages of the DevOps lifecycle, and therefore the key is automating the whole process. Now, what happens in case of continuous integration? Like I told you, the developer has stored up the code under his repository. Okay, this is a single repository where the developers have stored up their code. Now what will happen? There will be a multiple stages will be there. Okay, stage 1, stage 2, or you can say stage or task. Okay, under the continuous integration CI, multiple tasks will be there. These are the different tasks. Okay, now in this task you will mention a different thing. For example, in task A you will run up a sonar. I will tell you all those things just on a top overview. You will run up a sonar. Okay, in the next phase, what you are doing, you are building up your building, or you can say the compile. Okay, compile the code. Now, in the next phase, what you will do in this particular task, you will test the code. Okay. Now in the next stage, you can store up the code, or you can push the artifacts. If you're not getting these terms right now, don't worry. You will get it with the classes. Push the artifacts. Okay. Now this complete process, when I'm doing the multiple task 1, 2, 3, 4, when I'm doing this multiple task from one pipeline means the complete set of tasks I am running it up in one go. That is known as a continuous integration. When we are compiling the code, it is known as a CI, the continuous integration. When we are deploying a code, then it is known as a CD, continuous deployment. So when there is a task in between for compiling the code, that is a continuous integration. Okay. So now what will happen? Now connect the dots. Now the developer A has made some changes into the code or the application, the Java application. He will push the changes into the repository. From the repository, this pipeline will automatically try to detect that something new has been pushed onto this repository. If something new has been pushed into this repository, these steps will run automatically. Okay, so what will happen? The developer has made the changes into this code, pushed it to the server. Now from there, it will analyze, this particular pipeline will analyze, yet something new has been pushed into this repository. There's new changes into that repository. It will automatically detect that, and he will run all these steps automatically. Then once this is run automatically, then what will happen? You will create up a artifact. Artifact means the executable file. So let me show you one example. uh, like this is the one of the example. See what is happening in repositories. It's a version controlling, like I told you. This is the repository means where you're storing up your code. Okay, just so in this one, you have a code. This is a code for the application. Okay, like I told you, it creates a history means who has made the changes and when those changes were made. So if you see over here on the update as your pipeline, I have made the changes over the code on 16th November at this time, my last changes. Before that, it was 8/27. If I want to see what changes has been made, click on that one. The red means that this has been removed and green means this has been added. So in this particular sdo.yaml file, you are checking it up that what has been added and what has been removed. So now if in future I want to roll it back, these changes, I can roll it back, these changes. If not required, my manager just want to see what changes I am doing it up, so I can check it from there as well. Okay, so that is the version controlling. Now what will happen, if I have a pipeline? Let's suppose this is a pipeline. I have a pipeline. This is a pipeline known as a continuous integration. Now in this pipeline, what I want, as soon as I make changes into this code, any file, if I make a changes over here, automatically that pipeline should execute. This pipeline should execute means there's a set of tasks into it, start running that all complete steps automatically. So in that case, I will use a continuous integration. So just for a short example, I'm not running this pipeline, I'm creating one empty pipeline, because that's a YAML. You will not able to get it in one session. So I'm creating one open pipeline. So empty job. In this one, you will see the triggers. In triggers, I'm enabling the continuous integration. I am mentioning that as soon as someone will make changes into this repository, this particular pipeline should execute. So let me save it. Okay, now it's a triggering part. Don't focus on failures or success. I'm just showing it for your purpose, like how does the continuous integration work. There is a readme file. In this readme file, I will just add one line. Okay, just a word. If I put a single space as well, what will happen? I commit it up. See, I have just made a single chain and your pipeline will execute. See, my pipeline has started executing it out. This is a continuous integration. Okay, now in the DevOps tools, like we have talked about the CI/CD pipelines. Okay, so now in this case, um, now in this case we have a different tools into the market, which brings up the DevOps as a one concept and how it works. So now in this one, what are the different tools? We have Jenkins, we have Negios, we have Docker, Kubernetes, Puppet, Git, and Ansible. So what happens in the tools? Let me explain it to you in much more deep. Where does each and every tool will help you? So I will give you the list of tools. How does it work? For example, first thing is there's a developer A. Okay, Now this developer A has to store up the code somewhere at a common place from where his or team can see the code and what changes has been made to the code. Everybody can see it. So for that he needs a common storage place, and we call it as a version controlling system. So in version controlling system, for the version controlling system, we have two things. One is known as a distributed, another one is called as a centralized. I will talk about that. So the tools for the version controlling, mostly the people will talk about the Git. Okay, Git is a distributed. I will tell you the differences between the distributed and the centralized. Don't worry, I will tell you tomorrow. There are two things: centralized and distributed. SVN is for the centralized. Okay, that is a version controlling. Now Git is a you can say is a technology, and to use the Git we have a platform like GitHub. GitHub is a platform. Similarly, Git can be used onto a different platforms as well. That different platform means you can use it up a GitHub, or as a you can use a Bitbucket. You can also use up the GitLab. These are the different platforms which provide you the facility to work onto the Git technology. Okay, so that is the version controlling. After the version controlling, we will use up a for the CI part, the continuous integration part. We have different tools into the market. The open source tools means the free tools which is available into the market, and you can set it up onto your site. Either you can use it on your own laptop or a virtual machine, anywhere you want to set it up on your own. Then you can use up the CI tools, like we have the Jenkins, we have Azure DevOps, we have AWS DevOps, then we have the TeamCity, we, TeamCity. We also have the GitHub Actions, and many more are coming up these days. So these are the few of the ones which is very much used into the IT industry. So you have to work on any of these tools. So it CI/CD, I will call it as a CI/CD. CI/CD means continuous integration and continuous deployment tools. These are the tools. Okay. Now besides this, once okay, now this pipeline has been created. Now we will do a monitoring. For the monitoring purpose, we have the different tools like Grafana. So using these tools like Grafana and Prometheus, what happens? You take up the logs from the servers, and then you create up a diagram, the pictorial diagram. Diagram means or a structure. Like for example, you must have seen the share market. In a share market, it shows your graphs. So those graphs are shown through the Grafana or the Prometheus. We have other tools as well for the monitoring, Crologics, many Datadog, many are there into the industry which you can use. Okay, Datadog. Then we have Azure monitoring. We have AWS monitoring. So these are the tools which comes into the market. Besides this, we also have the Terraform. Terraform is used for the infrastructure as a code, IAC. What is the infrastructure as a code? You write up a code for the infrastructure creation. Infrastructure creation means you want to create a virtual machine, for example. You will write up a code to create a virtual machine. So once you will run up that code, your virtual machine will be up and running. That is a Terraform. Then you have an Ansible. What is the use of an Ansible? Like you have a virtual machine, 100 virtual machines. You want to configure them. Now one way is manually log into that machines and run up the update commands or run install the software. Instead of that, you can use an Ansible. Ansible is used for the configuration tool. You can use this tool to run install the softwares onto multiple machines at one go. that is the Ansible. And other than the Ansible, we also have this one which is known as the Puppet. We also have the Chef. So these tools are there into the industry, which brings up the complete concept of DevOps. This is known as a DevOps. Okay, then combination of these tools will help you to learn and grow into the DevOps world. So from each and every site, like from each and every part, you should have a knowledge of at least one tool. Terraform and IAC means Terraform means infrastructure as a code. This is the technology. Okay, Terraform, or either you call it as a tool, which is known as a ARM templates. That is in Azure. Okay, so what happens in Terraform and ARM templates? Infrastructure as a code is a technology. It means you're writing up a code to create an infrastructure. It means, for example, you want to create up a 10 virtual machine. Okay, 10 virtual machines. Either you can create them manually, or you can write up a script or manually. When you are writing up a script to create a 10 virtual machines, then it could be onto a Terraform or ARM templates. These are the tools. Okay, for example, let's suppose you want to post a photo socially. Okay, now if you want to post your photo socially, you have a different platforms. Either you will share it onto a, let's suppose, Facebook, or you can also share it onto a Instagram. So you can say that your motive is to share the photo, your photograph, your image. That is the infrastructure as a code. Now you are using up a different tools to complete that process. That is the Terraform and ARM templates are the tools which will help you to work on it onto it. This is my Azure portal. In this one, I need a 10 virtual machines. In this virtual machines, what I have to do, either I will create that process manually. I will go and put up these inputs 10 times. I will repeat the steps 10 times. I will put up my all information one by one, and then I will create one virtual machine. I will come back, come back, and put up all this information 10 times. Then I will have a 10 virtual machines. Okay. Now, instead of that, I don't want to repeat that work again and again. What I will do, I will write up a code so that my repetition of my work can be reduced. So I will write up a code, and once I will execute that code, my 10 virtual machines will be up and running in just 1 minute. That is known as an infrastructure as a code. Now, for writing up a scripting, like you have a shell scripting, we have a, for example, you have a Java, you have a .NET, different type of coding technologies are available. Similarly, to create up the infrastructure as a code, we have the different technologies, which is known as a Terraform tool, Terraform, or either it is a ARM templates. What's the difference between them? Terraform is a tool which was created by another company. ARM template is one of the tool which is created by the Microsoft. So that is a difference between those tools. You write up the code into these as well, and you run up an infrastructure. Okay. I hope you must have got it. If you have not, it's fine for now. Once we will come up onto these topics, you will get a more clarifications. Okay. Now the continuous development, like I've told you, what is a continuous development? We have to do a version controlling. So whenever you see this sign means Git. It is a Git repositories. So in the continuous development, what the developer is doing, he is making up the changes and then pushing up those changes into a repository. Repositories, I will tell you how to create it, how to work onto it. So in a repositories, what are you doing? At a common place, at a common server, you are storing up your code. Code means the application code. For example, you are creating a facebook.com. You will write up some code and you need to store somewhere. For there, it's a common location where you're storing it up. That we call it as a version controlling, and that is the Git. Okay, whenever you see this kind of sign, it means Git. Okay. Now continuous integration. This is the sign of a Jenkins. Jenkins is, like I have told you, it's used for the continuous integration and continuous deployment. So I hope you have understood what is CI/CD. More about the Jenkins and hands-on we will do in upcoming classes. Okay. Now continuous deployment. Now in continuous deployment, it can be deployed onto multiple uh, uh, continuous deployment is deploying a multiple your code to a multiple servers. It could be virtualizations and containerization or through the configuration management. I will tell you these things. What is virtualization and containerization? We will come up to the topic of Docker. When we will come on to the Docker, I will talk about these things. Then continuous testing. What happens in continuous testing? Like I told you, this is a Selenium, one of the tool for the continuous testing. It's a automation testing which is used over here. So that is the one. Selenium is a portable software testing framework used for web applications. It is an open source tool which is used for automating the test carried by out on a web browser. That is the Selenium. Continuous monitoring, Nagios is one of the example. Over here I have given you the example of Grafana, Prometheus, Datadog monitoring. So similarly, Nagios is one of the tool used for the continuous monitoring. So now in these tools, see each and every tool is working in which phase. This is a developer. He has made some changes onto his file, the code file. Automatically the GitHub is a platform, okay, on which the code it will check that yeah, some changes has been made. It will tell Jenkins that yes, some changes has been made, please execute the pipeline. It will start running up a set of tasks one by one. Okay, once this pipeline is successful, it will start deploying that code onto a testing server, and testing server also, and from testing server it can go to the production server. Now once it is deployed onto the production server, there will be a feedback and continuous monitoring will be done onto the production server. Why we do a continuous monitoring on production server? So that we can know how's the experience of the users onto the applications. So once we will get the feedback and monitoring reports to the developer, he will work according to the feedback. Again, these steps will keep on going up throughout the when we until we are using up that product. So what is a version controlling? Version controlling is a system that records, manages changes to document, computer, programs, etc. over time. It helps tracking changes when multiple people work onto a same project. Now, what do you mean by this? So what happens, like I have told you, let me open up a clear page. Let's suppose there's a developer A, okay, dev A, and there's a developer B. Both are part of a same team and they are working onto a same project. Let's suppose we have the facebook.com. They both are working onto a facebook.com.
Let's have a quick quiz question, guys. And the question is, what is the use of Git? And your options are containerization tool, continuous integration tool, version control system tool, continuous monitoring tool. Please mention your answers in the comment section below.
Just a quick info guys, if you want to make a career in cloud computing, then Intellipaat provides an advanced certification on cloud and DevOps by IIT Madras. This course is taught by industry experts and IIT Madras faculty. This course is designed to upskill and land your dream job. Now let's continue with the session.
I'm writing in short fb.com. They both are working into this company and they're working on to one project, fb.com, developer A and developer B. Now you know there are multiple features into a application. And when you go to the Facebook, you have multiple features. One is for the login. Then you have the upload the videos, upload the photographs. Many features are there. Now developer A is working on to a feature called as photographs, and developer B is working on to another feature. It is a videos. So both are working, but the ultimately that the both of the features are of which product? That is the facebook.com, correct? He is working on to the images. He's working on images now, and the another one is working on to videos. Both of those features are of which product? facebook.com, correct? Now what will happen? Developer A is writing up some code, developer B is writing up some code. They both need to store the code somewhere. One way is they will store up that code onto their local, that is their own laptops. Okay, local means their own laptops. They will store up the code onto their own laptops, developer A also and developer B also. But now we are making up a product facebook.com. This particular code should be at a common location, because why need a common location or common directory or storage account? Because if developer A wants to see the code of developer B, if developer A wants to see the code of developer B, he will go to that common repository, the common server. Okay, so what will happen? He will go to the common server and watch out the code, what a developer B is doing. And similarly, developer B can also see what developer A is doing. Even we need to have the common server, because if the developer A leaves the company, he will take his laptop, or maybe that laptop will be submitted to the IT team. But that code will also go with him. We will lose that code with him. Is it a good way to store the code locally? No, you need some common place, the common server, which should be active all time, which should be up and running all time, and where any user from the company, I mean, who have the authentication, can go ahead and read up the code, what is the code has been written, and what is the changes has been done recently, and what is the progress of that project. We need a common server where we can store up that particular code. Now, one way is either we can do a copy paste of that folder, the code folder, into any remote server. Is it a good way to copy the code into a remote server? We can copy it up, we can take a backup, but it's not a good way, because if a developer A is making changes into that particular code, the file, will we able to get it, know that what files changes has been made? No, because we don't know. There is no software to control what changes has been made. There is no software to record those things. Now to record those things, what changes has been done, when it has been done, and who has made those changes, we have a software called as a version controlling. So version controlling is a concept in which you do a historical, or you can say create a history, you keep a records of the changes you are making up into that directory. Okay, so in short, version controlling means you are recording the changes made to the directory, files, folders, anything. If you're making any changes into the file, folders and all, it will keep a record of it, in which it will show who made the changes, who, when, and it also helps you to compare. Okay, version controlling is a particular technology. Now to work onto the version controlling, we have the two things. One is called a centralized and one is called a distributed. Now, what is the difference between a centralized and distributed? So in case of, let's suppose there is a one machine. Okay, this is one machine. Machine means this is a virtual machine. Virtual machine, it's a laptop or any device through which you can interact. Now, if there in this particular file, in particular laptop, you are storing up your code. Okay, this is a common server. This is not a developer. It's not a of developer. It's not of developer. It's developer B. It's a common server, common location. Okay, common server for the team. In this one, you have a directory. Okay, one folder. In this folder, you are everyone. Developer A is also making up the changes. Developer B is also storing up the changes directly. Direct changes to this machine. When you are making up a direct changes onto this machine, directly you are making up the changes. If it's a developer C as well, developer D as well, you're directly making up a changes into this folder and saving it up. Then we call it as a centralized. It's a common place. This is a common server where they are making up a direct changes. Then it is known as a centralized. Okay, directly means for example, there is one virtual machine. I'm directly making a changes into it. I'm not storing it in my local. I'm directly making changes into it. Then that is known as a centralized. Other one is called a distributed. What happens into a distributed? You clone the code. For example, there is a folder. Okay, folder, or you have a directory, which we call it as a repository. Okay, that is available onto the server. This is also on server, but you clone the repo on your local machine. Every developer will clone the code onto its local machine. In case of distributed, what they will do, they will clone the folder. Let's suppose there is a machine, this is a server. Okay, from this server and machine, every developer will take up a clone onto their local machine. Okay, now they will make the changes into their local machine. Now what they will do, they will make changes on local machine and push those changes to the server later on. Now what they are doing, they are first taking up the code onto their local, they will make the changes, and then again they will push it back to the server. Now what are the advantages of the distributed? Let's suppose there was a server and that server goes down. Still that code will be available to you on let's suppose the developer A, B, C, D are working. They will say, don't worry, we have a copy of that code on our own machine, so we can push that code again. That is the one advantage. Another advantage is, in case of distributed, even if you don't have an internet connection, you can still work, and later on when you will have the internet connection, you can push that changes into the server. But in this case of the centralized, if you don't have an internet connection, then you will not able to make the changes into the server because you don't have an internet connection. So until you have an internet connection, you can't work onto this particular server. So that is the difference between the centralized and distributed. Now the examples of the one under the centralized category is we talk about the SVN, or into the Azure DevOps we have the TFVC. In case of distributed, we call it as a Git. So Git is a technology which comes under the distributed. Git means when we talk about Git, automatically it means distributed. Now developer will clone that code onto his local system, and then he will start making up the changes into the local system. That is about the distributed and Git. Now to work onto a Git, we have a different platforms. Different platforms means there are different companies, those support the Git. So let me tell you in a layman language. For example, you want to purchase a car, four-wheel vehicle. Okay, four-wheel vehicle, you want to purchase it up. You want to purchase a car. Now there are different companies, those manufacture the car. So over here, I want a car. You can compare it as a Git. Okay, Git is a product. Now you want to use it. So how you can purchase from the different companies. Either you can purchase from GitHub, Bitbucket, or either other companies are there. You can purchase from anyone. So Git is a main part. Git you can compare as a car, and the manufacturing companies of the car you can compare it as a GitHub, GitLab, Bitbucket. People usually get confused because these companies have kept the name of their product as GitHub. So usually people think Git is a product of a GitHub. It's not like that. Git is a technology for the version controlling used by the distributed system. So you can take it like GitHub is a common place. The GitHub is a server which a company gives you as a storage, as you storing up your code over there. There is a example. GitHub is an example of distributed because you are creating up a Git over there. In case of Azure DevOps, we can create both of them. So if I tell you in this Azure DevOps, we have both of them, centralized also, GitHub also. Oh, sorry, Git also. If I create up a new repository, you see this option, Git and TFVC. TFVC comes under the centralized. Git comes under the distributed. Like for example, you want to purchase a car. You have a four-wheel vehicle, you want to purchase it. So that is the basic need. So Git is a car and GitHub is a platform. Like you, if you want to purchase a car, many companies provide you that feature of car. You will go to Mercedes, BMW, any company to purchase up a car. So Git is a car, and GitHub you can compare as a manufacturing companies. Those are providing you a facility to work onto that Git. Internet connection means like if you are losing up a connection for some time, it's fine. Always you take up a backup as well. Your data will not be lost. We always take care that backup should be there. It's not too easy to lose up the data. Problems we've now let's talk about what is a version controlling. I hope you must have got it. Let's talk about through the slides. Imagine developer A creates a software and starts a company with this software. Okay, this is a developer A. Now as the company grows, developer A hires more people to enhance the feature of the software. Developer A shares the source code copy with each of them to work on. So version controlling can be done in multiple ways. Version controlling can be done and can be used in multiple scenarios. One of the scenario I have told you, like to create up the history of that particular code, what changes has been done. It can be used to share up the code with the other people. You can do it you can use up a version controlling for multiple reasons. This is one of the reason which we are explaining into these slides. As the company grows, developer A hires more people to enhance the feature of this software. Developer A shares the source code copy and each of them to work on. Okay, so now developer A had a code. Now you want to share that code with the developer B, C, and D as the team is growing. Now developer B enhances the software with feature and submits it to a developer A. So see in this one, what version is shared? Version 1. Now in next slide, the developer B has made some changes like version 2. Now he is giving back to developer A and telling him that yes, this work has been done. That is the version 2. Developer A verifies the changes, and if all looks well, simply replaces the code with the main software. So developer A have verified that version 2 is perfectly fine. So he has made that deployment onto the server. That is the now version 2 is the one on which the users are working. Okay. Now the problem starts here. Developer C also finishes work and submits the changes to developer A. But developer C worked on the code for versioning 1. So what has happened? Developer A has when he submitted to developer B, it was version 1. Then the developer B gave it the version 2. Then it's a version 2 which has been deployed over here. Now, but the developers still have the version 1. Although there was a version 2 available within the team, but developer C was having the older version 1 only. He was not aware that developer B has created a version 2. He was making up a changes on version 1 only. Although the thing should be like this: 1, 2, 3. Developer C should work on version 2, but instead of that, it at the initial stages, version 1 was given to that developer C, so he was working on developers this one version. So the whatever changes were done by developer B has been skipped by the developer C. Now there is a confusion with the developer A. If he puts up the code of the developer B, then version 2 will run. If he puts up the developer C, version 3 will run, which will not include the features of version 2. There is a conflict. Okay. Then developer A verifies the feature, takes the code and manually integrates them with the version 2 code. So what developer A thought, okay, let's do like this. I have version 2 and he has brought up version 3. I will manually make some changes and integrate it. Now version 3 has been deployed. Similarly, when developer C is done with his work, submits the work to developer A, developer A verifies it, manually integrates the changes with version 3. Okay, now he is making up the changes. Now the complete setup, what we understood the problem, versioning was manually. Who was doing that versioning? Developer A was doing that manually. He was making up the changes manually. Team collaboration was a time-consuming and hectic task. No easy access to previous versions. Multiple versions took a lot of space. So you can understand in this complete scenario, when we were not using up a version controlling, these were the challenges which people were facing it up. Okay. Now advantages of version controlling. Versioning is automatic. Team collaboration is simple. Easy access to previous versions. Only modified code is stored across different versions. Hence save storages. That is the advantage of the version controlling. Okay. Types of version controlling. Now we'll talk about the version controlling. There are two types: version controlling. Sorry, centralized version controlling and distributed version controlling. These are the two things. Remote repo, local repository. So what happens, as I have told you through this diagram, I was telling you, and now the things will repeat for you, Nikita, as you have requested. So types of version controlling: centralized version controlling and distributed. What everybody is doing now, see, in this one, every developer is making up the changes to the remote server directly. Push and pull. Push and pull means whatever changes you are making it up, then directly you are making up to a remote repository. Okay, remote repository means remote server. In case of this distributed version controlling, what you are doing, you are making up a clone. You are copying up that code into your local, making those changes to the local, and then you are pushing up those changes into a remote repo. That is a distributed version controlling. I hope you must have understood with this diagram. Now, centralized version controlling system has one single copy of a code in the central server. Developers have to commit their changes in the code to this centralized server. Committing a changes simply means recording the changes in the centralized system. Surendra, most of the people use the Git only. 90% of time we use up a Git. Git means distributed. Now version controlling. In distributed version controlling, one does not necessarily rely on central server to store all the versions of the project file. Every developer clones a copy of the main repository to the local system. This also copies all the past version of the code on the local system too. Therefore, developer needs not to be connected to the internet to work onto the code. This is the advantage of the distributed system. For example, you want to store up videos or some high files, high data. Some files are very huge in size. For that case, distributed is not good because if you make any changes into it, then it will record those changes and the size of your particular repository will increase. Now, if you have to clone that repository onto your local, you will have to create a multiple copies. So what happens on a background when a Git, when you do a version controlling on a Git, it creates a copy of that code. Multiple copies are created of that file. For example, there is a 1 GB file. Okay, now you have made some changes into that file, 1 GB file. Again, it will create a copy of that 1 GB. So you are creating up a multiple copies of that file for the version controlling. So in that case, 1 GB, 2 GB, 3 GB, 4 GB. So if you have made to that files 5 times, now instead of 1 GB, it is consuming your 5 GB of space. That's why it is saying it is uh, not good to store a large files on Git. Okay, example of centralized version controlling. Subversion we called as a SVN. Another one is Helexic core. Another one is TFVC. These are the examples of the CVCS. CVCS means centralized. Now, SVN, Apache Subversion is a software versioning and version controlling system distributed as open source under Apache license. It's a based on centralized version controlling architect. It they developed started in 2000 and the version finally became available in 2004. It is still constantly being developed by a small but active open source community. As SVN is not used much more actively these days, that's why there's not much progress onto this side, but a few people are still working onto this SVN. So there is a centralized version controlling. Disadvantage of SVN constantly needs internet connection for any operation. When we talk about SVN, it means centralized. Version history is not downloaded or maintained onto a local system. Slower than DVVC. DVVC means distributed version controlling system. Since requires internet for every operation, conflicts can have to be resolved manually. Okay. Example of distributed version controlling. We always talk about the Git, but there are many more. Perforce and the Mercurial. They are also example of the distributed, but we always use the Git. And popularity for Git is too high. Everybody knows Git, how to work on Git. If you are working into the software development side, then you should have the knowledge of the Git, how it works. Okay, now introduction to Git. See the popularity of the Git among all other DFVC tools. So you can see how much highly Git is used. We will talk about the introduction to Git. Now I have told you yesterday as well, Git is the most popular tool among all their DVCS. DVCS stands for Distributed Version Controlling System. As you can see over here into the chart, when you even if you have talked about these tools into the IT industry person, they will always talk about the Git. Okay, so Git is the most popular tool for the version controlling. Now, what is Git? Git is a version controlling system for tracking changes in computer files and coordinating work on those files among multiple people. It is primarily used for source code management in software development, but it can be used to keep track of changes into any set of files. So what do you mean by Git? What happens? Let's suppose there is a developer A. Okay. Let's take this is a developer A and he has a laptop. He has a system. Okay. Over here, it is a system and in this system he writes up a code and stores up a code. Okay, now he want to share that code with the teams. Okay, his team is here, the developer B, C, and D. This is developer A. Okay, this is a developer B, C, and D. Now he wants to share up this particular code which is in his system to these guys. So one way is either he can copy into a pen drive and give it to B, C, and D. Will it be feasible? No. If he gives them this code, okay, one time he has given up in a pen drive. Now second time, if he has made some changes into that code, now how will he give back to the B, C, and D? Will he again copy it into a pen drive and give him to them, or maybe into some local or maybe some remote directory? Will he copy the code over there and give it to them? It's not good and it's not feasible. And even developer B, C, and D will make some changes. How they will make up the changes into the code, how they will transit between the code between each other, and even how will you identify that there is a lot of code is there, lot of files are there, who has modified and when it was modified. Now when you have this one, the code is there and everybody is making up the changes, you want to track what changes has been made and who has made those changes. Now to do that part, to make a record of those changes and all, we have a tool called it as a git. Git is a version controlling system. So there will be one folder. Okay, there will be one folder. Now it will have a multiple files into it. Okay, whenever you will make any file changes or any code changes into these files or into this folder, that will be tracked, that when you have made those changes, and once you will push up those changes into the remote repository, then developer B, C, and D will able to see it. Okay, so today we will do some hands-on activity. I will show you how to do that part. Okay, now Git lifecycle. So what happens in Git lifecycle? So first we have a working directory. Like I have told you in this one, you have a working directory. Okay, this is a folder. Folder is known as a working directory. A working directory means the folder in which you are making up the changes. Okay, in this one you have multiple files. Okay, a 1 2 3 4 5, in which you will modify your code. Okay, now in this part you have a multiple directories. Now you have a staging area. Staging area means that you have made the changes, it's waiting for the commit. Commit means to properly save it. There are two things. One is you have a file. Okay, you have a file. In this you are writing up a code, you have made the changes. Now there is a one more thing, that we save the file. Okay, you are saving up the file. After saving up the file, you put up that things into a pause state. Okay, these changes has been made, I will push those changes all together. That is a staging area. It's waiting to get in commit, it's waiting to get it a final saving part. So that is a staging area. After that you commit. Commit means now you have finalized that yes, we are good to make the changes and to save up the changes. In that case you will use up a commit. I will show you how these things come up. For each and every stage we have the different commands. I will show you to how do we do it through the uh, how to do it with the command prompt and how to do it with the other ways. Okay, going further, what is a working directory? The place where your project resides in your local disk. The project may be or may not be tracked by Git. In either case, the directory is called a working directory. The project can be tracked by Git by using up a command called git init. So what happens? Yesterday you have installed the Git onto your system. Okay, let's suppose after installing up a system, you will think that I will show you how to first confirm that Git is installed or not. This is the command. You once you will run up your Git version command onto your command prompt into your system, you will get this output. if you get this type of output, it means it is installed successfully. The Git version could be different from mine, but it means that your Git is installed successfully. Okay, now yesterday I've asked you to install a Git, and I'm telling you that once you have installed the Git, then it will be controlled. Your working directory will be controlled. Controlled means the history will be created to that folders. So your question will be like, okay, yesterday I have installed the Git. Will my all the folders of my system will now be having a version controlling system? I mean like next time when I will make some changes into this particular folder, any random folder, will it start recording up the history and the changes? No, it's not like that. You have to initialize. You have to tell that in which folder or which folder you want to track. Uh, 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 I mean, like you have to tell the software that I want this folder to be tracked. This folder to be tracked means whatever changes I am making to this folder, that should be tracked. And how to do that part? Okay, so let's suppose there is a one of the folder. This is an empty folder. Do you see this is an empty folder? So what I will do, I will open up the location of this empty folder into the command prompt. So see this one. Currently I am in which directory? I am under this folder, DevOps material, and this is a December batch. So I am into this particular folder location. So this is a basic Linux command. So I hope you all should know how to change up the directory, how to open up this directory. If you don't, let me know. I will tell you how to do that part. So this is the directory. If I run up any commands right now, then those commands will be executed onto this level of the directory. Okay, now in this one, I want that whatever changes I make into this folder should be version controlled. Version control means the history and the changes should be tracked. So what I will do, I will run up a simple command called as git init. Now, as soon as I run the git init, it means initializing the empty git repository at this location. So as soon as I have executed this git init, you will see one of the this .git folder got created over here. Okay, how it happened? I just went to this location of the folder, the directory, and executed git init. Git init means initialize the git over this directory. Now, as soon as I executed, this is a hidden folder. So if you, after running up a git init, you don't see the .git, then go to the view, and from view you have to check this box, hidden items. So once you will check this box as hidden items, you will see this .git folder. Now what is this .git folder? This is a folder in which you will have all the configurations of your Git repository. Okay, I will tell you there are different type of files and folders are there into this one. So each and every folder will have their own information. So if you think like your changes, whatever you're making up the changes, how this software is tracking, how the software is storing up in a background, these are the files and locations where your all the things will be saved. Even your user credentials will be stored under the configuration file, so that once you have configured your Git and GitHub over here, a video, I mean like remote repository and your local repository, if you have configured it once with your credentials, next time you don't have to put up your credentials again and again, because your configurations will be saved under the configuration file. Okay, so this is the .git folder in which your all information will be stored. This is called a Git cheat sheet. Git cheat sheet means that there are lot of Git commands, but we want a complete list of commands into one page to understand their working, so that in future if I want to do some work and I don't remember a command, I can take a reference of this particular PDF. So we will be doing it up. These git init. You did a git init. Okay, that is your folder is now initialized. Now we will be using up a different commands to learn how does it work. Okay, so in this particular one working directory, as I have told you, git init. What happens with the git init? We are initializing the git into that particular working directory. By doing git init, it automatically creates hidden .git folder. As you have seen, did .git folder got created. Second, staging area. Once we are in the working directory, we have to specify which files are be tracked by Git. We do not specify all files to be tracked in Git because some files could be temporary, which is being generated while execution. To add files in staging area, we use the command called git add. Okay, now this is the folder. Now in this now I will make some changes into this folder. Let's suppose I am creating one text file. This is a normal text file. Okay, let's make some changes and say hello, and I am just saving it up. It's a normal saving. Okay, till now this particular file is not being tracked. We have not made anything over here. So what we will do now, I want this particular file should be tracked, and the records should be kept. So I will stage this area. How to stage this one? I have this file. Let me close multiple here. Okay. Now in this one, in particular directory, I want that the changes which I make into this file should be tracked. Like changes will be every time I will make a changes manually, I will track those one. So in that case, what I will do, I will run up a command called git add. Now there's one more thing. In this particular folder, now did this particular folder, December batch, I have initialized the git. In this folder, let's suppose I have two files. Okay, let's suppose there are two files. A new text document 2, new text document. I want the changes into this file should be tracked, and this file should not be tracked. So what I will do, I will use up a command git add, and just put up the file name that which I want to be tracked. In the file in which I have made the changes, and I want to be tracked. You can make a single file change as a committing part, as a staging part, or the other option is I will use up a git add and put a space and dot. Dot means whatever is there into this particular directory. Which directory? December batch. That should be saved. That should be staged. As soon as I will click up the git add, you will see you will see it has started over there the tracking of these particular ones. See, the color has been changed. So now it is into the staging area. How to confirm whether it is in a staging area or not, or any other area? You have a command called git status. So now do you see, this is our main branch. Into this one there are two files which is been staged. Okay, green means it is been staged. It is been staged but not yet committed. It is the saved one. So what is the staging area? Once we are working with a directory, we have to specify files been tracked by git. To add files in the staging area, we use the command called git add. That's the command which I have used over here, git add. And dot means, or dot means that I want to stage the complete directory. Complete directory means this particular folder, the complete folder I want to stage. Whatever files are there into that folder, I want to stage them. So I am staging that particular complete folder into this using the command called git add. And git status will show you what is the current status of that particular folder. Okay, now it has been staged. Now next command, git commit. Once the files are selected and ready in the staging area, they can be saved in the repository. Saving a file in the repository of Git is known as doing a committing. When we commit a repository in Git, the commit is identified by commit ID. The command for initialize the process is git commit -m the message. So this is the now I have committed up. Now I want to save the changes under the Git. Okay. Earlier we have saved the changes in the folder, the normal changes. Now I want to save the changes under the commit. You will save up through this git commit -m, then the message could be like learning, anything. You can put up a message and save it. Now if I check again my status, let's see what is happening. Git status, it means everything is fine. Everything, the changes into this directory is fine, nothing to be checked it out. So now in this one, you will see, once you will do this git commit, one of the unique ID also gets created. This unique ID will be unique every time to identify. Let's suppose I am making up a multiple changes. Okay. Now I want to roll it back my changes at some point of time. So this particular ID will help you to do that part. So let me tell you what is a commit ID more in detail. So what happens, let's suppose there is a file. Okay, in this file, I have first written up hello. Okay, in this hello, I have committed those changes and a new ID got created. ID, I am taking any random 1, 2, 3. Now, after that, sometime I have realized, no, I have to write hello world. And then again, I've committed those changes, saved those changes under the Git. And again, your unique ID will be created 4, 5, 6, 7. Okay, this is have a unique. This is have a unique. Again, after some time, I thought, no, I want world hello. I have made those changes. Now again, those after saving up those changes, another unique ID will be created. Now we have a 3 unique IDs. After making up all those changes and saving it up, your manager came up and said, why you have written up a hello world or world hello? I don't want that. I want hello only. So he wants to see which commit ID he has made up those changes. So what we can do, he can roll the whatever changes are there currently, he can roll it back to the hello using this ID. He will tell the Git, I want my all changes back from this particular ID. So whatever changes will be there onto this commit ID, that will come back. So you don't have to do it manually. The changes, it will come back automatically. In the you might be thinking, why can't we delete this world and it is done? See, in this particular example, there is only one keyword in which we have to make up a changes, but in a code, there are multiple places, very small places are there where you have to make up a changes like comma, hyphen, all those things. You can't redo those changes by your manual process. You will not able to uh, remember where you have made those changes. So that in that case, these commit IDs will help you to recognize what need to be done. Okay, CMD is a command prompt. So if you heard about Linux, Unix, so when there are multiple ways to interact with your system. One way is through the GUI. GUI means you are interacting with the when you have a mouse, you double click on them, you can see the files and folders, you can operate it through the clicks. Other way is you want to work, you want to interact with the computer, so you will be using up the commands. So basically most of the time when you have to work with Linux, you have to work with those commands. Okay, now see this one. Do you see this particular command, git log? This is the command using this command, see, a unique ID was created over here. This is the commit ID. You don't have to remember the commit ID. This commit ID gets generated automatically. Now, if I want to see what all commit IDs are there, this is the git log command, which will help you to get the commit ID. It will tell you what who has made the changes, when those changes were made, and this is a message. Do you remember? I have put it this message. So this is a message. Okay. Okay, let's go further. I hope you have understood these three things: working directory, staging area, and commit. So this is a Git life cycle. So both, if you want it, okay, this is a file. I am putting some text over here. 1, 2, 3. Save. It is now saved. This file is saved on my local. See, this particular has been changed. Red means that something has been changed into this file, but it is not yet committed. So to commit again, I will use the command git add dot. Once it is committed, again I will run it up a git commit message. Message could be like, let's suppose now I am making changes in file 1. Now these changes has been made. It shows you one file has been changed over there. Now again, if I check up a git log, you will see another git ID will be created. This again, this ID has been created. It is unique. This is the first ID. This is a second ID. This is a unique. Git lifecycle. Program workspace. Git initialize working directory. Stage files in the working directory for commit. Files commit to Git repository. This is the complete process which goes on over here. So every time a developer make a changes into the code, that will be first initialized, staged, and then it will be committed to the Git repository. Now still these changes are onto my local. It's not onto a remote repository. Now we will see how we will push those changes to a remote location. Remote location means remote server, where from where other developers can also see what changes I have made. So we will see that part. Currently the changes is on my local. Whatever I'm doing, I'm doing it on my local. Now we will see how to work on to a to a remote repository, how to push it. We will see in upcoming slides. Now, how do we collaborate with the team? So once the files are committed, they can be pushed to a remote repository such as GitHub. We are taking up an example of GitHub. It could be anything. Okay, it could be anything like GitLab or anyone. Okay, now in this one, we are talking about a platform GitHub. We will do a hands-on activity on GitHub as well. Instead of that, you can store your code onto a GitLab, Bitbucket, Azure repositories, anywhere, depending upon your platform, which one you want to use. This is the complete thing, how the process goes on. A developer will make up a changes into the local, for a particular local file. He will initialize, he will stage that files. He will commit those changes into his local, then push those changes into a remote repository. Repository means a remote directory, you can say so, where all the changes made by the developer will be pushed. Okay, from there the other team members can view it, and even if they want to make some changes, they can make up the changes as well. Now, how does the Git work? Any project which is saved on Git is saved using a Git using a commit. The commit is used using a commit ID. I've already told you there will be a commit ID. I have also shown you this is the commit ID. Whenever you're making up a changes and then you're saving, you're committing it up, then a unique commit ID gets generated. When we edit the project or add new functionality, the new code is again committed to Git. A new commit ID is assigned to modified project. the older code is stored by a Git and will be accessible by its assigned commit ID. So do you see now? This when I have made changes into that file and redid that recommitting, again a new unique ID got created. Now all these commits are bound to branch. Any new commits made will be added to the branch. A branch always points to the latest commit. The pointer to the latest commit is known as a head. So in this one, do you see this one? Head and master. Head and master. Head means a master is a branch. Let's talk about what is a branches and how does it work. Okay. Now what happens? There's a concept of branches into this repositories. The Git. What is the branches? Like you must have seen the tree, correct? When you see the tree, what happens in tree? You have a main stem, and then there are further branches coming out of it, correct? Similarly, in case of repository also, we have a main branch. This is called as a main branch. The like in a tree, you call it a stem as a main. Why call a stem as a main? Because your complete tree is standing onto a main branch. That is a stem. Similarly, in this case also, when you will creating up your repository, automatically one of the branch, or you can say the branch will be created, that is will be called as a master or main. Some at few places, few platforms call it as a master, few platforms call it as a main. Okay. Now even you can change it up to master or main, it depends upon you, but automatically when you will create any repository, one of the branch will be created, then that will be either master or either it will be a main. By the name itself, it means it has a more importance than the other branches. Okay, this is by default. Whenever you will create a repository, this is by default. Okay, this is a default branch. Now further, if you want to work, then you create up your own branches. What is a concept of branches? So let's suppose you have this main branch. In this main branch, you will always store up a production code. Production code means prod code, or you can say finalized code, which you want unchanged. Unchanged means, when the developers will work, when they will do some testing, they will write up a code. They will make changes into a file multiple times, but you don't want that. You want that at one folder, at one location. You should have the perfect code. Nobody should touch it, and the other file and directory should have the other code on which you can play. So always think about in your day-to-day routine. You always try to keep up the things, the finalized things into one side and other testing things onto another side. You don't want to touch the material which has been finalized. You don't want to touch them. So similarly, in this master and the feature branches concept is what happens. You have created one of the main branch. You said, okay, this is a directory in which you will put up a finalized code. Nobody is allowed to make changes to that particular location. Besides this, if he wants, he can make the changes into his own directory. Okay. So what you will do, you will from the master branch only, you will create up the sub branches. Sub branches means these are the branches. Okay, these are the branches. Branches 1, branches 2, branches 3, branches 4. Branches 1, branches 2, branches 3, branches 4. Now what you will do, you will add the same files which were there into this master file. For example, into a master, if there is a ABC file, okay, abc.txt or xyz.txt. These are the two files which is onto the master branch. Okay. Now you want these two files onto your own directory as well. Directory means where you will play on these files. You want to make up the changes, anything you want to do, you want to make the changes, but you're not allowed to make it to the master directory. So you will create your own branches, and once you will create up your own branches, those two files will be copied onto these branch, into your particular repository, or into your branches. This branch you can name it as a dev A. By the dev A, we will get to know this is a branch for the developer A. So developer A will be making the changes into this directory. So now this developer will make changes into this directory. He will now what will happen? Whatever changes he is making into these files, into this directory, will remain over here only. It will be limited to here only. Okay, this will be limited to his directory only, and the files which is onto a master, that will remains unchanged. This particular changes which the developer A is making onto these files into his branches will be remain onto his side only, onto this branch only, and it will the master branch, the master code will remain unchanged. Once he's fine, developer A is sure that okay, my code is now finalized, I want the same changes to be onto the master, then he will raise a request which is known as a pull request, or you can say a merge request. Merge request means okay, merge these changes into my master, merge these changes into my master. So once you will raise a request to merge it, the code, the changes which developer A has made onto this files will now be reflected onto this master. So this is how other things work into the IT industry. Okay, that is a concept of the branches. So I was explaining you the concept of branches to tell you that when you were running up these commands, that time you must have seen the master. So the changes which I was making up into the files, and those files were stored where? Those files were stored under this master branch. Okay, those are under the master branch. Okay, so in this we have talked about the branches. Now what we will do, there was a person who was facing up the issue onto the system. Okay, so now in this one, if you are talking about the git config global username and git config global user email. So what happened, if you see this one, when I was running up a git add and git commit, at the git commit, a commit ID was created, and that time my username and email address was saved. Because let's suppose if I want to push my changes into a repository, okay, at that time, to identify who has made those changes, a username and user email ID should be mentioned. So that's why I don't remember her name. She was sharing her screen that time. She has shown up the error, and error was saying please configure the username and email address for your repository, so that when she will run up a git commit, when the commit ID will be created, automatically author details will be saved from there. And these author details, where are these saved? These are saved under the .git folder under the configuration file. So in this particular file, your username and your user name and user email ID will be saved, so that whenever you will make up the changes, automatically those author details will be fulfilled. Okay, now next question. Now as I've told you, this particular repository is on my local system. Okay, but I want it onto a particular remote server, so that everybody can see the changes onto my repository. Whatever changes I am making into a repository, anybody can see it. Anybody, by anybody I mean from my team. Okay, so in that case, what I will do, I will use any one of the platform. The platform which we are using up for learning purpose over here is GitHub. So in a GitHub, what you have to do, I'm giving you one thing. This is a GitHub. I hope everybody has created the account onto a GitHub. Now there are few of my repositories over here, which I have used to teach the students earlier. Today I will also create up one more repository. In this one, to create up the repository, once you're logged into GitHub, go to the repositories.
Just a quick info, guys. If you want to make a career in cloud computing, then Intellipaat provides an advanced certification on cloud and DevOps by IIT Madras. This course is taught by industry experts and IIT Madras faculty. This course is designed to upskill and land your dream job. Now let's continue with the session.
Okay. Now these are the list of repositories which is available in my GitHub account. Okay, let me remove this one. I don't want it. So settings. Okay, so now once you go to the repositories and you want to create your own repository, like I will be creating a one repository which we will use for further learnings throughout this. Even I will store the files, any teaching material, any study material over this repository. Okay, so to create up a repository, I will go over here. There's an option called as new. Click onto the new. Okay, now I over here there is option called as repository name. So I'll put some repository name. Let's suppose December batch. So here is a description. Description. If you want anything like you want to pick up some notes for related to this repository, then you can put up under the description. Otherwise, you can ignore it. Then there are two options: public and private. What do you mean by public repository? Public repository means if I will create this repository and give and share the repository URL with anyone, they will able to see the content of this repository. Okay. Another one is private. Private means only people who have access to your repository will able to see the content. Otherwise, they will not able to see the content. So for now, I am using a public. Okay. After putting up a public, I will create one this repository. These are the other options. I will come back and show you. We will create a multiple repositories and I will show you what are the different uses. So now in this one, I am putting up an option called as create repository. After creating up this repository, okay, this repository is created, but it's blank right now. Now I want my local repository and this repository should communicate. Communicate means whatever changes if I make into this repository in future, the steps which I'm going to do right now will be one time. After that, once it is done, okay, after this is done, you don't need to do it again and again. This is only one time which I'm going to do it right now. So what I want my local repository should be synchronized with this remote repository. What I will do, there is a command. This is the command git remote origin, add region, and I will copy this one, go to this particular directory, this my CMD. I think it's not copied properly. Let me recopy. So once I have executed this command, it means now they both are communicating. Now I have set this particular repository to my configuration file. Now I will use this command to git push hyphen origin. So it will push my changes to this particular branch. Okay, 1 second. I think it's master. public I have to re-log in and do this part. One second. I think my configurations are not done properly. Uh, One second. Let me recreate it. Okay. Now it is done. It's a master. Okay. So okay, now actually my earlier the issue came up because, okay, let me tell you, in this Azure, sorry, into this GitHub, we have two types of authentication, HTTPS and SSH. Earlier, I was using up the SSH. For SSH, we need a private key and public key. And for HTTPS, we need a username and password. So that time, I was using up this. If you see my command, by mistake, I have copied up the SSH command. For SSH command, I need to have a private key. You see, public key and private key, but in this one I was running up a wrong command, because of which I was getting this error. So as soon as I change up my command, it worked fine. Okay, so now in this one, onto my local, we had a master. Now in this one, when I created up this particular repository, it was having a main. So that's why I told you, sometimes some companies or some platforms call it a master and some call it as a main. So now in this one, I have pushed my changes. Okay, let me refresh. Do you see, once I have pushed those changes from my local, these two files were there onto my local folder. Do you see this one? These two files were there onto my local folder. Both of the folders came up over here, though both of the files came up over here. Okay, now in this one I have these two files. Once I will, now these the configurations which I did right now, again I don't again I will not need to do it. Let's suppose there is a developer A, he is learning and he has made some file changes into this one. Let's suppose he has entered this name Jatin. So what he will do now, he will go over here, made the file, made the changes. He will again do git add and git add. See the git status, it is under the staging. Staging is done. Now he will git commit -m and name it as put up a message, name is added. This is the message, git commit -m and name is added. So now there's this particular changes has been committed onto my local. it is not yet pushed onto this particular remote site. So to confirm, let's go to the new text document. In new text document, it still shows you hello and 123, but in this case, if I check it on my local, it shows Jatin as well, but it's not onto a remote. So to make a changes or to push the changes from my local to the remote, what I will do, I will run up a command called git push. As soon as I will run the command git push, see, automatically it has started pushing up the changes. Now if I go back over here and now refresh this page, see, my local changes are now onto this remote server. Okay, now for the testing purpose, you can also take up this link, and if you will use this link, you will able to see my repository as well. We have the master branch, and from master branch, what happens whenever we make any changes to the master branch and commit those changes, a new commit ID gets created over there. Correct. So now what is the use of the commit ID? The use of the commit ID is like if you want to roll up the changes, or if you want to take a reference of the changes when it was made, how it was made. So we use it up a commit ID to refer that particular changes into it. Now with the commit message, we also while putting up a commit, what we do, we also pass it up a message for the reference. So there is one more concept which is known as a how does it work? Like how Git will get to know that this changes has been made at this point, and now I have to overwrite, or if I have to continue writing up the code from this particular history, this one, this particular changes. So for that, we have a concept called a header. Header is like a pointer. So what will happen as soon as there will be one header? For example, I will show you on Paint. So for example, there is a repository. Okay, repository is there. Now you are making up the changes. One change you have made over here at this point. Okay, this is the first commit. Okay, there will be one header over here. Header means there will be a pointer. If we call it as a head. Okay, now what will happen as soon as you have made some changes and committed those changes, there's another commit has been created. This header will switch from this pointer to this head. So next time, whenever you are making up the changes and you are creating up a new commit ID, then this pointer will again changes to here, from here to here. Why we do that? Because we want to know where we have to make up the changes, from where Git will get to know that we have to make up the changes. Where is the header? Through that, we can come across this point over here. So for example, yesterday I have shown you when we type a gift log. So there will be a header. It shows you the head. So head means this is onto a master branch. It's on a, my head is onto a master branch. That's what it is currently referring to. So once you will make up a changes, okay. So if you will want to make some changes into the file and you commit it, then this header will switch. So another ways, like if you want to roll it back, I will roll back the changes to this commit ID, then this header will change from that to the new commit ID, which will be created through this commit ID. So that's how the header works. Header is used by the Git for a reference purpose, from where we have to write and save up the changes. You don't have to worry about this header master and all. Sorry, about the header, how it is pointing out, but you should know the basics, like how the Git works. On a Git, header is the one which helps you get to identify from where I have to pick up the changes and where I have to modify the changes into the file. Okay, so all these commits are bound to the branch. Any commits made will be added to this branch. A branch always points to a latest commit. The pointer to the latest commit is known as a head. Okay, The default branch in a Git repository is called a master branch. Whenever I will create a new repository, one default branch will be created, and that will be called either a master or either a main, depends upon the platform. Okay. Now, the default branch in a Git repository is called a master branch. But why do we need a branch? So now the concept comes up. Why do we need a branch? Say a developer has assigned enhanced this code by adding a feature A. The code is assigned to this developer in a separate branch, feature A. This is done so that master contains only the code which is finished, finalized, and is on production. So like we have a tree. Okay, we have in a tree we have a stems, and then we have the different branches like this. Similarly, in case of Git also, we have a main branch. This particular one is called a main branch. This is the master branch. Now from here, you can take up the code and create your own branches and name it as a feature branch. Okay. So what do you mean by creating up a branches? It means that whatever files are there into this main, whatever the files are there into this particular main branch, that will be replicated to feature branches, okay, at a first time. Now what will happen, every developer will work onto their own branches. For example, there is a developer A, he will work onto the feature branch, and once he will see that the code is finalized and it is ready to go to the next phase, then he will merge that code into this main branch. So every developer works onto their own branches, or and then they are merged into the main branch once they knew that the code is ready to be finalized. That is the concept of the feature branches. Advantages of the feature branches, that if developer A is making up the changes into his own branches, then the main branch will not be affected, and also the if developer B is working, this work will this particular branch will not affect the work of the developer B as well. That is the advantages of this particular branching. Now, as it shows you, what happens, there is a commit id, then from a master a new feature branch has been created, and that feature branch is getting created from the latest go. It means, like for example, this is a master branch over here. In this master branch, what is happening, well, earlier you have 1 2 3 4, and now you have the commit id, let's suppose 1 2 3 4, and now you are creating up the fifth branch. So there will be some commit IDs onto it. It will take that commit ID from there. Okay. Now there is no matter how many commits are made by this developer on the feature A branch, it will not affect the master branch. So that's what I've explained you. If number of changes you made into this particular feature branch, that will not affect the master branch. Now, once the code is finished, tested and ready, we can merge the feature A branch with the master branch, and now the code is available on the production server as well. So like it has been explained over here, what will happen, commit ID is created, feature branches is created, it is ready to go. Again, the master branch, it will be merged to the master branch. Now, how Git command works. You can do the following task when working with Git. Let's explore the commands related to these tasks. Create a repository. Parallel development. Parallel development means there's a developer A and developer B. They both can work onto their systems. Synchronize repository. What do you mean by synchronize? We have a option to synchronize particular our repositories. Synchronization means, for example, there is a developer A. Okay, developer A has made the changes onto his feature branch. He has pushed those changes into the master. Now developer B, what he will do, he will also synchronize his code into the master branch. Why he will synchronize the code with the master branch? Because what will happen, let's suppose developer A has created a code. Earlier this code was on v1. Okay, developer A has created the code. Now V2 has been released. Now earlier when the developer B has taken up the code, that time at an initial level, the developer B has taken up a V1 code. But now the latest code is V2 on to master. Let me explain you with a better picture, with a clear one. Let's suppose there is a master. Okay, in this you have the code. Okay, in this, from the code, a developer has taken up the feature branch, and another developer has taken up a feature branch. Developer A. This is developer B. Now what will happen? There was earlier a code into this master branch V1. That is the version 1. So when we have created up the feature branches, then the version was V1 to both of them. Okay, it's fine. Now both are working onto their own branches, and what will happen? Like for example, there is a developer A. He has created version 2. Let's suppose. Now it's on when he will what will he will do, he will merge that code to this particular master. Now from V1 it will change it to V2. Now what will happen? Developer B still having a version 1. Okay, the developer B still have the version 1, but on a master it is version 2. So what will happen if our developer B will keep on working onto the version 1? Here we have a latest code. Here he is using the old code. So if he will keep on working, he will keep on working onto version 1. There is no use of using working onto the version 1. He should work now onto the version 2. So what we do, usually he will sync it up. Sync it up means whatever has been pushed into the master branch, that will also come to the developer B feature branches, that is version 2. So now his code is also latest. Now he will work on to that latest files, that is the version 3. So now when the developer B is working and he has finalized, that version 3 will be merged onto this master. Okay, so that is a synchronization. Every day when there's a developers are working together, every morning they decide, and when they log in, they usually do a git pull. I will tell you what is a git pull and push. I am telling you in next few minutes. So they always do a git pull. Git pull means they are pulling up the changes from the master branch or any other branch to their local. So they keep on synchronizing the one. Okay, now what is the creating repository? I have told you, and how to create up the repository. Git init, making changes. Once the directory has been initialized, you can change the status of the files, whether they are being tracked by Git or not, using the command git status. Now again we have a synchronized repositories. What is a synchronized repositories? First, the files or changes has been staged. We are ready to commit them in our repository. We can commit the files using the command git commit. Okay. Now sync repositories. What is a sync repositories? Once everything is ready on your local, we can start pushing our changes to the remote repository. We have pushed our local repository from to the remote repository. Remote repository was onto a GitHub. Then we have a parallel development. What is parallel development? Parallel development means to push the changes to your repository. Enter the command git push origin, the branch name, and hit enter. In our case, the branch is master, hence git push origin master. This will then prompt for username and password, and enter the values and hit enter. Now your local repository is now synced with the remote repository on GitHub. So if you want to download the remote repository to your local system, we use the command called git clone. This command will create a folder with the repository name and download all the file contents of the repository inside this folder. In our example, repository contents were downloaded into the DevOps folder. Now, okay, one thing. Let's in this particular case, we have initialized the repository onto the on this particular local system, and then we went ahead and made the files, and then we have pushed the changes into the repository, which is on GitHub. Now let's suppose we already have the particular repository. Okay, now somebody has joined your team and they saw already repository has been there onto the GitHub. Then what to do? Then they will not need to do a git init onto their site. Git push origin is not required. Instead of that, what they want, whatever code is there onto this repository, that should be cloned. Clone means that should be copied onto my local system. I want to bring up that code onto my local system. For that perspective, there were two things authentic for authentication purpose. One is HTTPS, another one is SSH. So HTTPS is used with the username and password, and SSH is basically using the private key and public key concept. The much more secure way is the SSH, because in this we have the private key and public key. So if there, let's suppose I am the one person who works in an organization. So if I will have a private key, then only I mean both the keys, private key and public key, then only I will be authorized to access this repository. Otherwise, I will not be allowed. For example, in movies, you must have seen that there is always a code between the two person. If the both of them speak up the same code, then it verifies that he's the correct person to whom we have to share up the information. Similarly, in case of SSH also, when it will confirm the SSH and private and public key will verify whether both the keys are matching in a pattern, then it will authenticate to make changes and work onto that repository. Otherwise, that will be not work. Now in HTTPS, if anybody gets your username and password, then they will easily go ahead and copy this particular repository onto their local. Okay. So now to clone this one, what is the way? Let's take HTTPS. This is the copy button. So let's suppose I want to create I have one more folder. Let me create one more folder just for testing purpose. I have this one. I went to this folder. I want to clone a repository into this folder. How will I do? Again, I will open up a CMD over here. Under the CMD, we have this. I am into this folder. I want to clone my folder into this folder. So what I will do, I will use a command called git clone and then URL. Now see, this particular my laptop has already been synchronized, has already saved the credentials of this GitHub. That's why it is not asking for the username and password for the repository. But if I will if I want to clone any other repository besides my account, then it will ask the username and password for the authentication purpose that you are the correct person to work onto this repository. So I have cloned it up. Now see, whatever the code was there into this particular repository, that has been copied under the folder, new folder 5. Okay, now it's a different location. That is in different, the one which we have created earlier, that was in different folder. Now it's in a different folder. So automatically all my files came over here into it. So yesterday, when I have shared this particular link with you, this particular repository name, you can also clone this repository on your local. If you have the permissions, then you can also clone it onto your local. A remote repository means the repository which is onto the this one. You can say GitHub, GitLab, or Bitbucket. The complete repository, I mean complete folder structures, that is called a repository. Okay, so when we are talking about this feature branches, we are talking about the main branches. This complete thing is called a repository. When this repository is stored onto the some servers, okay, not onto your local, at some servers and all, that is called a remote repository. But you're talking about what is a main branch. So main branch comes under the repository. Then as I've shown you, what we did over here, we did a cloning. Cloning means we have cloned the complete code onto our local. Anybody can clone it, like whoever have the access. If it's a public, who if you have the access, if you have private, if you have the access, then you can clone that repository to your local. Now there's another command called as git pull. Okay, at the first time when I was making up these changes, okay, or I would say like at the first time when I want that code onto my local, what I did a git clone. But next time, let's suppose there is a developer A, okay, or developer B. Now developer A has made the some changes into the code. Now developer B wants to bring up those changes onto his particular repository or his branch. What he will do, he will run up a command called git pull. So whatever changes are there onto this particular server, the remote server, that will come onto my local. For example, this is a new document. Okay, in this new document, what does it show? Hello 123 Jatin. And over here also, let's verify what does it show. It's a new document text. Okay, we will see over here. What does it show? Hello 123 Jatin. Now let's do one thing. Over here, we will go and make some modification to the remote server. Okay, now over here I will do like this, Jatin Billa. Now one more keyword has been added over here. So I will save those changes from the remote server. I am doing it to show you how does the pull works. Usually in a company, another developer will do a push and pull. So from there the files will be updated. But I have to show you. So that's why I'm making direct changes into the remote server. Commit those changes. Once those changes has been committed, now see, it's a we have a 4 words into this file. Now if I go and see on my local, it still have the 3. I want to bring up that 4th word onto my local. So what I will do, I will use up the command. What command? Git pull. Now it will start syncing up. Now what does it show? These are changes into this particular document. If I make up the if I open up this document, see, now the changes has been brought up into my local machine. Another word has been added onto my local machine. That is a use of a pull command. The git pull command is also used for pulling the latest changes from the repository. Unlike git clone, this command can only work inside a initialized git repository. This command is used when you are already working into the clone repository and want to pull the latest changes that others might have pushed to the remote repository. Git pull and the URL. You can see this one. Okay. Any questions? So both you can clone your repository to anywhere, but usually we don't clone one repository another the to the another repository. We will not do that part because you have their own version controlling. So you can make a copy of the files from one repository to another, but it's not like that you have one repository and you will clone the another repository in the same one. it we will not do that part. Okay, I hope everybody has done it. Let's move ahead. Until now, we saw how you work on Git. Now imagine multiple developers working on the same project or repository. To handle the workspace of multiple developers, we use branches. To create a branch from an existing branch, we type git branch. Okay. Now I was telling you we will create up the branches. Now how to create up these branches? First, what we will do, I will do this part. I will let me go back to the folder earlier which we were working. Okay, so actually I have copied the repository twice. So let me go back and work over here. In this particular repository, you will see still we have hello123 because it is not synced. In this folder, I haven't run the pull command. So this one is not synced. Okay, that synchronization git pull I have used in folder 5, new folder 5. It's on a different location. So again, I have to do a git pull at this particular location. Okay, now this has been pulled over here. Now you can see in this folder also, I got the new changes. Now what I have to do, I have to create the branches. First, if you want to see how many branches are there currently, how you will see git branch and you will see master. So wherever you will see the star and green color, it means currently we are onto which place? Currently we are under the that branch. That is, we are whatever changes we are making changes onto that branch. So currently we have only one branch into it, that is master, and now we are making up the changes under the master branch. To create a branch, what is a command? Git branch and the branch name, let's take it as feature 1. What is my branch name? Feature 1. Okay, now what I will do, I will change from my master to the feature 1. How will I do? Git check out feature 1. Now it says switch to feature 1. So if I will do now command git branch, do you see now earlier there was only one branch. Now we have the two branches onto my local system, the feature 1 and the master. Do you see that? Now the pointer, this particular hashtag and that color has changed to the feature branch 1. So now in this file, let's try and type it something like feature 1. Okay, I am putting up for your reference to know that I am making changes into the feature 1 branch. What I will do, I will edit up this point and save this file. Now I have saved it. What I will do again, the same thing will be done. In whatever branches you are, you have to again do git add for staging. Again, I have to do git commit -m and then the feature 1 as a message and then save it. Now this has been committed. Those changes has been committed onto my feature 1 branches. So again, I will show you. We have this feature 1 over here. Now what I will do, I will switch my branch. To switch that branch, how to do it? Again, git checkout and what was my to which branch I want to switch? I want to switch to master. So I will put up like this. Okay, now I have switched to the master. Now let's see. Now do you see that feature 1? No, I have written up a feature 1, but that is not visible into this master. Why it's not visible? Because we are working into the which branch? We are under the master branch. Let's see. Okay, now I am under the master branch. So this is how we will switch it up. Okay, now again, this feature one branch is on my local. Do you see anything onto over here in remote server? Do you see anything with any branch name feature one? No. So to how to now what we have to do? Now we have to push my local repository from my local repository to the remote repository. What it means that the branch which I have created onto my local, that should be pushed onto this particular remote server. So how will I do that? Do you want okay, so see what happens, like you must by now you must have got to know that how what is a feature branches, what is master branch. Now to create up the any of the branches, what command we do? We use a git branch. If we put up some name, okay, it means that you have to create up that branch. Okay, to create up that branch, what we will do, we'll put up some name of that new branch which we want to create it up. Now to switch means from this particular branch I want to go to the feature one branch. So what I will do, I will use a command called git checkout, and to the branch name I want to switch. So after that, you saw that message, switch to feature branch one. As soon as I do that, my branch will be changed and now it will be shown over here. When I will use again the command to verify what all branches exist into this repository, I will use a command called git branch. Now over here, you can see one more branch was created, feature one branch, which I have created over here. Now again in feature one branch, I have made some modification onto a file. Okay, and then I've committed those files, and those file changes will be under which branch? Feature one, because I was under the feature one branch. Now from here I have shown you how what is the difference. In feature one branch we have some other content, in master branch we have some other content. Now let's try from the another we have to no not pull, we have to do a another way. Git checkout, we have to push it from the feature branch. Okay, feature one. Now again let me see what is over here, git branch. Okay, now what I will do, I will use git push. Let's see if it works. So now there is a difference. When you will create up a one of the particular feature any branches onto your local at a first time, only at a first time, to push the branches, to create up the branches onto my remote server, I will use this command git push only first time, because I have to create a new branch over there onto my remote server. I will use this command only first time, because I want to create up the branch onto my remote server. So at the first time only, I will use a with the push command, I will tell that I want to create up this particular feature branch onto my remote server. Only first time I will use this command set upstream origin. It means that I am setting the header as a original feature one branch. Now let's see over here. Now another branch got created. Do you see that? Here another feature one branch got created. Earlier it was not there. Let's see over here. Do you see feature one? Earlier it was not there. That is only needed when you will create up a branch on your local, and then you want to push that branch, you want to create that branch onto the remote server. Now let's suppose I have created one branch from the remote server. I will create some branch from the remote server. So over here I am creating a new branch. do you see the option find or create a branch? So I will create one more branch, feature 2. So there's an option called as create feature 2. Okay, I have created that. I will create that feature 2. Now it means this feature 2 has been created onto the remote server. Now if I will check it out onto my local, does feature branch 2 got created? No, the feature 2 is not over here. Now I will use a git pull command. See, when I have used the git pull command, then feature 2 automatically got created onto my local. Now what I will do git checkout and see if I can go to the feature 2. Now git branch. You see, for taking up any of the branches from the remote server, I just need to take up a git pull. But if I create any branch from my local and to want the same branch to be created onto a remote server, at the first time I will need to use up a git push set upstream origin. So upstream is the used for the header. As I've told you, we have the header concept. So to set up the header and tell that this is the, here I want to point up the header. In that case, we will use up this command. Okay. There is a main branch. In this, we have a file named as new document .txt. In this, we have 3 words. Okay. Now there is another one, feature 1. Sorry, let me call it as master so that you don't get confused. Okay. In feature 1, the same document was there. In that document, I've added the word feature 1. Okay. Now I have created another branch which is feature 2, but in this document we can't see the keyword feature 1. Why? While creating up the branch, you will see one of the option. Okay, let's create a feature 3. You see this option, create branch feature 3 from feature 2. It means that the new branch which I'm trying to create, okay, what base image I want to create it. So for example, this is the new branch. Okay, this is a master branch. From here we have created feature 1. From here we have created feature 2, F1 and F2. Over here I am taking up the code, the base code. I am taking it from the main branch. But let's suppose there's another developer who came up and say, I want whatever is code with the F2, I will take it that. So what we can do, instead of taking up a base image, base code of feature 2, master main, I will create one more branch taking up the base of feature 2. If I take up a base of feature 2, what will happen? Another repository will be created under the master only, but whatever is the content of feature 2, that will be copied to F3. Okay. Now let's suppose, take up an example over here. I will create it. I will first what I will do, I will first switch it to feature 1. In feature 1, we had that file, correct? Now I will create a new branch, feature 3, and I'm telling that the base will be feature 1. Okay, let's create it. Now I will go to my local. What I will do, I will use up a command called as git pull. Now that but new feature has been copied to mine, I will do git checkout feature 3. Now let's go over there, refresh. Now see, this came up over here. We are under which one? Let's check it from here. Git branch. I am under feature branch 3, but I have that content. What content? Feature 1. Why we have it? Because now I have taken up the feature 3. When I was creating up a feature 3, I have taken feature 1 as a base image, base repository. That's why this particular content was copied. Okay. So if you have a git tortoise, instead of using the commands, you can perform the same task from this way. Merge, switch. These are the commands which you can perform through the GUI. So if you are into this particular directory, like folder, right click, you will see git tortoise, and then you can push, pull, fetch. Multiple things are there. Okay, let me tell you what is the purpose of staging. For example, this is the master branch. Okay, this is a one branch for developer A. Okay, and he was working on his code. Let's suppose there is a file called abc.txt. Now in this particular abc.txt, he was modifying some content. It is not, let's suppose he was adding 1 and 2, then 3, then 4. Okay, now there is a developer B. It is a developer B, but he's working on some other files content. For example, XYZ is the file name, and he was he said to developer B, developer A, that I have some doubt. Developer A said, okay, tell me what are your doubts. He said, can you check my this file? Now developer A was working into this particular file. Okay, now he was confused. Why he was confused? He was confused like if I should I keep on working on to my repos code, or should I first check the developer B code? So what he did, he has saved that file abc.txt onto my local, but when he will try to do a checkout, he will get an error. Why we'll need to do a checkout? Because the developer A has to switch to the branch of developer B. He has to switch to developer B. Now he can't switch it up until he do a commit or staging. Commit, if he will do a commit, you know, this file is incomplete. He was working on it. So until that particular file is complete, he don't want to commit. So what he will do, he will stage it. So what is a using of what is the advantage of staging is, when he wants to switch it up, he will stage it. That the changes into that file will not be recorded under the commit ID. Although those changes will be saved onto a Git logs, but that not will be saved under the commit ID. He don't want to create a commit ID for that one until the file has been completely modified. So what he will do? He will do over here staging. Once he has staged, now he will switch the branches to developer B. he will check this file, give his reviews to developer B. Now that work is done. Now he will come back to his own branch. Now he will start working onto this file. After some time, he made it 5, 6. Now he is good to work further. He is fine. Now he thinks like this file is now good. I can commit my changes. Now he will commit those changes. Staging is like you can say how I'm not getting that word, but thing is like something between the final commit and the initial saving. So it takes up a record in that way. Okay, let's go further. So I've told you how branches work. To create a branch, what is a command? Git branch, name of the new branch. To delete a branch, git branch -d and the branch name. Okay. Now to switch between the branches, what was the command? Git checkout and the branch name. Now, want to check the logs for every commit detail in your repository? You can accomplish that using the command git log. Git log I have already shown you. Okay. Git stash. Now, what is git stash? Want to save your work without committing the code? Git has got you covered. This can helpful when you want to switch branches, but you don't want to save your work to your Git repository. In that case, you can use a git stash to your staged file. Without committing, just type in git stash. If you want to stash your untracked files as well, type git stash -u. So whatever I have explained you just now for the staging, to do that part, staging, we use a command called git stat. Staging means you're putting up under the staging environment, staging that status. So to do that part, we have the command called git stash. Git stash is the command which will help you to do that part. Okay. Now, as it explains, I've already explained you to do this part, like developer A wants to switch between the different particular branch without committing the local changes, then he can use a command called git stash. Git stash will do a staging saving for you. Let's suppose it is a git logs. Sorry, git log. You saw many of the commit IDs are there. Now, if I want to revert my changes, then what I can do? I can use a command called git revert. This is the command to revert the changes. Okay, git stash, git revert. Now the next command, git diff. What is a git diff? Let's see. Let's suppose there is a two. These are the two commit IDs. Okay, there are different commit IDs are there. I want to find a difference between those two commit IDs. Difference means what changes has been made between this commit ID and this commit ID. For example, in one file, you have made those changes, you have committed. Okay. Again, you have made some changes. Again, you have committed. Now you want to find a difference. What changes were made into that commit and this commit, to compare the file differences. What was changed? You will use a command called git diff. So this is the command which you will use. Git diff command, I have told you, this is the command git diff, which you have to try it out. I have written it in an assignment as well. Now going further, merging branches. Now what is a merging branches? Let's do like this. Now let's suppose earlier what was happening.
Let's have a quick quiz question, guys, and the question is, DevOps is an extension of, and your options are QA, Agile, Waterfall, or none of the above. Please mention your answers in the comment section below.
Just a quick info guys, if you want to make a career in cloud computing, then Intellipaat provides an advanced certification on cloud and DevOps by IIT Madras. This course is taught by industry experts and IIT Madras faculty. This course is designed to upskill and land your dream job. Now let's continue with the session.
What was happening? This is the branch. Okay, this is a master branch. Now from this master branch, we have created up the multiple branches. Branch A, branch B, branch C, and branch D. Okay, now we have these branches which we have created. This for developer A, this is for developer B and developer C. Okay, now whatever changes they have made onto this branch, this branch, this branch, so they will have to merge that branch changes into the master branch. So to do that part, what we will use a merge command over here. Okay, let's talk. Once the developer has finished his code on the branch, the code will have to be combined with the master branch. This can be done using two ways: git merge and git rebase. I will tell you the difference between both of them. Git merge, if you want to apply changes from one branch to another branch, one can use a merge command. Okay, if I want to merge from one branch to another, then in that case I can use a merge command. Should be used on remote branches since history does not change. Creates a new commit which is a merger of two branches. Syntax git merge, and over here the source branch. This is the syntax. So if you want to merge two command particular branches, how will you do? Okay, let's try this one. Currently I'm in which branch? I'm in master. I have made the changes into the assignment file. So first let me commit that changes. Hit add. Okay, now what I will do, I will do another command git commit -m assignment, or we can say activity 3. Okay, now we have made the modifications to the master. So now I have to tell you about the merge command. Let's think like this. What we will do, we have a feature one, F1, we have F2. What we will do, we will merge the F2 to F1. It means whatever is the code is there into F2, I will change it into the F1. I will bring those changes into the F1. So to do that part, what I will do, first I will go and I will show you the difference between the files so that we can see how it is working. Now, to do that part, first I will switch my branch. How to switch the branch? Git checkout. I will go to feature one first. Now, let's see this file. Not this one, this one. It shows you feature one. Okay. Now I will go back and check it out. Feature 2. Okay. Now I have to merge. To merge the one, what I will do, I will go to the, for example, if I want to merge from a feature 2 to feature 1, I have to go to feature 1 first. Okay. Always you have to be at the destination to merge. So to do that part, again, I will go to feature 1 and I will use a command called git merge feature 2. Let's see. 1 second, what happened? Git merge feature 2 is already. I'm in which branch? I think 1 second. Git feature, git checkout, git merge feature 1. Okay, now see this one. What happened? There was a feature 1. This, do you see this one? Currently, I am under which feature? Which branch? See this, git branches. Feature 2. I am under the feature 2. Earlier into the feature 2, this file was not having this line. After merging, what I brought up the from feature 1 to feature 2. Whatever was the content in feature 1, I brought it into the feature 2. So using this command git merge feature 1, I have brought up the changes from the feature 1 to feature 2. Do you see that? Fast forwarding new text document. It means this line has been added over here. Okay, that was a git merge. We will see more about the git merge once we will have a merge conflict, how to resolve it. I will show you that as well. Now imagine you have a master branch and a feature branch, a feature A branch. The developer had finished his work, feature A branch, and wants to merge his work into the master. In that case, he will use up this feature branch. If he is using git merge, a new commit will be created which have the changes of the feature A and master branch combined. Any new commits to the feature branch will be isolated from the master branch. Okay, this command can be executed using the syntax git merge and the source branch name, as I have done it just now. Git merge and the source branch name, that is the command. The history of the branch will look something like this if you are using a git merge. So there is one more way to check it out. If you want to see this status, git log, graph, and pretty online. This is for the show the diagram of a configuration, like how the merging is working. Let me see if my CMD will support this one. Give me a second. See, once I have used this command, grid log graph, on a left, this kind of star is showing it up. So it shows you how the particular thing was working. Okay. Now base. This is alternate to the git merge command, should be used on local branches. Since history does not change, will confuse you for the other team members. So what does the git rebase do? Like in case of a merge, it creates a history. History means the entries, what changes has been made. But in case of git rebase, what happens? It doesn't change the history. Okay, it will confuse for the other team. Does not create any new commit and results in a cleaner history. This history is based on the common commit of 2 branches. So when you are doing up a git rebase, it will not clear up the history. It will keep it clean. So in case of commit, one history, like for example, there were 2 branches. From one branch, when you're merging to another branch, history is also getting copied. But in case of rebase, it will not get copied. The destination branch commit is pulled from its base and rebased on the latest commit on the source branch. That is the rebase. Basically, most of the time we will use the merge only. Rebase is very less used. Okay. Imagine you have a master branch and a test branch, local branch. The developer has finished his work onto the test branch, but the master moved forward while the code was being developed. The code being developed is related to the new commit added in the master. So here it is. Okay. Now, therefore, you want all the changes from the master in feature. Since it is local branch, you would want a cleaner or linear history. You decided to use it a git rebase. So what happened? For example, there was a developer B. He has merged his code onto the master, and you had your own branches. But in your branches, you were creating up your own history. So if you take up a Git pull, those history from the master will come to your side as well. But I don't want that history to come up. So I will use up a git rebase command. Okay. This is how the output looks like. And the git checkout, git rebase master. This will be the output. You can use it. This is how the commit looks like after rebase. The commit was rebased from the first commit to the next commit. And looking at the history, we can clearly see it's clean linear history without any branches. Okay. You have try commands diff, stash, revert, activity 4. Try all commands from this git sheet and try to understand how the things work. Try means you have to do a hands-on on these commands, okay, and try to understand what these commands are doing. Okay, now next another thing will be find difference between git clone and fork command. You have to find this difference. What's the difference between a git clone and fork command? Okay, git rebase, let me tell you. So what happens in case of merge, you were merging up the complete repository to a complete repository, not complete branch to your complete different branches. So you're merging up that. But alternate to that is also called as a git rebase. So what happens? It should be used on local branches. So what happens when you're making up a history? When you're creating up this particular branches, you also create up the history. Now, if you don't want to merge that history, then in that case, you can use up a git rebase command. It does not create any new commit and results in a cleaner history. So, for example, when you merge these particular branches to over here, okay, now it brings up the history as well, and it creates a new commit ID as well over here. But now you don't want to bring up the history of this particular branch to this branch while merging up, then you can use up a git rebase command. It's from basically from not bringing up the history of the branches. The benefit of doing that is like what happens when you create up the branches. Okay, it also creates up the history. Then your size of that particular repository keeps on increasing. Okay, and you don't need to have that history. You don't want that history to bring up into the main branch because this will bring up your this will increase the size of the branches. You know, sometimes the branches this particular repository size grows too much that even companies have to follow the complete process for days to bring down the capacity of that particular or space of that particular repository. Why? Because everybody has to clone this particular repository onto their system. Okay, now what happens when everybody has to clone it? They have to it takes 5 minutes even to clone this repository. Then think about it, every time they are doing pull and push and all those things, so synchronization will take up the time, and even they will take up the space of the system. So in that case, they don't want to keep up the history, so they want to clear out the history of this branches. Okay, and even another reason behind this one is sometimes people create up the branches for some testing purpose. So they don't want, for example, people start creating up the test branches out of it. Now, if they are created test branches, they don't want its history to be merged into this main. It will create up the confusion as well because it is not needed. That's why we do that rebase. Okay, so let's talk about the Git merge conflict. What is a merge conflict? Let me clear this one. Now, what is a Git merge conflict? For example, I have told you, this is the main branch. Okay, from the main branch, you have the sub branches. feature 1, feature 2, feature 3, feature 4. Okay, now what happens? I have told you merging. What is a merging? When you are merging one branch to the another branch, it could be into the main branch, or it could be also into a different branches. If I want to merge this branch into this particular branch, then also I can do it. Now let's suppose there are two developers. Okay, dev A, and there is one more developer, developer B. Now manager has asked them to work onto this particular branches, okay, to work onto this particular features. Now what has happened? There are multiple scenarios where merge conflict can come up. One scenario is, for example, developer A and developer B, they both are working into this branch, okay, on they're working onto this branch, and there is a file called abc.txt. Okay, now in this abc.txt file, there was some content. Now both of them have cloned up this particular file onto their local. Now in this abc.txt, there is a content written like, let's suppose 1, 2. So when the both of them will copy this particular repository onto their local, what will happen? They will have the same content onto their side. That is, this developer A will also have the abc.txt with content 1, 2. Developer B will also have the abc.txt file with 1, 2 keyword. Now what has happened? There is a developer A. He thought like, okay, let's change from 1 to 2. Let me add one word, that is 3. Okay, now he has added 3 over here, and he has pushed those changes into this branches. He has pushed this file. He has pushed this file to this particular branch. Now this file has been updated into this branch. What is the content of the file into this branch now? abc.txt 1, 2, 3. Now there is a developer B. On his end, still the file have the content 1 and 2. It's not updated. This file is not updated onto a developer B. But what did the developer B did? He did from 1, 2, and then he put up the 4 and 5. So now what will happen? When developer B, for developer A, it has worked fine. But when the developer B will try to push up the changes into this particular repository, this particular branch, he will get an error message of the merge conflict. Why merge conflict? Because when he cloned the repository, that time the file content was 1, 2. But now when he is pushing up the changes, then he has realized this particular Git tool has realized that now the file content is 1, 2, 3. But at the time of developer B has taken up the clone, that time it was 1, 2. So it will create up the merge conflict. Now they have to resolve this merge conflict. Why they have to resolve the merge conflict? Because without it, these changes of developer B will not be pushed to this particular branch, because Git doesn't know which content need to be kept and which content is not required. So Git doesn't know, should I keep the file 1, 2, 3 with the file name, with the file content 1, 2, 3, or should I update it with the 1, 2, 4? So it will create up the merge conflict. Okay. Now the second scenario, when it will create up the merge conflict. Mostly this merge conflict will comes up in the second scenario. What is the second scenario? Let me explain you with a fresh page. In a second scenario, what is happening? This is the particular repository. This is a main branch. Okay, out of this main branch, there is a branch 1, branch 2, branch 3, branch 4. Now similarly, there is a developer A. Developer A has written up something, and this is another one developer B. Now both of them have cloned this complete repository onto their local. Now developer A is working into this particular branch. developer B is working into this particular branch. So when they cloned up this particular repository, there was a file called abc.txt. Okay. Now abc.txt was where it was under the main branch, under this particular branch, the main branch. Now, when they are cloning up this particular repository and they were creating up the feature, so what will happen? This abc.txt will be into this as well. And similarly, abc.txt will be over here as well. Okay. Now, in this particular files, when they are making up the changes, let's suppose this is a developer A. Again, there was a content 1 and 2. Now developer A has made those changes. It was also having up a 1, 2. This was also having up the when they have cloned it. Again, they have the 1 and the 2. Now developer A, what did he do? He has changed the file from abc.txt to 1.1 and 2 to. He had added one more line over here, which is a 3. Okay. Now again, this developer has finalized this code and he has pushed those code changes into this particular main branch. Now this main branch have what file content? He have a 3, but still developer B is not updated. He's still working onto the changes. He's still working onto the file which have the content 1, 2. Similarly, when he will try to push up the content with 4 and 5, this developer will get up the error of the merge conflict. Now this merge conflict will be solved manually. How? I will tell you. There is a tool called as merge tool. That is a command. So if you don't have installed merge tool, you can install it. I think with the Git it will come automatically. So using the merge tool, you can compare. What will happen? It will open up a panel like this within the Git command prompt. There will be a comparison between the both files, and it will show you where those merge conflict is coming, in which way it is creating up the merge conflict. Okay, so that is the merge conflict. I will go to the slides. Now let's talk about the merge. Let me show you a few slides, then I will show you the hands-on activity of the merge. Now merge conflicts occurs when we try to merge two branches which have the same file updated by two different developers. Let's understand this scenario. I have already explained you this scenario. This is the slide. Okay. So commit ID, when you have a new master branch, commit ID 1, commit ID 2, like people are making up the changes into the file, commit IDs are increasing. Now from here, the developer A has taken up the code, and that is the feature A branch, and developer B has also created one of the feature branch over from here. What is the name of the feature branch? A and B. Imagine two developers have been given the task of adding features to a code. They both have to add their code in a functions.c file. Like in my example, I have given you abc.text. In this one, they are calling up the functions.c file. Now, the function files look something like this as of now. Main, function 1, initial code. This is a function C file. It's an example. Now, developer A finished his code and pushes the changes to the master. Like I have explained you, this developer has made the changes and he has pushed the changes into this master. Now, what is happening? This feature A has been merged to the master. So this is a merge conflict now, because after the developer A changes his code and pushes it to the master, the code on the master branch looks like this after merging up. So what happened? After merging it up from the developer side, the code has been changed. What has been changed? If you see, earlier it was a function 1. Now what does it show? Function 2. Okay. After the developer B changes his code, the code on a feature branch B looks something like that. What is happening in this one? He is making up the change into the function 3. So that is the changes. Initially, what was there? Function 1. But developer A has changed it to function 2 and pushed his code. Developer B had the function 1 and he has replaced that function 1 with the function 3, but still function 3 is in local. Now when developer B will try to push up the code, he will get the merge conflict. Comparing the two code, we can see feature A branch is missing developer A code. Therefore, if we merge the feature A branch with the master branch, logically developer A changes will disappear. Okay. Now to solve this, Git as a fail safe, if the master branch has been removed, has been moved forward in commits, compared to the branch it is being merged, it creates a conflict. So developer B finishes his code and pushes the changes to the master branch. The merge is unsuccessful with the conflict. So now, as you can see, the for developer A, the code was successful. Why? Because files were matching it up. Now, in case of developer B, there is a conflict because when he took the code, cloning of that code, that time content was different. Now the content has been changed. So there is a conflict in this case. Now, how to resolve this one? We have the way. That is a Git conflict part. I will show you that thing. So let's see. This is a snip how this error message comes up when there is a merge conflict. This is a message you will get when you merge a branch which has a conflict file. Okay, so let's see how does it work. First, I am into this local branch, this particular repository. Let me see I am in which branch. It branch. So I am under the master. I will not play with the master. I can do it, but I don't want to play it right now. I will change the branch. So how to change the branch? Git checkout, and I will play with the feature 3. So now if I check my repository, the branch which in I will check with the Git branch. So I am currently into the feature 3 branch. Okay, now let's try it out. We have a new document. Okay, let me see what is there into another document. Okay, so let's do like this. I am taking up this particular file, which is a new text document. Okay, so what I will do to create up the conflict, although I don't have any other developer, so what I will do, I will make up the changes from directly from the this portal. So currently I am in feature 3. I will go in feature 3. In this one, you see new text document. So just for the learning perspective, think like this, that somebody has made the changes and that changes has been pushed over here. So I am typing up over here merge test. Okay, I am making up the changes directly to the portal to create up a scenario of the merge conflict. Now you can see merge test I have written over here and have committed those changes onto my portal, this one. Now do you see merge test? Okay, it's a new text document. Now if I go to my local, you see, do you see anything over here? No. Let's try. And over here, what I will do, I will write something like 1, 2, 3, 4. Save it on my local. Now, after saving up to my local, I will add it up at git add for staging. After that, I will commit those changes. Okay, I have to put up some message. Let's suppose merge conflict. Now I will save it. Now this has been saved. Okay. Now what is the scenario? Now as per the GitHub, what is the content of the file? Merge test. Okay. Now as per my local, what is the content of that file? 1, 2, 3, 4. Now if let's suppose this merge test was written by developer B. Now I am a developer A who has written up 1, 2, 3, 4. I want to push my changes of 1, 2, 3, 4 to this GitHub account. I have written up git push. Do you see? This is a merge conflict. Why a merge conflict came up? Because when I took this particular file onto my local, that time content was different, but now it is comparing up over here from the GitHub account. Its content is different, whose history is not there into my system. So it has created up the merge conflict over here. So usually what happens when you will go with the git merge tool, it will show you where is the file, in which file you are getting up the same message. And then what will happen, it will show you a window like this. Okay, this is a window. It will show you a window like this. In this file, you have the main. In this particular one, if you have a main file, this will show you like developer one made what changes, what developer do has the changes, and which one you want to see, which one you want to resolve it. So you can compare it with the merge conflict tool, and then it will show you the output of it, and then you can use it to compare which one to keep, which one is not yet to which one is not required by you. So once you are sure that I want to keep this one, you will make up the changes manually, and then you will push the changes back to the GitHub account. So the merge tools looks like this. The top most left column is for dev1 branch. The center column is for the original code, the master code before any commits. The rightmost column are for the dev2 changes. The area below this columns where we have to changes is the player where we have merged it. So left developer 1, developer 2, and mid one is for the one you are making up the changes. It's for the comparison purpose. So you can think about 3 windows are open, and out of 3 windows you are comparing and making up the changes into the middle one. Now this is the one. Once the issue is resolved, what will happen? So if you don't know about what is wkey command, what is the wkey means write and quit. So if you have worked on if you have worked on to a Linux, okay, this is a Linux command. This wq is used for the purpose of the writing and quit. So what happens in case of Linux? I think most of the people will not have not worked yet onto a Linux. So Linux is a command line CLI tool, the operating system. On that operating system, you don't have the way you interact with the Windows. In Windows, what you do? Right click and you do your work. You have a mouse, you have a cursor, you can see up the task, you can operate very easily with the Windows. But in case of Linux, you have to write up the commands for each and every perspective. Now like we have the this notepad editor in Windows. Similarly, we also have the in Linux we have the Vim editor. So Vim editor, once you have made your changes with the particular file, let's say there is a any of the file. Now you have made the changes into any of those file using the Vim editor. So what you can do, you can use of the command called as wq. So that's what has been explained over here. Using the colon wq command, you can save up the changes, and then you can quit, you can exit from that file. So it will make the make your changes written into that particular file. That is the wq. Okay, now after the step, see the status of the local repository. You can see the file in conflict has been modified successfully and is merged with the master. This modified file can now be committed to the master. Okay, that is the use of the git status. Using the git status, it will tell you what has been modifications. Nikita, I will tell you how to do it manually. Let my merge tool command work. So what happens when you will work with the merge tool? Now, it is not working. I will check it on that part. So in a merge, when I will write up the merge tool command, it will open up a window like this, like it has been shown up into this snip. This type of window will open after running up the merge tool command. So in this merge tool command, you see three windows are there. 1, 2, 3. So this is a developer A. What developer A has pushed. This is the one which developer B has pushed. This is the original code. Like I've explained you in my context earlier in abc.txt file, what was the content? 1 and 2. So original content will be 1 and 2. From this particular developer A, it was 1, 2, 3. From this particular developer, what was the content? 1, 2, 4, 5. So this will be into the first window, 1, 2, 3. This 1, 2 will be into this window. Okay, now 1, 2, 4, 5, 5 will be into this window. So now all the three files, you can say so, is open up into one window. Now you can compare what to keep, what not to keep. So according to that, you will make the modifications into this panel. Into this panel where you see pink color and blue color, you will make a modification by comparing up these files. Now let's suppose you want to keep it like 1, 2, 3, 4, 5. So you will write up 1, 2, 3, 4, 5 into this particular panel, and then you will run it up a WQ. WQ will what it will do? It will save up the changes into this particular file. In this summarization, I have told you that what will happen. There is a complete repository is there. This is a repository. Under this repository, developer A has made the changes, developer B has made the changes, developer C has made the changes. Now, in the same file, if developer A has made the changes and pushed the code, let's suppose to this one, and developer B has also made the changes and pushed the code into this one. So what will happen? Into the same file, they are making up a changes at same time and trying to push it up. It will create up the conflict, the merge conflict. So to resolve that merge conflict, as I have shown you, the this particular one, merge conflict was coming it up. So to resolve that merge conflict, you will use up a merge tool command. So once you will use up a git merge tool command, a window will open, and in this one you have the three options will be there, like this 3 panes will be there. In this one, it will show the file of developer A, and in this one it will show you the file of developer B, and in this one it will show you the original one. Original one means like there was a abc.txt. Okay, now in this one, earlier the content was 1, 2, the original. Okay, now in this one, developer, what is the content? 1, 2, 3. In developer B, you have 1, 2, 3, 4, 5. Now this kind of window will open with the merge tool command. So now it's up to you, have 3 windows over here. Now you are the person who is resolving up the merge conflict. So you can see what is there into these files. Now you have analyzed, okay, I want all 1, 2, 3, 4, 5. So you will write up over here as a 1, 2, 3, 4, 5. You will commit those changes. Now this file will have the new changes with this content. So finally commits your changes. Like I have shown you at final stage, what you have done, you have made the changes into this one, 1, 2, 3, 4, 5. You will commit those changes and push those changes. That's how the merge conflict will get resolved. Okay. Now, as an interview point of, if I tell you, these questions are usually asked, even when I take up the interviews from my company, I ask these kind of questions only. What is a git merge command? So I will, at the end of this particular slides, once the topic will be covered, I will tell you few interview questions, what is asked into interviews, so you can note it down those points on your side. Even I asked these questions, and I have given up many interviews in my lifespan. So I have faced these kind of questions, which I will share it with you after this, at the end of the session. As you can see my screen, okay, let me show you how what I did and how what was the issue, the what mistake I was making that time. Okay, so like I've told you, one of the scenario. Let me explain it over here. This is the repository. Okay, in this repository there was a in my scenario, I'm telling you what I did. It's a new test document.txt. Okay, in this one, keep it like this. It's a new text document. File name was 2. Now what I did, I created one of the branch over here, which is a feature 1, feature 2, and feature 3. Now in this one, feature 1, feature 2, we have something feature 3. Okay, now this in this new document, this was an empty file earlier. Now what I did, in a feature 1, I have written up my name Jatin and saved it and committed. Now in feature 2, what I did, I have written up something like 1 2 3 4, committed and saved it. Now in my local scenario, what I did, I have tried to merge this feature 1 to feature 2. I'm not merging it to the main branch. I'm merging this feature 1 to this feature 2. Now, at the initial stage, when we have created these branches, feature 1 and feature 2, what was the content of the new document? It was empty. But within the branches, we have written up something over here into the content, and that content is also different. So now it has created up the merge conflict. So I can show you over here. So this is the Unix commands. Okay. Now if I show this one, let me reopen this page. Okay. This CMD, it will help you to get this part. Now if I show you git branch, we have 3 branches, feature 2 and 3. So in a feature 2, I'm trying to merge the feature 3. So what I will do for merging, git merge, and which branch I want to merge? I want to merge the feature 3. So it is showing up that there is some changes. There is an unresolved conflict over here. So to see that one, what is the conflict? Git merge tool. So now it is saying, okay, there's a merge tool. Will ask you which editor you want to use it to compare. So I want to use up the Vim editor. Vim editor will find it up the difference between the 2 files, and it will show me over there. So in this one, I am writing up a Vim diff. Now I got this window. As you know, in the earlier one, into that when I was showing you up the these slides, the same window was there. Now in this window, there are 3 contents. Do you see developer A? That is the this is in which file? This is in feature which this is in feature 2 branch. This is in feature 1 branch, and in the this is the main. At the initial stage, it was empty. Onto the one, it is showing me the one which is in the current branch, that is a feature 2. This is in feature 3. So it is comparing it up. Now as per this one, do you see this lines? It is showing it up over here that this is the head and this is the main. Which one you want to keep it up? So as per your requirements, now you can make a modifications into it. I don't want to keep this thing. Okay, let's suppose there's the person who wants to resolve this issue. So what he will do, he will check make the modifications over here. I want to keep it this. Okay, You want to keep it WQ and save it. Now this has been said that from 1 to it has been changed to Jatin over here into this new text document. So if I go over here into the new text document, now see the content was 1 to earlier. Now it is showing up Jatin over here into this particular branch. That which branch? Feature 2 branch. So now what I will do, I will come back over here under the CMD and then I will just commit my changes, save it, and it is done. And then you can push those changes into the GitHub account. Now, if you are facing up the issues in learning this merge tool and all, the best way or the easiest way will be like Tortoise Git. So in Tortoise Git, if you see, there's an option called as this one, merge, create branch and all. And this is a resolve. If let's suppose a new issue came up, the merge conflict came up. So using the resolve, it will resolve your issue. If you want to revert, then you can revert up your changes as well. So using this Tortoise Git also, you can resolve this issue, merge conflict very easily. So you don't have to worry about commands if you don't want to learn it. But my preference is like do learn it, because in interviews they ask you about these commands, what is the use of these commands and how to resolve these issues. So these are shortcuts. Like there is always an alternate for the tools into the market, but I would suggest you to use up the commands only to learn in future as well. Okay. Now going further, collaboration in GitHub. So what happens? Let's suppose this particular repository has been created. Now I want to provide the permissions to for you. Nowadays you must be using up my repository to clone onto your local, but when if you will try to make some changes and push, you will get the error, you don't have permissions. So now if I want that one of my student should make up the changes into my repository, I will provide them the permissions. Now to provide that permissions, we have an option called it settings. Under the settings, we have a option of collaborators. Like collaborators means who can make changes into my repository. Okay. So now in this one, I can add the people so who can make up the changes into this particular repository. So in your team, if you want to share up the code, then you can add them as a collaborator and manage the access. That is what has been explained over here. Collaboration is GitHub is very important aspect of software development. It enables developers to parallelly work onto the same project. Add collaborators to your repository. Protect the branches which need restricted access. This is about the one. Collaborators are the people who will work on your project. To add contributors to your repository, uses the steps in the following images. Okay. The collaborators can work like it depends upon what type of role you are giving it up. So collaborators can make changes onto your repository. Protecting the branches. So usually what happens, we also protect the branches. Protecting the branches means, like for example, I'm a developer A. I don't want anybody else to make up the changes into my branch. So I will set up the policy that way, or set up the securities that way. Only the authorized person can make a changes into my branch. So that policy can be applied. Another one can also be applied about the policies are there. So let's suppose this is the feature one. This is a feature 2, feature 3. I want that only the feature 2 branch can be merged to my branch. I don't want feature 3 to be merged into the feature 1. So in that case also, I will put up the policies. These kind of policies can also be applied even in case of this particular one. When we talk about the main a branch, whenever we want to merge any code, we put up the policies so that people should not randomly put up the affected or maybe defected code into this particular branch, because this is very important branch for you. You keep up your final code over here into this particular main branch. So that kind of protection is also done. Okay. Now collaboration in GitHub, I've already shown you how to add up the user. Now, one of the most important thing, I have told you about the merge commands. Okay, merging is used for merging. Now, there is one more thing. When you will work into the company, you will hear the command. Usually, you will hear PR request. So, in short, we call it a PR request. What does it mean? It means pull request. What do you mean by pull request? So in a company, what happens? Let's suppose this is a developer A. So he wants to merge his particular branch to this particular main branch. So like in my case, in our case, what we were trying to do, we were directly merging it up and it was accepting your changes. But in a companies, it doesn't work like this because they want to restrict the people to so that they don't merge the invalid code. So in that perspective, they put up the policies or they put up the authorizations in between, validations in between. So what they do, they say, okay, you are a developer, good. You work onto your branch. Once you feel like that my code is fine to be merged to the main branch, then raise up a pull request. Pull request means that this user is requesting people, please approve so that my code will be merged into this one. Now, in this case of pull request, your manager depends upon to whom you have authorized. So when the pull request will be raised, his manager will approve, his team lead will approve. So once those two people will approve the request of this pull request, then this particular code of his branch will be merged to the main, otherwise it will not be merged. So to raise up the pull request, once you will go to this particular one, do you see this is an option called as a pull request? So in this pull request, what I will do, I will raise up a new pull request. New pull request, as you can see, base compare, which one I want to merge. So for example, I want to go with the feature 3. I want to merge means it is happening the same way like merging, but in between you are asking for the approval from your seniors so that I can approve it or not. So in this case, I am raising up a pull request. In this pull request, what I am raising, I want to merge this feature 3 to the feature 1. It can be between the different branches also. It can be from one branch to the main branch also. So I am asking persons to approve so that my code will be merged to their branches. In that case, I am raising up a pull request. I am raising that feature 3. Can I merge my feature 3 code into the feature 1? I have raised up a pull request. Once this particular pull request will be raised, now this is into a 1. So now you remember it is showing up a merge conflict. Why merge conflict? Because just now we have practiced, we were doing some practice in which a merge conflict was there between these two files. Because of this, this particular branch got errored. Okay, this pull request got errored. This Git is asking us that first resolve the merge conflict, then I will create up a pull request. So that's why this got this message of error out. But if there's in a normal case when everything is working fine, in that case it will raise up a it will create up a pull request. Your manager will come and he will just go ahead and approve it. Then that code will be merged from one branch to the another branch. I hope you have got the use of the pull request. A Git workflow is a recipe or a recommendation for how to use a Git to accomplish its consistency and productive manner. Git workflow encourages users to leverage Git effectively and consistently. So like what happens, just now I've explained you, like we have created up the branches. We create up the different scenarios. Now what happens into a company? Even for creating up the repository and how everyone will save up the code, we have the branching strategies. What do you mean by branching strategies? Like I told you, this multiple branches will be created. So in a company, when you create up any branch, it itself has some meaning. Why? Because if let's suppose your manager comes up and he wants to see up the data, or he wants to see the progress. So like each and every branch have its own meaning. So for example, this is a feature 1, feature 2, feature 3. So in an application, if you're creating up any application, it has different features. So according to that particular name of the branch, he will able to recognize in this particular branch for what feature code is written. Okay, for what feature in feature 2, what type of code has been written. So according to that, we create up the branching strategies into the company. So that is where another part. Special meetings are conducted to decide what kind of branching strategies we should follow in a company. That everything is synchronized. People should able to work easily. Even if I tell you, in my days, I'm working in one of the project, and I am working on to this only. We have to go with the branching strategies. So even if you go to and Google out the branching strategies, then they will show you different ways how you can go ahead and create up your own branching strategies. This is very important part for the company. Even Git seems to be easy, but completely it needs a planning and everything when you go with the branching strategies. So many articles you will find it out in what case which branching strategy should be followed. So everything can be done over here. You can study from the branching strategies which one will be good. So in my company, like I'm proposing one, the branching strategy, what we will do, we will have a main branch. Then we have feature 1 branches, feature 2 branches, feature 3 branches. Now in this one, what we will do, further, if any hot fixes come up, let's suppose hot fixes come up onto the feature 1 branch. So I will create up this one more hot fix out of it, hotfix 2. Once the hotfix that will be done, it will be merged to the feature 1. From feature 1, it will go to the merge. So that kind of merging, this kind of, you can say the merge conflicts or how the things will work. So these kind of branching strategies has been created by each and every company, and employees has to follow that branching strategies. Okay, so git flow is one of the way through which you can check it out. For example, in this one, centralized workflow, as case of centralized, you are directly making up the changes into the centralized one, so no, not such major you can say branching strategy is required. But in case you are putting up onto your git distributed system, then you have a feature branching. Git workflow, you have a master, you have hot fixes, you have releases. So those type of branching strategies has been followed. So even once you will be having a good experience in your career, so let's suppose 1 year, 2 year, 3 year, and when you will go for switching up your job, even in interviews they will ask you, in a project management side or anywhere, they will ask you what type of branching strategies you were following up in your last company. So this is also one of the question which comes up in interview.
Let's have a quick quiz question, guys. And the question is DevOps and Agile same? And your options are yes, no, maybe, or none of the above. Please mention your answers in the comment section below.
Just a quick info guys, if you want to make a career in cloud computing, then Intellipaat provides an advanced certification on cloud and DevOps by IIT Madras. This course is taught by industry experts and IIT Madras faculty. This course is designed to upskill and land your dream job. Now let's continue with the session.
Okay, so centralized workflow, this workflow does not require any other branch other than master. All the changes are directly made onto the master and finally merged on the remote master once work is finished. Before pushing changes, the master is rebased with the remote commits, results in a clean linear history. This is a centralized workflow. Feature branching. Master only contains the productive really code. Any development work is converted into a feature branch. There can be numerous feature branches depending on the applicant's development plan. Once the feature is complete, the feature branch is merged with the master. So in this one, like we are creating up the branches. Each branch by its name explains what type of code is stored into this particular branch. So using that branching strategies, it is easy for everyone to recognize, to find out that what type of code is written into this branch. Git workflow. Now see this one. This will be seems more complicated. In feature one, just master feature. Now Git flow workflow. So you have a master. From master, you have taken up the code over here. You have releases. You have developed feature A, feature B. Now you are merging back to the master. From master one, you are merging back to the you are deploying to the production server. So this type of Git workflow options are there over into this. Okay. Forking in GitHub. So what is a forking in GitHub? Like you must have seen in this options. Okay. Now when I have created this repository, another option comes about the forking. So I think few of the people have even forked my repository. I don't have option of forking. What do you mean by forking? Forking means, let's suppose there is some XYZ person. He has created up the public repository. Okay. Now I want to take up that repository onto my GitHub account. So one option was cloning. Cloning means, what do you mean by cloning? You are taking up this URL and cloning the code onto my local. But what I want to take up this code and I want to synchronize this one into my another GitHub account. Or maybe like you are my student. You want that this particular repository should come into my GitHub account. So in that case, once you will go to my repository, you will see the option of fork. So guys, if you will open up this my repository, you will see the option of fork. Then this particular repository will be cloned onto your GitHub account. For me, this forking is disabled because I own this repository. If I will go to some other person's account, then I can fork that repository onto my account. Okay, I hope you will get this one. So what is happening in the case of forking? If there is some other person, not you, if there is some other person whose code you have liked and you want the same code onto your GitHub account, then you can use up a fork command. From here, I can see how many people have forked my account things over here. The tools which we will learn in with these after Git. Let me give you those things. One second. We will go after this one. We will go with the Jenkins. After Jenkins, most probably we will go with the Docker. After Docker, we will go with the Terraform. After Terraform, we will go with the Ansible. And after that, we will go with the Kubernetes. So this will be the learning plan. So what is a cherry pick? Let me explain with the plain text. So what happens in cherry pick? For example, you have this main branch. Okay. Now within the main branch, you are creating up the different branches. Branch 1, branch 2, branch 3. Now what is happening in this branches? For example, you have the let's suppose let me type it like this. You have the file, and in this file you have written up a different content. For example, this is one of the branch feature 1. Now this was the main branch. Now let's suppose this is a feature branch and you have the multiple commits. Multiple commits means, for example, you have abc.txt. In this one, first you have written it up 1, 2, 3, 7. you have saved this file, committed those changes. So once you will make the commit of these changes, a commit ID will be created. That commit ID could be like X123. Okay, one commit ID has been created. Again, in file, what you did, you have again written up something like, okay, 123. Jatin is already there. Then you added one more name. Let's suppose you put it up Rahul. Now again with this Rahul, you have entered one more commit ID. One more commit ID will be created, X456. Similarly, again in the after some time you have made one more file. Okay, not one more file, within the same file you are making again a changes. I, it's not like that I am talking about the same file. It could be anything within the same branch. Majorly, making up a changes into the same branch, and new commit ID is getting created. That's what my motive is. Okay. Now I can say about J. So in this one, I have now 3 commit IDs, 7, 8, 9. Now in this main, from the main branch, what I will do, from the main branch, I want to merge this feature one, but I want to merge, or I want to take up the commit ID 456. Okay, if I do a merge right now, if I using a merge command, if I try to merge this feature one into the main, which file or which code will it take? It will take up the latest one, 789. But I don't want to take it up as 789. I want to take it up 456 or maybe 234. I don't want to take a latest. I want to take up the commit ID before that. In that case, you can use it up a cherry pick. So in case of a cherry pick, you will tell the you will run up a command and tell them, I want to merge, I want a file or I want a commit ID from 456. So in that case, you can use up a cherry pick command. If you're working, or if you're looking for a profile into a DevOps career, okay, please try to be independent. By independent, what I mean, try to learn from your side as much you can. During the classes, we try to cover the topics as much we can. But when you will go into the real world and face the issues, you will face the issues in very different way and manner. Even sometimes you will feel like, oh, this was not taught to us, or this was not taught to us. Many times you will feel like this, because what we teach over here is the basics. We try to clear up your doubts. What does this tools work and how does it work? But when you will work into a real scenario, that time things will be completely opposite to it. So you will work on to these tools only, but you will get a basics of how these tools work. But over there, many things will be different, how things are working, because it's not easy to go into the DevOps world. I'm not encouraging you, but I would also say that please try to be independent. Try to gather the answers from your side as much you can. Try to Google it out as much you can. Try to get the information. Try to be self-independent. If I tell you about myself also, I have never taken any self training. By training, I mean I never attended any classes for DevOps or anything. Everything is my self learning. I've done the self learning a lot. I studied. I studied about DevOps. I gathered the information. Then I studied from that. From there, the YouTube videos or any other things, even the articles and all. Let's suppose there are two developers, and two developers have the same repository. Say they have created the same branches from a main branch. Okay, for example, let me show you. This is the main branch. Now what developers has done, they have created their own branches out of it. Now they have the same files on these branches. Now developer A has made the modification onto that file and he has merged over here. Okay, now over this, now in this particular repository, this branch, the code is latest, which developer A has pushed, but still the developer B have the old code. He has not took up the pull of request of this particular new code. He still have the old code. So, but he is modifying onto the old commit. Now, when he will try to make the changes and push up the changes to the main branch, merge it, then he will get up a merge conflict. What is Jenkins? What is the use of a Jenkins? During this one Jenkins, we will take up the example code of a Java, and for building it, the Java code, we will use up the Maven. Okay, so we will talk about the Jenkins and Maven, both of the things. Okay, so going with the Jenkins, like Glory has explained and Rashmi has explained, what is CI/CD pipelines? What is CI/CD? When we talk about the DevOps or continuous integration, continuous deployment, you always see a sign called as infinity. I've made an incorrect. Oh. You must have seen the code like infinity. What do you mean by infinity? Infinity means this process keeps on going on from one side to another. Why it shows you infinity? Because what does the people do or the developers do these days? They try to create up a code, they create up a small application. For that application, they divide it into the parts. They try to deliver that product into the parts. So what happens? They build up the small code into the pieces, and then they go ahead, build it, test it, deploy it. So again, this continuous process keeps on going it up into the small pieces. Okay, that's why we call it a CI/CD pipeline. And what happens into the CI? In CI, for example, you have a Java code. So you will write up this set of steps or tasks through which you will build up the code. Build up the code means that, for example, the Java code. So using the Maven compiler, you will create up an artifact. Artifact means a executable file format. Like once you will get up that particular package, you will copy it onto the server. Now, to copying to the server is done through the process of continuous deployment or delivery. So in an interview, this question is also asked, what's the difference between a continuous integration, continuous deployment, and continuous delivery? So please write it down this as a homework. What is the difference between a continuous integration, deployment, and delivery? Now this process keeps on going, keeps on going. Now when we deploy a code which was created by the continuous integration to the servers, that is called as a continuous delivery or deployment. Okay, now in this process, this complete process, we talk about continuous. The word is continuous. What do you mean by continuous? That without doing any manual process, without including any manual process, everything is going automatically. So what we do, we have a developer A. He for example, what he will do, he will write up a code onto his laptop. He has a laptop. In his laptop, he has written up a code. Okay, and now code will be stored where? It will be stored into a Git. Now that Git will could be on anywhere, like it could be GitHub, GitLabs, or Bitbucket, anywhere. Wherever you have a version controlling system, source controlling management system, over there you have that particular code. Now developer has pushed his particular code onto any of the platform. Okay, after pushing up that particular into the platform, what will happen after pushing up onto the platform? Either a GitHub, GitLab, or anyone. Let's say I will always talk about the GitLab of GitHub. So sorry for now. So in a case of the developer has pushed the code onto the GitHub, now what will happen? After pushing up the code into the GitHub, automatically we want that a particular CI should execute. CI means continuous integration. In continuous integration, what we do? We do a build. So automatically a package should be created. Okay. Now in after the build, what should happen? It should be continuous deployed. What do you mean by continuous deploy? That automatically particular code will be deployed to the servers. Where are the servers? Servers are onto the cloud or anywhere. Okay. Now for that, to deploy onto that server using the continuous deployment, this particular package will be deployed using the CD. So it will have the steps of deployment onto the servers. Now this server could be a VM machine, that is the IA services. This could be app services, which is a PaaS services. So in case of VM machine, we can deploy the code. In PaaS, we have the app services, or we have the Kubernetes or Docker. Through that, we can deploy up the code. So what we want using the continuous deployment, any of the IaaS PaaS services we want to deploy, then we can deploy using the continuous delivery or deployment. That is about the CI/CD. So what happened? This developer has just made modification onto this particular laptop. He pushed the code and automatically that code has been deployed onto this particular machine, either IA services or either a PaaS services. So automatically it got deployed over here. Now this process, okay, we talked about this process. Okay, it's fine. That developer wants to push his code to that particular machine. Now we want that automation. Now to bring the this type of automation, we have the tools which is there into the market, and one of the tool and the oldest one is Jenkins. That Jenkins is a open source tool. Anybody can install that Jenkins and run the software or either onto their laptop. Either you can create up a virtual machine on a Azure, or either you create up a virtual machine on AWS and install that particular Jenkins server and run up the Jenkins server and start creating up the CI/CD pipelines. Okay, so let's go with the few slides, and after that I will give you some time. Even I will create up a one account, one of the virtual machine on my account, and then I will install the Jenkins on it. If you want to install the Jenkins onto your system, laptop, local laptop, you can do it. If you want to use it a Azure account, you can do it. If you want to use the AWS account, you can use it. So either of the platform, you can run up the Jenkins and start up the services of Jenkins. And from there, we will learn about how to set up the Jenkins server, and then how to use up the CI/CD pipe, how we use it for the CI/CD pipeline. Okay. Now, why Maven? The written code by developers has to be packaged and converted into executable format. This is done with the help of a Maven. So what happens, like, there's a Java code. Okay, Java code is written up over there. It's a very, you can see a scratch way. When you see the developer's code, you will see there is a coding is there. Many file structures are there. But and even you will see on a web, when you see any website or you install any software, do you see that type of code over there? No, you you don't see that type of code over there. You see a end product. You don't see a raw code over there. You don't see what type of classes has been written over there, what is running behind that application. You don't see that. Okay, so now even if you want to modify that code or any application, can you modify it? No, because you're working onto an executable file. You can modify it. For example, you have a website. If you try to modify, you can modify it onto a local, but that will not reflect to the other users. Okay, so now what will happen if you have created up an executable file that is running onto the server? Now to create up that executable file, you need some softwares or the compilers. One of the compiler is Maven for the Java. Another one which is used by the Java is Java is ANT, and also we have the other ones. Let me remember: Java, ANT, Maven, ANT, and one more was there. Gradle is one of them. So what happens? Executable file gets created out of it. Then we copy it onto the server. So in this example, do you see in one application, we have multiple options. Like if you go into any website, you have multiple features over there. Even like, for example, you have an Amazon.com. Okay, on an Amazon.com, you have a login page. You have some password reset page. You have to set up the passwords. You have a payment gateways. You can order the things. So this is a complete website you have with the multiple features. Now these features are not created by one code only. I mean, like, it will be divided into the parts, and what will happen once that part is created, it will be merged to the main code. So that's how it is done. When we talk about the coding part, all features, for example, I talked about the repositories. When I was talking about the repository, I told you that we have a main branch, then we create up the different small feature branches out of it. Now that's how it works. What the developers do, they have a main branch. Okay, what a developer A will do, he will create a branch out of it, and he will say, okay, this is a feature one. Feature one means I want to create up a login code over there. There's a developer B. He will create up a feature 2 branch, and in that feature 2 branch, he will write up a code for the security. Then again, there will be another developer who will create a feature 3 branch, and he will start writing up a code for the library. So that is how each developer is working on to the different set of features over there. Once they are sure that they are working fine and all, they will start merging those code to the main branch. Now the main branch will have a complete application up and running. So that's why main branch is always important, because in that branch, the final code is written, and using that main branch, the code will be a package will be created. And once the package will be created, it will be deployed onto the production server. So this is the that is how the Maven works. Maven helps you to create up the executable file. Shilpa, you can go with the .NET application also. .NET application needs a different compiler. Each and every, like for example, for Python, you need a PyCharm. Each type of code have their own compilers, so you can use them as well. Okay, since Maven is a build tool, it can help in building an application. It can help in building an application so that several different modules. It is doing it so by this downloading the dependencies, enforcing a directory structure, building an executable file with all the dependencies. So what do you mean by this? What happens in, for example, you have written up a Java code. When you write up a Java code, what does the developers do? They have a different file structures. Once I will show you the code of the Java, you will able to understand much more in deeper. So what will happen in case of Java, you have a multiple file structure, multiple files will be there, and each file will have their own type of usages. So for example, there is a file called as pom.xml. What does the pom.xml do? You can say, so it's like of a configuration file. So developers write up the configuration file. In that, you will write up all the dependencies, like what type of packages means, or the runnable executable files are also required on your site. For example, when you install any software onto your system, sometime you must have seen, you get up the alert, you can't run this application because Java version is not available onto your system, or maybe .NET version is not available onto your system. Some supporting softwares and dependencies are needed. Okay, so in that case, those dependencies will be downloaded onto your system, and once those dependencies will be installed, then your application starts running on it. So what you do, you write up in a pom.xml, you write up what all dependencies should be installed for the software. Some supporting softwares are needed in your system. When you download any software, okay, sometimes you might have got when you have a new laptop, you must have got the error message like you need Java version 1.2. I'm just giving you an example. A Java version this one to run up this software, you need this software to run up this software. So you must have seen there are dependencies between the software. They run as a one unit. They need some dependencies. In even if you check up into your onto your laptop, there will be a multiple softwares running in a background which is supporting your main software, because you need those packages, those versioning to run up your application. Okay, in an application, many several things are dependent on a background. Making a combination of all of them together brings up the main application to run properly. If those dependencies are not there, then your applications will stop working. Even if you see in your laptop also, just open up a control panel and see what all softwares are installed. So you will find it out many packages are installed onto a background. For example, I will go over here. Now see, into my system to run, you have a .NET SDK version, framework version. You have a SQL Server. With the SQL Server, other dependencies get installed. Visual Studio, Visual C++ is many times required to run up the software. Node.js is there. Many type of softwares are available into the market which need some dependencies to be installed onto your system. Not in case of web application. This is majorly required onto the this one on for the desktop applications. Okay, those are the dependencies. Now what happens, you write up a pom.xml file. In pom.xml file you mention all the dependencies on and their versions. So what happens in versioning, because for example, you have a Java code. Now if you have for example, you're writing up a Java code of 1.2 version, then dependencies will also be installed which will support those 1.2 version. It doesn't mean that you are taking up a latest version of a Maven and then you are using up the dependencies of the oldest one, because they will not support each other. Okay, so in that case you need to have that same type of dependencies, same level of dependencies and versioning should be there into that particular code. So to mention all those things, what dependencies are needed, you will write up into a pom.xml file. You usually don't write it as a DevOps engineer. It's not your task. It's the developers who write up that dependencies file. So that is into a pom.xml. And then you are enforcing a directory structure. Directory structure will be like, you have the images, you have a main code. So everything will be there into that particular Java code where you will write up these structures and everything will be saved. Then once you will execute that one, it will create up a executable file. In executable file, it will store all that information which you have written up into the code. And once you will execute that executable file into some server, automatically whatever you have commented out or whatever things you have mentioned into the code will execute. Okay. Now, what is Maven? Maven is commonly referred to as a build tool that is used to manage the entire life cycle of a project, generates reports and store documents with its POM repository. So what is Maven? Maven is like, I've told you, it's a build compiler tool. So what happens in case of Maven, you have the dependencies. Dependencies will be downloaded from where? It will be downloaded from the internet. Okay. So in a POM, there will be one pom.xml file. Okay. In the pom.xml file, you will mention what dependencies are needed and what version is needed in that dependencies. So once you will run that particular executable file, what will happen? Automatically that version will be installed onto your system. So dependencies will be there, modules will be there. You will mention all those things. Then you will start building up the code and you will get an executable file. Now using that executable file, you will copy it into the server. That is a complete application. And then once you will run that particular executable file, it will be installed onto the server. Okay. Now, what does the Maven do? Enforce a directory structure. It helps you to create up a directory structure, manage and download the project dependencies, build an executable for the code. Okay. The Maven is used basically for the Java. You can use up a Maven for different languages as well. Not .NET and all. You can use it for Groovy and all. You can use it for that as well, but majorly this Maven is used for the Java projects to build up the code. Now going further, managing and downloading project dependencies. What do you mean by managing and downloading project dependencies? Like I have told you, several other supporting files or supporting versionings are need to be installed when you run up a software. So how do we do that? So why we write up dependencies? Because for example, it might happen. Let me create up a new notepad. This is a developer A. Okay, this is a developer A. He knows what all dependencies are not needed. He knows what all dependencies are needed. So he can manually install those dependencies on his system. Okay, but let's suppose he's running up onto his system. It's fine because he will install those dependencies onto his system. But now he will, if he will give up the code, if he is giving up a code to some particular operation persons, okay, who or maybe he is copying up to any of this server. Now, will he run up that dependencies manually to those server as well? No, because on a server, we always do like this. We try to create the things dynamic. We will not keep that process manual. So that's why, to avoid that manual process, we write up all the dependencies into a POM XML. So once the developer will give the code to the operations team person, and operations team person will run that code into that server. So what will happen, when he will run that file, that executable code, first of all, it will check what all dependencies are mentioned into the POM XML file. So the all the dependencies and versions which is required and mentioned into the POM XML file to execute that code, that will be downloaded from where it will be downloaded from the internet to that particular server. Now what is happening, all the dependencies is installed to that server. Now whenever that particular code will be executed, it will find it out that this version is available. Now it will help you to get the things work done. Now what is dependency? Dependencies, actually I have told you, there are multiple features. Like you have a login feature, you have a let's suppose you have a payment gateway feature, you have a security feature. Multiple features are there into the application. Now these features come up with other softwares or other you can say small dependencies which help them to make those things much more secure. For example, you must have seen we have two types of URL, HTTP and HTTPS. HTTP is not secure. HTTP is secure with the certificate. Now to on that certificate also, you need to buy the certificate. You have several things to make that particular website to be secure. So these are all dependencies which works on a background. So even if, like for example, if I give you a layman example, okay, let's talk about a car. In a car, when you have a car, you want to drive it out, the main things you always focus is gear. You always focus about the clutch, accelerator, brake and steering. But on a background, when you go into the engine, when you open up an engine, you will see there will be many small parts are there which help together, which help each other to make that car run. So similarly, in a code also, when you're writing up any feature on a background, multiple versions and multiple things are required of different softwares so that your application can run perfectly fine. So that kind of dependencies get installed onto your server once you will run up that code, and those dependencies will be mentioned under the POM XML file. That is the benefit of that POM XML file and the dependencies. Okay, I hope you must have got it now. Okay, now managing and downloading project dependencies, that will be done through the POM XML file. Projects may need a Java APIs or frameworks that are packaged in their own jar files. These jar files are needed in the class path when a project code is compiled. So, like I've told you, you have a directory structure, POM XML. Now request what will happen, like POM XML, you have mentioned which all dependencies are there. Request the dependencies, then it goes back to the API, to the internet. It will download it from the internet, gives to the project, and it goes to the directory structure. Now, what do you mean by directory structure? In a particular Java code, or maybe like when you will see the code in actual, you will see there will be many files are there, many structures are there. Now, for example, you have src slash main dot the main Java. Okay. Another one is src slash main slash resources. Multiple type of directory structures will be there. Now, each and every directory structure will have their own set of files. For example, let's suppose you go into the library. When you go to library means the actual library where you go for reading up the books in your college and all. I'm giving an example of in a day-to-day life so that you can relate it easily. So in this one, let's talk about the library. In a library, your college library, you go over there. In the college library, you see there are shelves. Correct. In this is a library. You have different shelves. In let's suppose in this shelf you have a science books. In this shelf you have a maths book. In this shelf you have a history books. So now if you need a science book, so where will you go? You will go to the science look over here, science shelf, and you will pick up your whatever book you needed. You will take it up. If you want to know, I want a maths book, you will go to the maths row, and you will pick up that particular rack. From that rack you will pick up the maths book. So similarly in Java also, like I told you, multiple files will be running up to run up your particular code. So now when you are when Java or any of the compiler needs to look into the file structure, if they are looking for some files. So if I put it all together into the same file, one folder, will it be easy to find up the file which they needed? No, because it will become very complicated and it's not easy to find it up. Even while writing up the code also, it will not be easy to find up the files. Even for the application or this system which is running up that particular application, it will be not easy for that to find up the file because it doesn't know where to find up that file. So that's why we create up a directory structure like src main Java, src main resources, src main filters. Each and every directory will have their own usages. You will get to know that if you're working on to the src main Java, if what type of content will have into the src main Java, it will be application and library sources. In case of src main resources, what type of files will be there into this one? It will be application and resources. Now what type of files will be here into this filters? Resource filter files. So each and every directory will have their own set of file structures, so that if the particular user or particular applications need some information, some type of information, they will go to that directory structure and they will find up the file. And if they find the file, it will react according to the things mentioned into that file. Okay, I hope now you must have got what is a directory structure. And dependencies can be downloaded from the internet server. Yes, and there are multiple things. Actually, what happens in some companies, what happens, you have a server. In those particular servers, you don't have an internet connection. So this question also comes in interview. Let's suppose you want to install the dependencies and internet connection is not there. What you will do? So alternate to that is, for example, there is another server. You will bring, what you will do, it have an internet connection. So at time you will need to run this, install these dependencies. You will make a connection between these two servers. Okay. Now this server will install the dependencies for you, copy those dependencies to this server, and your application will run. Okay. So many type of these things can come up into your interview question, that you have a main server and main server is not allowed to talk to internet. How will you install the dependencies? So POM XML file, once you will compile up the code, POM XML file will be there. At time of deployment, automatically it will check for the POM XML file. And while deploying only, for example, when you install any software onto your system, you must have seen it shows you 10%, 20%, 30%, and once it is 100%, your application is successfully installed. You must have seen into your mobile also, these kind of things come up, 10%, 20%. So what happens? There will be a executable file. It start extracting the data information out of that executable file. It starts unpackaging it. So just take an example. You have a folder. You first do a rar, you do a zipping, and you then give it to some other person. Some other person unzip it. Similarly, in this one, you can say, so you have a code. First you are zipping that code, you creating up an executable file, you are copying that executable file to the server, and over there you are again unzipping it. So while unzipping that particular code, it will check for the POM XML, that what all dependencies are needed, and from there it will install that dependencies to that server. So every Maven project directory needs a POM XML file. This file contains all details necessary for Maven to effectively execute a project. The POM file is stored in a SRC. SRC, what is SRC full form is source folder or a root directory. So it will be stored into a root directory. So this is how your POM XML file looks like. Dependencies in this one, you have a version. Do you see this version? What type of this is required? What type of group ID is there? What is the scope? Everything is mentioned into this POM XML. Don't worry, I will show you the real-time scenario as well. How to use up the POM XML file, I will show you. Now, what happens in Maven build lifecycle? First, we validate, compile, test, package, verify, install, and deploy. So in this complete build Maven lifecycle, for when you're doing up a build, okay, when you're running up a build pipeline, in the build pipeline, first it will validate whether you have written up a code in a correct way or not. If it is correct, then it will compile. Compile means start creating up the executable file. Then it will also test your code. Test your code means it will do some internal testing, whether all the format is correct, whether you have not used the dependencies which has a vulnerability. It's an internal check from the Maven side. Then it will create up a package. Package means an executable file will be created. Once executable file will be created, it will verify. It will verify again that the package you have created is fine or not. Once that is verification is done, the package is good, then you can install that executable file, or you can take up that particular package to the server, and then you can deploy onto the servers. That is a complete life cycle. So now explaining you every phase into detail. What is a validate phase? Validate the project is correct and all necessary information is available. Like you have written up a code, it will verify whether the project is correct, the file format is correct, the directory structure is fine or not, POM XML file is correct or not. Everything it will validate first. Okay. Then in a compile phase, during the compile phase, Maven will compile all the .java file present in the main directory into a class files and put them back into the main directory in the dedicated folder. So what is happening? Maven is there. Compilation has been started from here. From this compilation, it will go to this directories. Which directories? Java files. It will look for the Java files into the directory and .class files into the directory. Once it will find that particular one, it will store it into the information and start creating up the application. It will start compiling that one. It will start installing the dependencies. It will start working onto that particular one to create up the executable file over there. So that is how the compiler will work in this case. Now in the test phase, during the test phase, Maven will execute the specified test cases and create a summary log. So in a test cases, what happens in test cases? Usually what happens in test cases, you do a manual testing or automation testing. That is a separate thing that you do it from the Selenium, or you do a manual testing to check up the functionality. But Maven itself runs some test cases. Test cases means internally when the this particular product was created, the Maven compiler was created, or at that time, what was done, some internal test cases were written to check up what is a code and how this code is written up, whether the code quality is good or not, what is being there into that code. It verifies its syntax, it's verified structure. So that kind of test cases has been written up within the Maven. So then using that test cases, you can do and it creates up a report for you. So if I tell you about the Maven, it's create a report using the JCoco, or there is one more Koburchra. So there are the two testing file formats which will help you to create up the reports as a test results. JCoco. So everybody just write it down. You can search for it, search for that case as well. JCoco and Koburchra. These are the two ones. If you enable this to any of them, if you run up this any of them for the test cases, then it will create up a test results for you. It will help you to detect whether the test results are fine or not onto your code. So it's not mandatory that you want to run that JCoco or Koburchra. It's optional one. So you can enable any of them to create up the test reports, whether your code is fine or not. Okay. So that is the about the test phase. Then we come across the package phase. During the package phase, Maven will package all the class files and resources into the one file. This file format into one of the three types. Like I've told you, jar, it is one of them, jar, EAR, and var and EAR. So you have to search. This is a homework. We will talk about this one in tomorrow class. This is a homework for everyone. You have to find the difference between the jar, var, and EAR. Any of this file format will be created when you will use a Maven for the packaging purpose. Okay. So what is happening? There was a .class files. This was into the directory. Maven has found out this particular class files. What is happening into it? Maven will package those one and create a archive files. Like I've told you, we will create up a executable file. It is happening in a similar way, like you do a unzipping your package. Like I told you, in a layman language, into a day-to-day routine, we zip our files, then we unzip it to the servers. Similarly, in this case also, we have the files using the Maven. We are creating up a executable file. That is a package phase. Now verify phase. It runs any checks on results of integration test to ensure quality criteria are met. At the same time, all previous lifecycle phases are also executed. That is a verify phase. Now install phase. Install the package into the local repository for use or dependency in other projects locally, or previous life cycles are also executed. That is a install phase. Deploy phase. It copies the final package to the remote repository for sharing the other developers and the projects. So what happens in deploy phase? You have created a let's suppose using the Maven, you have created up the executable file. Executable file means, let's suppose, jar file. Now that package has been created. Now that package will be stored somewhere. So what we call it as? We call it as an artifactory. Now what happens? Using Maven, jar file has been created. You will store that jar file at some location. Okay, why we store it at some locations? Locations could be like, you can say about the storage accounts or storages. That location we called as a artifactories. Okay, there are multiple artifactory softwares available into the market. For example, JFrog. You also have Azure artifacts. you also have Nexus. So you can think about this when we talk about JFrog as your artifacts or Nexus. In this one, your packaged code will be stored. Why we use this software? Why we don't keep it directly to any of the storage account or hard disk? Why we use this software? Because when you write up an application, you write an application and it will have a various versions. So in these artifactories, you can store the versions means, like, for example, you have created one app. In that app, you have initiated with the basic code. You have a basic application. Now after some time, you brought up some new feature. So version 1 was there, version 2 will be there, version 3 will be there. So all this version 1, 2, 3 will be stored where? It will be stored into this JFrog, Azure, or Nexus. So if you want to deploy into the server, you will select which artifact, which version you want to deploy onto the server. You will take it from these artifactories. So in these artifactories, it works as a storages in which you take up the different versions and then deploy onto the server. That is the part over here. So in a deploy phase, we are saying this only. It copies the final package to the remote repository for sharing with the other developers and project. At many places, you will hear about the repository. Don't get confused. A repository is a terminology. It will be used in several places, but it has a different meanings. Earlier, when we talk about the repositories, it was a Git repository. Repository means a storage place. So in this, earlier we talked about the Git repository. Now we are talking about the remote repository. Remote repository means Nexus or artifacts, a storage place where you are putting up your artifacts. That is the remote repository. In future, we'll talk about the Docker repositories. Many things will come over here. So always try to differentiate with the prefix word. What do you mean by the repository? In which context we are talking about the one? Okay. Now in this artifactories, what happens when you will work on the JFrog, Azure, and Nexus? We are not just using up for the versioning. In this JFrog, Azure, and Nexus, we also get a multiple other options as well. Like you can also run up the security check onto your particular artifact. You can do multiple things once this particular artifact gets stored onto the server, this software. Each and every software have their own benefits. So you can do a multiple things. You can create up the reports. You can do multiple things while on this software as well. So that's why we don't use directly a storage account or a hard disk. We use up these softwares to maintain those versionings of this particular packages. Okay. Now Maven repositories. What is Maven repositories? After Maven understands which all dependencies are needed from the POM XML file, it will download those dependencies from the remote repositories and then store them in a local repository for current or future use. So like POM XML has asked, Maven has asked from the POM XML file, it has deducted what all dependencies are required. It will go to the local repository or either to the internet, and from there it will gather the dependencies and install to the system. Okay. So what is Jenkins? Jenkins is an open source automation server written in Java. Jenkins helps to automate the non-human part of the software development process with continuous integration and facilitating technical aspects of continuous delivery. So what do you mean by Jenkins? Jenkins, like I have told you earlier as well, is an open source tool. Open source tool for what? To bring up the automation in the build and the deployment process. And what is a build and a deployment process means? It means continuous integration and continuous deployment. So that is the this is one of the tool. Why we say it's an open source tool? Because anybody can go ahead and install this software. You can set up a server at free of cost and start using up in their company. Okay. So that is why we call it an open source tool. Anybody can also give up their ideas how to move up into this Jenkins. They can put up their own suggestions into it. But in case of Azure DevOps, and maybe like AWS DevOps, or there are some other tools as well like GitHub and all those things. Those are from the particular you can say a service provider like Azure DevOps. Azure DevOps is from the Microsoft. AWS DevOps, it's from you can say it's about from the AWS. So each and every CI/CD tool belongs to some company. In this one, it's a open source and is free of cost. But for Azure DevOps, AWS DevOps, you have to bear the cost of those services. That's why we call it a Jenkins as a open source tool. And also in case of Jenkins, you get a free services. Like free services means that you can set up onto any server, either into a locally or either onto the VM machine. Anywhere you want to set it up, you can set it up over there from the Jenkins. But the limitations is like similar. When you will go for the paid subscriptions, the Azure DevOps and AWS DevOps, you get a support, you get a more features as compared to Jenkins. But still Jenkins is very much a strong product, and most of the companies are still using up a Jenkins because of the cost efficiency and all other things. Okay. Now, features of Jenkins adoption. Jenkins is extremely popular among the open source community. Hence, there are more than 1,47,000 installations throughout the world, and 1 million people are using it. Secondly, plugin support. With an extremely open source activity community, Jenkins has around 1,000 plugins that allow it to integrate with the most of the development, testing, and deployment tools. So now, what is plugin? Plugins means like a supportive, you can say extensions. For example, you have a Google Chrome. Okay, now you have a Chrome, the browser I'm talking about. In that browser, you can set up the plugins. What is the use of the plugins? It works as a supporting softwares. So, for example, you want to view something onto the PDF file onto the Google Chrome. So what you will do, you will install the plugin out of it, and next time if you want to see the PDF, that PDF will be open up into that same browser. You don't have to install any extra software out of the browser. So that is kind of a plugins are there. Similarly, we have a plugins into the Jenkins. Plugins means you have a external or third party kind of software which you can install and use it with your actual product. Over here the actual product is Jenkins. So I will show you. So there is an option called as plugins. Under the plugins you can go and you can install the different types of softwares. Okay, let's go ahead. Now, before Jenkins, locating and fixing bugs in the event of build and test failures was difficult and time consuming. After Jenkins, smaller and automated continuous build and testing made the task accurate and faster. Tests were triggered manually. Developers have to just commit the code to the remote repository, build, test, and development and deployment happen automatically. That's the differences between the before Jenkins and after Jenkins. So what was happening before Jenkins, like people used to do a manual deployment. It will take time. If you are going with a manual deployment, there could be a chances that you can bring you are not following the proper process and you are throwing up the error. The system is throwing up the error. So, but in case of continuous integration, as you set up the task once, every time the same task will execute, so chances of that error onto your pipeline is very less. In that case, you have to check up the code. So if I tell you my live scenario examples, actually what happens, we get a usually request from the developers that the pipeline is failing. So usually when I try to do the troubleshooting, what I do, I always check it out that whether this is a new pipeline or old pipeline. Okay, if it is a new pipeline, then there could be a reason, and it has never been executed successfully. So there could be a reason that there is an issue in the pipeline. Otherwise, now let's suppose you have created a pipeline and it was working earlier, it was working fine. Like you have executed it successfully 6 to 7 times. Okay, everything was fine, and even developer said yes, it's working fine. Now in future, after 1 month, 2 month, or maybe like 2 days, 3 days, if developer comes back to you and say this pipeline is failing, then there is a higher chances that that the developer has made some changes into his code, because of which the pipeline is failing. Why so? Because the same pipeline was working earlier as well, like 1 month ago or few days back ago, and nobody has made the changes into that particular pipeline. So I always analyze that no changes has been made into the pipeline, so why it's failing. I will try to find out the reason, that what has been changed from past till now. So from that point of view, I will able to get that this particular changes has been made into the code, not to the pipeline level. So I will ask the developer that the issue could be onto the code side, not to the pipeline side. So this type of things can come up into your daily life to troubleshoot the things. This is how you can analyze that whether it could be your pipeline issue, or whether it is a code issue. You can identify this way.
Let's have a quick quiz question, guys. And the question is, which Maven plugin creates the project structure? And your options are execution, properties, archetype, or dependency. Please mention your answers in the comment section below.
Just a quick info guys, if you want to make a career in cloud computing, then Intellipaat provides an advanced certification on cloud and DevOps by IIT Madras. This course is taught by industry experts and IIT Madras faculty. This course is designed to upskill and land your dream job. Now let's continue with the session.
Now installing Jenkins on AWS, like I have already given you the activity, the link yesterday. You can set up the way. I will set it up onto the this one, Azure. Okay, so let's start. What does the first line say? From here, let's configure your environment. So if you don't have a Azure subscription, then you have to follow this first step. If you have a Azure environment up by Azure environment, I mean you have a Azure subscription, then you can skip this first step. Okay, open up a cloud shell. So what is a cloud shell? Cloud shell means you want to run up your CLI commands. By CLI commands, I mean Azure CLI commands or Azure PowerShell command. So in that case, one way is either you can run it from your local, or other way is you can run it from the cloud shell. So to open up from the cloud shell, here is the option. To when you will be if you want to run through the cloud shell, you need at least one storage account under your subscription. Why you need a storage account? Because if you know, when we run any commands on your CLI means command prompt, or or PowerShell, what happens, it creates some logs and it needs some file or directory structure. So in case of this particular cloud shell, you need some space where these logs will be saved, or where these changes or these records will be set it up. For that point of view, we need up a storage account. So I am creating first storage account. You need only one storage account to run up the Azure CLI or Azure PowerShell in the portal. So let it create. This is creating up my storage account. Once my storage account will be set up and running, I have to select the command line environment. So it could be PowerShell or either the Bash. So once this particular cloud shell step is done, next step is to create a virtual machine. How to create up a virtual machine? These steps has been mentioned. So what does it say? Create a test directory called Jenkins started. Now, once this particular directory has been created, switch to the directory. How to create a directory? If you know the Linux, the same commands which we will execute in the under the bash. So we are under the bash means we have to execute the Linux commands. So it is saying, let's create a test directory. To create a test directory, how we do it? mkdir. So it after creating up this directory, what we have to do, we have to switch it to that directory. How we switch it up? Cd paste over here. Now you can see I am under this directory. This location has been changed. So I am under this directory now. Now what is I have to do? I have to create a file named cloudinit.txt. Oh, sorry, create a file. So we have different editors. Using any of those editors, we can create up the particular file. So over here, if I want to create up the file, there's other ways as well. You can create it. So let's take it like this. I want to create it with the, let's suppose, Vim. I wish Vim is downloaded. Okay, now this is an editor. Under this editor, what does it say? Paste the following code into the new file. Okay, new file will be copied. So before copying up this one, let's try to see what is happening. It is saying us to run up the CMD and the command, which commands install apt. This is a JDK version. Okay, we have to install that. Then we have to get that Jenkins over there. So what we are doing in this one, we are creating up a virtual machine, and we are also setting up the Jenkins into that particular machine. So I will copy this one. I will let me. I have pasted it. Now to save this one, what is the way? WQ. Now let's see ls. Using the ls command, I can see that this particular file has been created. To confirm my content, my data is or what the lines which I have copied, is it fine or not? The cat and then the cloud. So it shows me, cat shows me that the files are the file has been updated. Okay. Now going to the next line, we have to create a group. What is a group? Group means into the Azure, you are creating up a resource group. For creating up any resources into the Azure, we need two inputs compulsory. What is those? One is a subscription, another is a resource group. So resource group is just like logical grouping of your resources. What do you mean logical grouping of your resources? Like in a school, we have a different classes A, B, C, D. We have this different sections into the school, and students are there into that classes. So that is a logical grouping of your classes or students. Okay, so that in future, if you want to identify this student belongs to which class, so you will take up a section name. Similarly, in this one, you create up a groups just for logical grouping of your resources. Because if let's suppose I have created a virtual machine, this virtual machine belongs to which project, I will identify using the resource group name. Okay, so I'm creating up a resource group from here. uh, Take it, I've copied this command. What does it do? It is creating up a resource group with the name of Jenkins started RG. Location means it you want it to create up this resource group at which geography. So we are creating up in East US. Okay, so now resource group has been created of in my subscription. Now next part is I will create up a virtual machine. So in this one, let's try to understand what is happening in this particular one. We are creating up a virtual machine. In the virtual machine, what I am doing, where I am creating it up, I am creating into this particular resource group. Okay, so in this resource group, I am creating my virtual machine. What will be the name of my virtual machine? Jenkins started a VM. That is the name of my virtual machine. Image Ubuntu LTS. What do you mean by image Ubuntu LTS? That what operating system I want. Username, I'm putting this as a username, and then I'm asking them to generate a SSH keys. That is authentication method. Which authentication method I want to use? I want to use up the private key and public key concept. So over here I'm doing that. Now custom data. What is a custom data? You remember I have created this one of the file. So I am saying that while creating up a virtual machine, take this file as an input. So what do you mean by this file as an input? That whatever commands are there into this particular file should execute. Now in this file, what the commands we have given over here, we have given to install the Java because we need it for the Jenkins JDK version. Then also we are asking to get this particular, this is a public repository. Here your actual Jenkins package is available or executable file is available as a software. From there you will download it, and then you will be running up that commands, and then you will do a apt get in update. So all dependencies under your Linux operating system will be updated using the apt get update. So that's what we are doing it into this command. Let's try. So it might happen that the virtual machine will create successfully, but this file will not work. It happened with me in my last session when I was teaching to the students a month or 2 months ago. This particular file was not executed successfully because of the JDK version. Why JDK version? Because this particular article of Microsoft is quite old. It's not yet updated. So JDK version over here which is mentioned is now obsoleted. You want a latest version. So one thing is, if it fails, I'm giving you a case. If it fails, what we have to do, either you can create up a new virtual machine by with the new updated one, or otherwise what we will do, I will log into the virtual machine which has been created, and I can follow these steps manually over there as well. So try to understand what I am saying. In this particular case, what I the current status which I am doing right now, what I am doing, I'm creating up a virtual machine and I'm giving him the instructions. What instructions? That while creating the virtual machine only, please set up the Jenkins server. Now, but the thing has happened reverse. It has created the virtual machine, but Jenkins is still not up and running. So what is an alternate? You can follow the same commands from your this particular Jenkins server, or you can say this VM machine, because this is the same steps you have to follow before as well and after as well. So after creating a virtual machine also, you can follow this commands and it will help you to set up the Jenkins server. Okay, let's see how what it worked. Okay, we got this output. Okay, the virtual machine is up and running and IP address is this one. Now we will go, what we will do, one second. We want to do a VM list. We want to set see the VM list, whether it is has been created or not. We are confirming. Okay, so it shows you that this particular one VM is up and running. Okay, now going further, what we will do, we will open up a port 8080. So what happens, like if you have worked on Nginx, or if you have worked on to some other system, the the hosting systems, we have a software on which you can set it up your code, and then you can interact with it. Now by default you have the port number 80 of this type of services. Similarly, in case of Jenkins also, when you will hit the URL of a virtual machine, it will ask you that on which port number you have to put it up. So you every time when you are running up the Jenkins, always give up the that port number as well on which you have installed the Jenkins server. So first we are opening up the this one. What we are opening up the port number. So copy this one and execute. See, and the whatever thing I am doing it right now, I am doing it through the commands. Same thing can be done manually as well, but to save the time and to make you learn about the commands, I am doing it from the command line. You can do the same steps from manually as well. Even you don't need to run these commands. But I would say in a company, you should learn and work with the commands because it will help you in a long term. Okay. Now configuring the Jenkins. We have to configure the Jenkins. Let's see. We need an IP address. So what is the IP address? This is the IP address. Now I have to log into that machine. Now what does it say? Using the IP address retrieved in the previous step, SSH into the machine, you will need to confirm the connection. So in this one, I will copy this particular, paste it. But in this one, I have to change the IP address. So it's asking me for fingerprint. Yes. So now you can see I am connected to my machine. I'm logged into my machine. Now I'm right now into my virtual machine. Okay. To check the status of your Jenkins, you remember using that particular file, this particular file, we have set it up the Jenkins. So if your Jenkins was successfully installed, so what will happen? One of the services will be created for the Jenkins. What do you mean by services? Like in Windows, we have the services over here. These services run on a background to help your system to work on to different type of softwares and perform the task. Even if you check it out on your system as well, on your laptop as well, multiple type of services are running. So for in case of Jenkins also, once your Jenkins server will be up and running, one of the services will be created by the name of the service Jenkins. Okay, what is the name of a service? That is Jenkins. And what we are trying to do, we are trying to check the status whether it is running or not. So in Windows, you can check it through this way also. Go to the services and see if it is running or not. But in case of Linux, you don't have the GUI. You can't interact with the help of GUI. So what we will do, we will use the command to see if my Jenkins is running or not. So now, as you can see, this is running active. Active means my particular Jenkins services are up and running perfectly fine. So no changes are required so far. Everything is fine in this Jenkins server. If it has been stopped or deactivated or something like that, it means my Jenkins is not set it up correctly. Some issues are there, but it seems the Jenkins is up and running right now. Okay. So now what I have to do, I have to go ahead and see one thing. What I have to see over here, what was the IP address of my machine? You remember the IP address of my machine was this 232.42.212. So what I will do, open up one of the page, put up the IP 232.42.212. Now this is the oh sorry, 121. This is the IP address of my machine. Okay, now try to hit this one. Okay, let's do like this. I will put up the colon as well. I will put up the port number as well. Now let's see. After putting up the this port number, you remember I was talking about the port number, it should be open. So now what is happening? My Jenkins is running up onto my machine on which port number? 8080. So you can see on the first time when you will run up your Jenkins the first time, for that time you will get this kind of page. Okay, this kind of page will be visible. This is the by default page, and there will be some admin password. And how to get that admin password? You will use this command cat. So cat sudo cat. There's a file initial password in this location. So I want to see that initial admin password. so that I can copy that password and paste it over here as an administrative password. This is a one-time activity. Okay, so let's go ahead. Now, once I have executed that command, I have got this particular key. Copy this key and paste it over here. Let me see if it is pasted. Yeah. So once you have pasted, that is a administrative password. Continue. Now, the next steps which are coming over here, these are the steps for configuring the Jenkins. Now, there is no relation between VM and Jenkins right now. By no relation means the things which I'm going to do right now, that is the Jenkins configuration, not a VM configuration. Earlier till now, we were configuring up the VM. Now, this is a Jenkins server. We are configuring it up. So we have customized Jenkins, install suggested plugins, or select plugins to install. So install suggested plugin means like you remember when you install any software, there are few by default suggestions for you, or they ask you, okay, tell me what you want to install. So I am taking up a install suggested plugins because it helps you to install the plugins, many important plugins by its own. Otherwise, I have to do that process manually. So I've selected this option. See, these kind of these all plugins has been installed, or it is trying to install all these plugins onto my virtual machine, because these plugins will be required in my or in upcoming projects so that we can work easily. Okay, now it's asking me for the username and password. Now I can set up my username and password for the first time. Let's do it. Now every time if I have to log into the Jenkins, I will be using up this username and password. This is my Jenkins URL. In companies, what happen? You can set up your own URL. Why you set up your own URL? Because you will not give the IP address to the developers or any other person who wants to see the CI/CD pipeline. You remember every time you see any website, you have some host name. You don't use up the IP addresses. So in this case, if you want to set some your domain name or your company name, something like that, then you can replace it over here, or otherwise you can use the this IP address colon 8080 for login to this Jenkins instance. Save and finish. Once your save and finish and setup is done, you will see this page. This is your Jenkins. Okay, this is your Jenkins. Now we will create up the CI/CD pipelines in after some time. But this is your Jenkins. If somebody asks you how does the Jenkins looks like, the dashboard looks like, this is the front page. This is the main page. If you get this page, it means your Jenkins server is set it up correctly and it's ready to work on. Okay, I will tell you about these things. First job and all, that is a CI/CD pipelines, your first job. So before going to the explanation of the Jenkins, let me tell you the architect of the Jenkins. What all we have into the Jenkins. Jenkins architect. So Jenkins is one of the tool which is installed onto a server, either VM or Windows. So in our case, we have installed it onto a Linux, correct? Ubuntu. So now over there, we also had a plugins. You remember when I was setting up the front page, that time I've got the option to set up the plugins manually or either the by default of the Jenkins. So I've selected the by default one, which included many plugins. And then there are the DevOps tools as well into the Jenkins. Now, if you want more plugins, how you can install the more plugins? On a left side, like you are into the Jenkins, on a left side, you have the manage Jenkins option. Okay, let me log in. I think it was. So on a left side, you see manage Jenkins option. This is the Jenkins option. Like if you want to set up or if you want to configure anything onto the Jenkins server, you will go under the manage Jenkins. Under the manage Jenkins, you have different options. So if you have some plugins installed, if you want to delete it, or if you want to add some more options, if you want to bring up some new any options into this Jenkins, you want to install the plugins, then you can go to the plugin manager. Under the plugin manager, you have the option called as updates, available plugins, installed plugins, advanced settings, download progress. So I think this is the latest version of Jenkins which I have installed. Earlier this was looking in a different way. The dashboard was different. Now this is a newer version of the Jenkins. So this looks has been changed. So in this one, the updates means like the plugins which you have installed, are there any updates on that plugins? If yes, then it will show over here. Available plugins, it will show you the complete list of plugins which is available on internet. So you can use these plugins for your perspective. For example, you want to create a dashboard that to check it out, which pipelines are failing or which pipelines are working successfully. You want to create a dashboard, so you can use that plugin, install that plugin onto the Jenkins server. Similarly, I've asked you to install the Maven, so you can also install the Maven directly to that server, or otherwise from the plugin you can install the Maven. You can search for the plugin which you're looking for, and then you can install that a particular feature onto your Jenkins server and start using it out from here. So during the class and demo, I will be installing few of the plugins according to the project and as per the requirements. I will show you that part as well once we will come up to the Jenkins hands-on. Maybe I think tomorrow I will do that hands-on activity. We don't have enough time today. So I will show you how to install the plugins, but I'm making you all to show how the things work onto the Jenkins and where we can see the options. So now in this plugins, you can download this available plugins. Installed plugins, it means which have already been installed into your Jenkins server. So these are the different plugins which is already installed onto my Jenkins. So I can delete it as well. If you want to disable, you can disable it as well. And you can do multiple things from here, the installed plugins. Now these are the advanced settings. Advanced settings is like, for example, you have your own plugin, or maybe like you have your own servers where you have those features, or anything you want to bring it over here. Then you can use the advanced settings, like HTTP proxy, server name, port number, username, password. If you change it to the with the plugin, then you can use this particular option, advanced setting. Download progress, as the word says, like for example, you are downloading any plugin and it is taking time. You can see the progress from here. It is successful or it was failed. It's like anything related to the plugins, the status can be shown from the download progress. Okay, that is about the plugins. Next, what happens? There's a architect. What happens? There's a Jenkins master, then is a slave agents. So this is a little bit to understand what is the master and slave. Now what happens? As you know, I have created one of the virtual machine. Okay, this virtual machine was there, and this is a Linux virtual machine. Now, let's suppose this is a master. Master means the server on which your particular Jenkins is installed. You can run the jobs on this master as well, but there is a thing to catch over here. The thing is, for example, if I talk about in this test cases, the one which we will do for the practice one, in that case, you will create one or two pipelines, correct? You will create one or two need one pipeline or two pipeline or three pipelines. I'm talking about number of pipelines you will create. Or now what will happen? The pipelines which we have created will be dependent on which OS. It will be dependent on to the OS of the server on which you are running it up. For example, I'm running up a pipeline 1, 2, 3. So those will be dependent on which operating system? Linux operating system, because I'm running my job using the Linux OS. Now let's suppose there is a project and they need a Windows agent, Windows operating system. So what I will do? Will I change the master to Windows? No. What you will do? You will create additional VM machines, two more virtual machines, you can say so, or three. How now depends upon how many machines you want. So you will create, for example, you created up a 4 more virtual machines. So now what you will do, you will create this virtual machine with Windows. Okay, you will create this one with the, let's suppose you have another flavors of Linux, you create with the Kali Linux. Other than this, you also have other operating system as well. Linux flavors are there, so you have installed some other operating system over there. So, or maybe like Windows Server is there, Windows 10 is onto this one. So it depends upon project to project which type of machine it requires to build your project. Okay, so for example, if you have a .NET project, most of the companies, 90% of the companies prefer to use a Windows. Why? Because Windows supports a .NET very well. So in that case, you will need a Windows agent. Now what you will do, you have created this additional VMs. This was a VM 1, 2, 3, 4, 5. This is a master. So now what I will do, I will attach these agents to this master agent. Okay, I will attach these agents to this master machine. Now, the jobs which I will create, the CI/CD pipelines which I will create, in that pipeline, I will define which machine I have to use to create my CI/CD pipeline. I am talking about to create and run the job. So, creation of that pipeline, the information of that pipeline, info of that pipeline will be on master, but the job which will be executed, the job will be executed through these agents, and we also call it as a slaves. We call it a master. We call these agents, these VM machines, as agents, or either you can call it as a slaves. So in case of Jenkins, you will usually see the keyword as slaves. So slaves means the machines which are helping to run up the job. So example, this was there was a job 1, 2, and 3. So what I will do, instead of running up the job from the master, I will run the job 1 from here, 2 from here, 3 from here. What is a benefit? One benefit is operating system. If you wanted one job to be having a different operating system, second job with a different operating system, in that perspective, it will help. Secondly, it will also tackle your traffic. What do you mean by traffic? In my example, I have just given you 1, 2, 3 pipelines, but in a company, actually you have multiple pipelines, maybe 20, 30, 40, or maybe 50, like depends upon the number of projects using your Jenkins. Okay. So now each project have their own type of code, and they also need to run the pipeline quickly. So what happens if, let's suppose, there is a project. Okay, there's a project 1, project 2, and project 3. Project 1 has 10 pipelines, project 2 has 20 pipelines, and different developers are working onto these pipelines, and all together they all want to run the pipeline. They want to run their code, their build pipeline. What will happen if I will give a command to run the 10 pipeline, 20 pipeline? So what will happen? It will queue. So 30 pipelines will be queued. One will be worked. Okay. Then 2 will wait for it. 3 will wait for it. 4 will wait for it. So think about the person who has raised at the 30th number will have to wait for so much of time. let's suppose this pipeline took 5 minutes, this pipeline took 3 minutes, this pipeline took 10 minutes. So in total, think about the 30th pipeline, the will take how much time the developer has to wait to run his job. That is not good. So what we will do to control the traffic, what we will do, we will divide the task. So what I will do, out of 30, I will say, okay, you handle 10, you handle 5, you handle 6, you handle 3. So I'm just giving an example, don't 10, 5, 6, 3. So what will happen, it will handle the jobs in such a way that the long queues are not there. So that is how you can manage your Jenkins slaves and jobs, so that you can run up the jobs quickly and also with the suitable operating system. Now that is a concept of the slave and master over here. In this diagram I've said Jenkins is installed on master. You don't have to install Jenkins on these slave agents. This master will control that which will work, which agent will work on which job. You have to install Jenkins only onto this one, and from here it will be talking to these agents, these slave agents. This master will assign the task to these agents. There is an option over here to manage the nodes and clouds. So what you will do, you will create a connection between the master and the slave agents. You will create up a link between them. So what will happen, this master agent, the master machine, will automatically start communicating with your slave nodes. Okay, and it will start giving up the task to the slave nodes, and it will tackle it automatically. Happens when you create up a pipeline, you define that on which agent you want to run up a job. If you put up any, then it will be like a load balancing. If you want a specific machine, a specific agent to use, for example, I want a Windows only, I will put up the agent name to that pipeline and say I want to use this agent only to run the job. So in that case you will define, so let's suppose I want to use a Windows agent only. So it will wait for the Windows agent to be free. Once it will free, then only it will execute. In case of any, it will check which agent is free, and it will give the job to that agent to work on. See, Jenkins is a tool, so it's running on a VM machine. If your VM machine is down, what is, first check it out, what is the reason for that down. Either it can be stopped, or either it could be deleted, or maybe like this region, in which region this particular machine was created, that VM machine was created, there is a downtime at that region. So there could be multiple reasons. So we have to tackle the downtime. There are multiple ways. So don't think about the master of Jenkins, think about a virtual machine. If you have a virtual machine, how you tackle the disaster recovery of that machine, how you take up a backup of that machine. So do the similar way you take up as a normal virtual machine. Think about like this, you have a normal virtual machine on which a Jenkins server is installed. So whatever you will do for a normal virtual machine to take up a backup, to create up a disaster recovery, similar you will do for this machine as well.
Let's have a quick quiz question, guys, and the question is, which of the following is not true for Ant? And your options are, it is a toolbox, it is procedural, it provides lifecycle management, or it doesn't have formal conventions. Please mention your answers in the comment section below.
So let's start with, what is DevOps? DevOps is a set of cultural concepts, practices, and tools that improves an organization's capacity to provide applications and services at high speed. If I talk about what exactly is DevOps, it is actually collaboration of development and operations team. It is more of a cultural shift, which is kind of related to the agile methodology. And its priorities are resource management, communication, and teamwork. And an organization get benefited by the speed, functionality, stability, and innovation by following this methodology. I hope so it's clear to you what exactly is DevOps. Now let's move forward and discuss the next question. The next question is, how does HTTP works? And the answer to the same question is HTTP stands for Hypertext Transfer Protocol, which works in a client-server model like most other protocols. HTTP provides a way to interact with the web resources by transmitting hypertext messages between clients and servers. So, there is an HTTP request by the client, and in response, there is an HTTP response given by the server. This is how the HTTP works. Now let's move forward and discuss the next question. The next question is, what is CI and what is its purpose? Actually, CI stands for Continuous Integration, which is the process of compiling the entire code base every time a member of a software development team checks the code into the shared code repository. Suppose if a team member checks into the code file with a bug, the build gets broken. In this sort of scenario, the other developers can synchronize the shared source code repository without introducing the compilation errors into their own local workspaces. Thus, collaborative and shared software development cannot go forward. When a CI build breaks, it is crucial that a problem is corrected immediately. A CI process often includes a suite of unit and integration and regression tests that run every time the compilation succeeds. If any of these tests fail, the build will be considered unstable, not broken. I hope so it's clear to you what is CI and what is its purpose. Now let's move forward and discuss the next question. The next question is, name 3 important DevOps KPI. And the answer are, the 3 most common DevOps KPIs are, first, mean time to the failure recovery. Then there is a deployment frequency. And finally, we have percentage of failed deployments. I hope so it's clear to you what are the 3 important DevOps KPI. Now let's move forward and discuss the next question. The question is, what is the difference between continuous deployment and continuous delivery? Continuous deployment is fully automated, and the deployment to production needs no manual intervention in continuous deployment. Whereas in continuous delivery, the deployment to production requires some manual intervention for change management in the organization, and it needs to be approved by the manager or higher authorities to be deployed in the production. According to your organization's application risk factor, continuous deployment or delivery approach will be chosen. I hope so it's clear to you what is exactly the difference between continuous deployment and continuous delivery. So basically, if I talk about the continuous delivery, your code is done first, then you go for unit test, then you integrate, then there is an acceptance test, and finally you deploy it to the production. And in the continuous deployment, we have first the code is done, then there is unit test, then there is integration, then there is acceptance, and from acceptance test to deployment production, the test is done automatically, where in the continuous delivery, it is done manually. I hope so it's clear to you what is the major difference. Now let's move forward and discuss the next question. The question is, what are the core operations of DevOps in terms of development and infrastructure? The core operations of DevOps are application development, version control, unit testing, deployment with infrastructure, monitoring, configuration, and orchestration. I hope so it's clear to you what are the core operations of DevOps. Now let's move forward and discuss the next question. The next question is, can one consider DevOps as an agile methodology? And the answer is, DevOps can be considered as in complementary to the agile methodology, but not completely similar. Now let's move forward and discuss the next question. Can you tell me what are the advantages of using Git? So if the interviewer asks you this question, you can answer the major advantages of using Git are data redundancy and replication. Then we have high availability. Then we can discuss of only one Git directory per repository. Moving ahead, you can say something like this: there is a superior disk utilization and network performance. It is collaboration friendly, and finally, it can be used for any sorts of projects. I hope so it's clear to you what are the advantages of using Git. Now let's move forward and discuss the next question. The question is, are Git fetch and git pull the same? This is one of the most important questions which is asked in DevOps. So you can answer something like this. The command git pull pulls any new commits from a branch from the central repository and then updates the target branch in the local repository. But git fetch is slightly different from git pull. Unlike git pull, it pulls all new commits from the desired branch and then stores them in a new branch in the local repository. In order to reflect these changes in your target branch, git fetch must be followed with git merge. The target branch will only be updated after merging with the fetch branch, where we performed the git fetch. We can also interpret the whole thing with an equation something like this, where git pull equals to git fetch plus git merge. I hope so it is clear to you what is the major difference between git pull and git merge. Now let's move forward and discuss the next question. The next question is, what are the benefits of using version control? And you can answer something like this. The major benefits of using version control are that it helps to improve the collaborative work culture, which means that the team members are allowed to work freely on any file at any time. The version control system allows us to merge all changes into common version. The next advantage is that it keeps different versions of code files securely, where all the previous versions and variants of code files are neatly packed up inside the version control system. Then it understands what happened. Every time we save a new version of our project, the version control system asks us to provide a short description of what was changed. More than it allows us to see what changes were made in the file content, as well as who has made those changes. The next advantage is it keeps the backup. It is a distributed version control system like Git, which allows all team members to have complete history of the project file, so that in case there is a breakdown in the central server, they can use of their any teammate's local Git repository. The next question is, how do you handle the merge conflicts in Git? The answer to the same question is, in order to resolve the merge conflicts in Git, we need to follow these three fundamental steps, and these are: understand first what has happened. It could be because of the same line edit on the same file, or also it could be because of deleting some files, or it could be because of files with the same file names. You can check everything by using the git status. Then mark and clean up the conflict. When we open the files using the merge tool, git marks conflicts the area like this. Then it performs the commit again and then merge the current branch with the master branch. I hope so it's clear to you how you can handle merge conflicts in Git. The next question is, can you tell me some advantages of forking workflow over the other Git flows? And the answer to the same question is, forking workflow is fundamentally different from the other Git workflows. Instead of using a single server-side repository to act as a central code base, forking workflow gives every developer their own server-side repositories. This workflow is most often seen in the public open source projects. The main advantage is that contributions can be integrated without the need for everyone to push a single central repository to maintain a clean project history. Developers can push their own server-side repositories, and only the project maintainer will push to the official repository. As soon as developers are ready to publish their local commits, they will push their commits to their own public repositories. Then they will perform a pull request from the main repository, which notifies the project maintainer that an update is ready to be integrated. I hope so it's clear to you what are the advantages of forking workflow with other Git workflows. Now let's move forward and discuss the next question. The next question is, when do you use Git rebase instead of Git merge? The answer to the same question is, both Git rebase and Git merge commands are designed to integrate changes from one branch to the another branch, just that they just do it in different ways. When we perform the rebase a feature of branch onto the master branch, we move the base branch of a feature branch to the master's branch endpoint. By performing a merge, we take the contents of the feature branch and integrate them with the master branch. As a result, only a master branch is changed, but the feature branch history remains the same. Merging adds new commit to your history. Rebasing will create inconsistent repositories. For individuals, rebasing makes a lot of sense. Now, in order to see the history completely, the same way as it happened, we should use merge. Merge preserves history, whereas rebase rewrites it. I hope so it's clear to you when do you use git rebase instead of git merge. The next question is kind of interesting, and interviewers can also give you scenario type questions. Suppose he says, if I want to move or copy Jenkins from one server to the another, is it possible or not? You can answer something like this. Firstly, I would suggest copying the Jenkins jobs directory from old server to the new one. Then we can move a job from one installation of Jenkins to the another just by copying the corresponding job directory. Or also we can make a copy of an existing Jenkins job by making a clone of that job directory in a different name. Another way is that we can rename an existing job by renaming the directory. But if you change the name of a job, you will need to change any other job that tries to call the renamed job. In this way, you can move or copy the Jenkins from one server to the another, and which forms the perfect answer to this question. Now let's move forward and discuss the next question. Now let's discuss the next question. An interviewer can ask you something like this. Can you tell me what continuous testing and automation testing are? And you can answer something like this. Automation testing, as the name suggests, is a process of automating the manual process of testing. It involves the use of separate testing tools that lets developers to create test scripts that can be executed repeatedly without any manual intervention. Whereas the continuous testing is nothing but the process of executing the automated tests as a part of the software delivery pipeline in DevOps. In this process, each build is tested continuously, allowing the development team to get fast business feedback so that it can prevent the problems from progressing to the next stage of software delivery lifecycle. This will dramatically speed up a developer's workflow. He or she no longer needs to manually rebuild the project and rerun all the tests after making the changes. I hope so it's clear to you what is continuous testing and automation testing. You can answer something like this. An interviewer will definitely get impressed. Now, let's move forward and discuss the next question. The next question is, are there any technical challenges with Selenium? So, you can answer something like this, that there are certain challenges with the Selenium, such as it supports only web-based application, it does not support the bitmap comparison, no vendor support is available for Selenium as compared to the commercial tools like HPUFT, and finally, there is no object repository concept. Maintainability of objects becomes very complex. So these are kind of technical challenges with the Selenium. I hope so it's clear to you. Now let's move forward and discuss the next question. The next question is, when should you use Selenium Grid? And the answer to the same question is, it can be used to execute the same or different test scripts on multiple platforms and browsers concurrently in order to achieve distributed test execution. It allows testing under different environments, remarkably saving the execution time. I hope so it's clear to you. In this scenario, you can use the Selenium Grid. Now let's move forward and discuss the next question. The next question is, how will you secure Jenkins? If the interviewer asks you this question, you can answer something like this. The way to secure Jenkins is as follows. First, ensure that the global security is on. Then, check whether Jenkins is integrated with the company's user directory with an appropriate plugin. Then, you can say something like this. It also makes sure that the project matrix is enabled to fine-tune the access. Then, you can automate the process of setting rights or privileges in Jenkins with custom version control script. Then, you can limit the physical access to the Jenkins data or folder. And finally, you can also periodically run the security audits. I hope so it's clear to you how you can secure the Jenkins. Now let's move forward and discuss the next question. The next question is, how to create backup and copy in Jenkins. So, if the interviewer asks you this question, you can answer something like this. To create a backup, all we need to do is periodically back up your Jenkins home directory. This contains all of the build configurations of our job, our slave node configuration, and our build history. To create backup of our Jenkins setup, just copy this directory. We can also copy a job directory to clone or replicate job or rename the directory. I hope so it's clear to you how you can create backup and copy in Jenkins. Now let's move forward and discuss the next question. The next question is, what is Jenkins pipeline and CI/CD? The answer to the same question is, Jenkins pipeline can be defined as a suite of plugins supporting both implementation and integration of Jenkins continuous delivery pipeline, whereas CI/CD or continuous integration or continuous delivery pipeline consists of build, deploy, test and release. The pipeline feature is very time saving. In other words, pipeline is a group of build jobs that are chained and integrated in a sequence. I hope so it's clear to you what is Jenkins pipeline and CI/CD. Now let's move forward and discuss the next question. The next question is, what are Puppet manifests? So this is one of the most important interview questions which can be asked by the interviewer, and you can answer something like this. Every Puppet node or Puppet agent has got its configuration details in Puppet master, which is written in native Puppet language. These details are written in a language that Puppet can understand and termed as Puppet manifests. These manifests are composed of Puppet codes and their file name uses the .ppp extension. For instance, we can write a manifest file in Puppet master that creates a file and installs Apache on the Puppet agents or slaves that are connected to the Puppet master, which forms the Puppet manifest. I hope so it's clear to you what exactly is Puppet manifest. Now let's move forward and discuss the next question. The next question is, how can I configure systems with Puppet? This is also one of the most important interview questions, and you can answer something like this. In order to configure systems with Puppet in a client or server architecture, we have to use the Puppet agent and the Puppet master application. In a standalone architecture, we have to use Puppet apply application. I hope so it's clear to you how you can configure systems with Puppet. Now let's move forward and discuss the next question. Now let's discuss the next question. It is also an interesting question, and the question is, what is Puppet code dir is? So if the interviewer asks you this question, you can answer something like this. It is a main directory for code and data in the Puppet. It consists of environments containing manifests and modules, a global modules directory for all environments and your hero data. The next question is, name some of the most important DevOps tools. So the answer to the same question is, the list of important DevOps tools are Git, Maven, Selenium, Jenkins, Docker and Puppet. This is one of the most important questions. An interviewer is definitely going to ask you this one. So be aware of it about some of the most important DevOps tools. Now let's move forward and discuss the next question. Now let's discuss the next question. And the question is, how does Ansible work? This is also one of the most important questions which can be asked by the interviewer, and it can be on any tool which you are comfortable with. So here I have chosen Ansible, and you can answer something like this. Ansible is an open source automation tool which is categorized basically into two types of servers. The first is controlling machines and second is nodes. Ansible will be installed on the controlling machine, and using that machine nodes are managed with the help of SSH nodes. Locations are specified by inventories in that controlling machine. Since Ansible is an agentless tool, it doesn't require any mandatory installations on the remote nodes. So there is no need of background programs to be executed while it is managing any nodes. Ansible can also handle a lot of nodes from single system over an SSH connection with the help of Ansible playbooks. Playbooks are capable of performing multiple tasks, and they are in YML file format. So this forms a perfect answer to this question. Now let's move forward and discuss the next question. The next question is, why should I use Ansible? If the interviewer asks you this question, you can answer that Ansible can help in configuration management, application deployment, and task automation. That's why I'll prefer to choose Ansible. This forms the perfect answer to this question. Now let's move forward and discuss the next question. The next question is, what are handlers in Ansible? This is one of the most important questions, and you can answer something like this, that handlers in Ansible are just like regular tasks inside an Ansible playbook, but they are only run if the task contains a notify directive. Handlers are triggered when it is called by the another task. I hope so it's clear to you what is handlers in Ansible. Now let's move forward and discuss the next question. The next question is, can you tell me the purpose of SSH? So if the interviewer asks you this question, you can answer something like this. SSH is nothing but a secure shell that allows users to log in with secure and encrypted mechanism into remote computers. It is used for encrypted communications between two hosts on unsafe network. It supports tunneling, forwarding TCP, and also transferring files. I hope so it's clear to you. It is one of the most important questions which can be asked by the interviewer. Now let's move forward and discuss the next question. The next question is, what is an RPE in Nagios? So if the interviewer asks you this question, you can answer something like this. NRPE stands for Nagios Remote Plugin Executor. As the name suggests, it allows you to execute Nagios plugins remotely on any other Linux or Unix machines. If I talk about Nagios, it can be helpful in monitoring remote machine performances metrics such as disk usage, CPU load, etc. It can communicate with some of the Windows agents add-ons. We can execute scripts and check metrics on remote Windows machines as well. I hope so it's clear to you what is NRPE in Nagios. Now let's move forward and discuss the next question. Now let's discuss our final question, and this is, what is Nagios log server? So if the interviewer asks you this question, you can answer something like this. Nagios log server simplifies the process of searching the log data. Nagios log server is the best choice to perform tasks such as setting up alerts, notifying when potential threats arise, simply querying the log data, and quickly auditing any system. With Nagios log server, we can get all of our log data in one location with high availability. So this defines the Nagios log server. I hope so it's clear to you what's the answer of this question. So this was our final interview question.
Just a quick info guys, if you want to make a career in cloud computing, then Intellipaat provides an advanced certification on cloud and DevOps by IIT Madras. This course is taught by industry experts and IIT Madras faculty. This course is designed to upskill and land your dream job. Now let's continue with the session.